Hello, hey there, I'm Cyberchroma. Alright, we are continuing with all of this stuff that we've been doing. Alright, let's get the music started. Sure. Still figuring out audio levels with that, but that's probably fine. Also, I temporarily got new headphones. I got like the cheapest things I could find for now until the new headphones I actually ordered arrive, because I can keep going with this thing, but prefer not to. And then a while back I got these, but these have a really terrible battery life. So yeah. Oh, what just happened? Okay. Don't know if that came across in OBS, but things have changed? No. It sounded like just audio changing sources or something, I don't know. Anywho though, actually, I have a better idea. Hold up. It's like no one here yet. I can continue to set up. We're gonna be continuing this project today. Why don't I said these have bad battery life, well I don't use them, but I can use them as long as they're not dead, so I will switch back and forth, but I will make these work as I can until I get my new headphones. Those were $12, so still, yeah, not great, but headphones I'm gonna be getting off Amazon. Might still keep getting delayed. Yeah, I don't know when they'll get here, but might be another week or two. Unfortunately, you know, supposed to be like yesterday, but whatever. Anyways, so I actually don't know if different audio sources and having different quality. I don't know how that comes across in OBS or not. Yeah. Whatever. Anyways, so continuing where we left off from yesterday. Yeah, we run this and show off what we've done. Is this fine? Yeah, okay. Okay, separating these out. So this is what we've managed to do. Where doing linear regression was all of this, and now we're about to be doing polynomial regression. Okay, it's nice being able to lean back. With those I can't, because they're... I kind of also made that mistake where they're wired. It's like, oh wait, the length of this is actually a problem that I did not consider. Oh well, anyways, so the first part of this was doing linear regression of, or no, this is the linear regression, but the first part of this was just drawing our initial data sets. This is the test data, this is the training data, whoop-de-doo. And then we did basically a line of best fit. It doesn't really match because it's a line of best fit on data that is not meant to be linear, but that's just part of what this was. We're going to be making it better eventually. So then we had to take the same line and draw it on the test data. It was like, oh, look how similar it is. How does this compare to this? Which, yeah, it's fine. Yeah, perfect. So now what our job is to repeat this, but with a basically a quadratic function, a second order polynomial regression. And then we're doing a third order polynomial regression and a fourth order polynomial regression and comparing them all to each other. Now, just looking at this looks like a third order polynomial regression, so a kind of line will be what fits this best. I don't think the fourth one will do anything meaningful. In fact, if anything, it might make it a bit worse. Looks like, I don't know. But no, it looks like, yeah, third order will be what we want here. Yeah. So I don't actually know how this works in terms of how we take this line of best fit and turn it into a quadratic thing, but we shall figure that out. Especially because I don't know what sort of like, are we just gonna take the I don't know what form of equation we're going to be making, like vertex form, standard form, root form. Is that what that one's called? The one with the roots. But yeah, I don't know. We're going to figure that out. If I had to guess, probably, I don't know, standard form? which usually is like the least useful one, but I don't know, maybe I'll be wrong. Okay, so mainly it having an a value. Well, no, they all have an a value, but an a value and then like a y-intercept and the b value, which usually is hard to compute for humans, but for a computer it's probably no problem at all. So our first stage here is, please double check that I'm about to be doing the thing that I'm supposed to be doing. Oh, right, okay. Implement second order polynomial regression by adding new features x squared to the inputs. Then repeat earlier stuff. Okay. Repeat these these two parts, blah and blah, as well as reporting the errors on both of them. Yep, because again, our goal is to get this as low as it can be. And so we're doing different things to make that happen. And that's a good, this gives us a good idea as to, yeah, how close this line is to matching our data set. In the super best case scenario, it would be a perfect 0, but that's not really going to happen. Now, perfect 0 would just be like a connect the dots kind of thing, but somehow it would also work with anything in between that makes these dots. But yeah, just having a line that kind of goes like woo will be probably our best bet, right? So that's what we're going towards. So let me start by making some new functions to kind of separate the different parts of what we're doing. Okay, so especially actually if we're going to then be repeating parts, kind of, sort of. Yeah. It's all of this that I think I want. I'm going to be adding a new thing to the feature set, so... Oh. I think, yeah, this part's going to get copied over too. And I'm probably going to want to... Just deciding. Do I want to... I have two options here. So I'm done with this data for the linear stuff. If I want to then calculate the features for the second order polynomial, do I want to reuse these variables, or do I want to make new ones? I think for now I will actually just reuse them, because it's like I don't need to keep storing that data anymore. They're done for. Right? Just double checking. I don't need any of those. I don't need those numbers again once I'm done. Okay. So let me start then by copying all of this. Nope, I need to go higher. Okay. Not the graphing the starting data, though. Yes. Isn't it usually a thing we put 2 spaces in between? Something like that. Okay. Then I'm just going to put a lot of space just so I can easily tell what I've just pasted in and everything else. Okay. And as well as renaming that function, and now we're going to have the same things. Now, I don't want to just say polynomial because we're going to do second order polynomial, third order, fourth order, and I'll keep those to their own sections. Maybe there might be something in there where I can reuse code with similar inputs, but for now, I'm just going to keep them completely separate, just so it's easier to see. Even, again, some parts I might be able to copy and then put into their own functions. At the very least, I'll do linear and second order polynomial. I'll do them completely separately. If they have similarities, then maybe I'll combine them, but just be able to mess with one and not mess up the others. Right. Okay, so this is going to be poly 2. Okay, so and then poly 3, poly 4. I don't know if I like how I swap what sides these are on. No, I'm gonna make it consistent. If I don't do it now, I'll do more renaming later. But I'll just do it to all of these now. Right. And of course, I still have to actually make these functions. But let me rename what's up top first. Oh, to make these consistent, it means I'm also gonna do this. Yep. Okay. Wait a minute. Why does this still say 0? I'm watching myself on my phone, so it shouldn't be able to be saying 0. It's not updating. Why is that? I can see my stream stats say 1, so can I get that to update, please? I am streaming, right? Yes. Well, that's odd. If I like change scenes, will that do anything that might make it update? No. That's concerning. What updates this again? One moment. Ooh. Ah, no, wait, that ruined a thing. Oh, no. That wasn't supposed to happen. Can I cancel? It got rid of the little bit of an outline I have just to make it easier to see. Ah, no. Why do you have a bit of a scroll bar thing in there now? No! What did I do? Well, that's unfortunate. If I go to other sides, it's all messed up now. No, what did I do? Oh, when did I mute my desktop audio? That's okay. I don't remember what I did when I initially set this up, but I do have the followers text to use. Oh, I did the outline differently in that. Ah, no. Well, let me figure out this real quick. Okay, how did I do this before? Something in this. Margin. I see text shadow, which would imply that we would maybe be using this. What did I do? I just refresh cache of current page. Why would that get rid of the outline? And why did it do this? Again, I say, what did I do? So this is through Streamlabs that does stuff with making that happen. Okay. That's where I follow the count. How did I do? How did I do this? This is a separate thing. Hold on. Yeah. Let me figure this out. Oh! Hey! Okay, it's updating now, but it still is cropped weirdly. Very bizarre. Very strange. So I could manually crop it, but I'd have to manually crop it in every scene, and I shouldn't have to do that. I also have to figure out how to bring back the outline, and I do not understand CSS enough. What did I do before? Okay, I have an idea, I have a plan. If I look at the CSS that's on my chat right now, I know there's a part of here where I modified this to add in an outline, and I think it was the same sort of thing. The follower outline is different, but this, okay, there's something in here. This text shadow thing, I would think. But no, but like this is in the other thing, and it wouldn't need to be all of this. Let me just have a quick scan for anything else that might be useful. Badge, margin. I don't remember what margin does. let's see. If I refresh it again. Nope. Why? What are my overflow options? Okay, if I get rid of this, hit OK. Do it again. Paste this in. Paste this in here. Still not updating. Oh. Okay, wait, no, it did. Okay, partially. Okay. Interesting. It still has, It still has the thing on the side. I don't have to, like, crop that for each scene. I should be able to fix itself automatically would be nice. Can I not do that? If I change the width. That made it worse. Okay, so what about increasing the width? Why do you only apply when I hit OK, but I also can't see the OK button when I have it on the other screen because it's so tiny? That didn't help. Well, okay, just because I need to make it taller instead. Wrong button. We'll continue with the stream proper in a minute. Just some technical difficulties here. How about that? Oh, I can just hit enter. Oh, that's better. Okay, there, fixed. You all sorted out? Just going between some of my scenes. Yeah, you're good. We're good now. Okay. Perfect. Okay, technical difficulties sorted out. Let's get back to things. Don't know how that happens, and whatever, it's fine. Okay. Where were we? Linear regression. So I just renamed some functions, and I need to rename them again in the actual thing. Yeah. So that's gonna be just everywhere I have linear. Reword it. Okay. Cool. So now these are the ones that need to be renamed entirely. The functions are going to change. Let me just kind of copy what I have down here is to have it be the same. Okay. And I don't know what happened with the spacing there, but let's keep it consistent at 2 between each thing, because apparently that's how I decided to do this. Okay. Just gotta find what it is that I'm looking for. Almost there. Also, I might not actually need this part. I thought I might, but I don't know. We're gonna see. Okay, cool. All this exists now. Let's not get ahead of ourselves, and I don't want to. There's about to be like a waterfall effect of. I change one thing up here, it's gonna break something down here. I need to make sure to do this one at a time. Actually, why don't I just comment at the functions? Yeah, do this one at a time. I just wanted them, the structure of them to be there, right? Okay, so starting at calculating the features for the second order polynomial thing. So this is going to be. So I need to add the feature that is x squared, which is going to be training data squared. I need to add that into as a feature. Now, does that replace the linear, or is that in addition? I don't know. I'm going to do it as, I'll just add it as another column to start. I don't know if the order matters, like if it should be. Oh yeah, I think the order should be x squared, 1's column. I think that's how it's supposed to be. As opposed to x, 1's column, x squared. Yeah. So this is what I use for the ones, which I'm making them again. I don't know if I should be doing that with the way that I'm sort of copying this. Just to have good practices early on and not reuse code, I guess. Technically, this should be like before this. Also missing an equal sign there, bud. Okay, blah, blah, blah. This, do this. So I've only calculated that one thing a single time. I don't need to calculate it again here, because it's going to be the exact same. Okay, so now the training data features. Features going to be of size 3. So this will be this amount plus 1 to start. If I want to eventually turn this into, rather than, like, you'll reuse code between all the different, orders, but for now I'm going to just hard code it kind of being the same, or like being completely separate code, and then combine it if I can. Okay. Wait, hold on. Now this is going to need to be this times 2. Not times 2, like squared, so times itself. This many times. And then the same thing's gonna go on over here. Where this is gonna be, again, multiplying itself. Whoops, if I can highlight the right thing there. Okay. Did those things. Yeah, that should be our features. Good and calculated. I don't think I really need to test that, but I should. Just does the code run still? Yeah. Yeah. I see error, I'm like, oh no, but it's like, no, that's an error amount I'm intending to print out. Now let me do one thing where I'm actually just gonna take this out. I'm also just going to separate these kind of with just an empty print statement. Just print nothing. Actually, if I do print new line character, that would do a double new line, I think. So yeah, keep it as is. Just to separate these chunks. Nothing gets printed here, so that's fine. That's just the initial stuff. Okay. So now. Okay, next bit. Let me make sure to uncomment the functions before I'm like, oh, why isn't it running? I literally did that last stream with this project, so not do it again. So does it doesn't just work like this, does it? No. Wait. So the wait, I'm getting the weights. If I calculate the weights now, does this give me an ABC value? Is that how this works? Because before I got a slope and a y-intercept as an M and a B. I mean, the letters themselves are arbitrary, but in terms of how they flip over, the A value is kind of like the M value, and the C value is the same C value, or B, or the y-intercepts are the same. The only new thing would be that middle B value, which maybe this is something that is now, it just works, calculates. That'd be cool. Let me start by just seeing what these weights are. If it's 3, that's a good sign. A, okay, that's a good sign. It being negative, I would like to assume is going to be fine. Here, let's pull out Desmos. What am I doing? No, I don't. I was going to say I'm going to pull out Desmos to like just see what the graph of this kind of thing looks like, but I'll just keep going, draw the line, and it'll be fine. I'm expecting a quadratic line that's going to do this, right? So, oh, that's not going to happen with these numbers, right? Because an A value needs to be negative for that to happen. Unless it's not going to... Unless it's going to try and do a quadratic line like this, that's a quadratic line at best fit, and fail miserably at that. Well, let's just see what happens. Maybe I need to change the calculation. I'm just going to kind of see what happens if I don't. if I do need to change them, I don't know how I need to change them. So let's just hope that this works. First try. Okay, so now what I need to change is... And also, another thing is that maybe it'll work if I swap some numbers around. So I can totally play with that, too. Okay. So, we got the two things that we're graphing. Now, this is the line. Right, I just realized I don't know how to actually implement these numbers properly. Like, how do I actually turn this into a proper equation? So I imagine, well, cause, wait. So, yeah, I don't know what equation form I'm putting this in. I'm gonna guess ax squared, oh, actually, okay, that doesn't maybe answer my question. Ax squared plus bx plus c. So, if this is a times, well, this squared, which it could be this times itself, but I have this as something I've calculated up here, so I'll just use that. In the one column, not the one. There's a column of all ones. That's not the one column I'm referring to here. The column that is the second column of the array. That is the squared values plus. Actually, I'm just gonna apply it onto here. Yeah. This is gonna be 0 because it's sort of going backwards. The way I currently have it. Oh, that's another thing I didn't even consider, is that I could also mess with the ordering of the features. Just kind of see, like, just try things and see what works. Because it might just be a matter of, like, having the x squared x and then the final thing. Like, the column of ones. We'll see. We shall see. But let's finish this off here by just then the last putting in a good old y-intercept. And let's just cross our fingers and see if it works. No, wait, gotta uncomment the function, right? Oh, that's for this one. I'll just get this one working first, and I'll worry about the test one after. Errors! Yeah, exactly what we wanted. No. Okay. So, now we gotta figure out why and where. Alright. Where are we looking at? So, so x and y must have the same dimensions, but have shapes 40, blah, and 3, blah. Okay, so there's some discrepancy here. Fine. But where? So it wasn't calling this function. Is it in the plotting thing? Is it in this line? I can double check by commenting this out, running it. If it gets to that point of code, good. Oh, right. I have to uncomment out this so it'll actually show the graph. But yeah, okay, so I was right on the money. So currently, yeah, this is just drawing the same line as this one, just without the line. We're doing the same scatter plot, is what I mean. Okay, so now we gotta get to do what it's supposed to do. Okay. But why is this not? Does this need to be transposed? Is that how this works? Let me print some things. Let me double check that numbers are what I think they are, and do it without things erroring in my face. Prior to that first thing, does it just print out anything without giving me errors? That's this. That's a size 3. That's wrong. I should be having something that's of size 40, so I'm definitely doing something wrong here. If I do just this part, does this need to be transposed? I think that's the case. Wait, why did this need to be transposed and the other one didn't? I'm sure there's some reason for it. So I go .t1. There we go. That, I think, makes more sense. So this is a list of all the squared numbers. Whereas, just to double check that my rationale here is right. Hold on. Okay, so this should be all the squared numbers, these should be all the regular numbers, and these should be all a bunch of ones. correct. There we go. Okay. I don't know how a 1's becoming a 3. There's something funky there. Like, these are definitely not these numbers squared, but how and why? Why is the spacing on these ones weird and these ones aren't? I don't understand. Well, let me just, for the minute, just kind of ignore that and just kind of put in the .t everywhere and just kind of see what happens. Because we should at least get a graph. This makes me think that the graph is going to be wildly wrong, but let's see if it at least gives us a graph. Maybe I'll be surprised. Oh, right, to close the old graphs for the new ones to show up. Well, okay. We got a graph. Okay, so before I go any further, let me just, yeah, I don't believe that, so going like top down, right? Like the first thing that seems maybe be wrong is that the, where is it? The features, I maybe I'm not calculating them right. Or maybe I need to transpose the stuff here, I don't know. Let me just, at, this stage, because also I'm not using these numbers yet, I'm just looking at these numbers right now. But I should be doing the same thing here, down here, effectively. So, didn't error, so I think that's, seems good. Let's start by, just print out the whole thing and see if I can piece together anything. Because maybe the numbers are right here and somehow I mess them up later on. Okay, 3 squared is not 11. Again, these columns, all these numbers should be these numbers squared. And that's all. But they're not. So why is that happening? Just to start. Just going, yeah, the 3 times 3 is 9, not 11. But what's going on here? Some recursive thing happening? Like, I can print out this number. Like, let me just make sure, I don't know, this is printing out what I think it is or something. Oh, right, it's all decimals. Oh, right. Is that actually gonna make a difference? Maybe it will, actually. Maybe the numbers are fine. Can I? This doesn't work this way, right? Because this ain't no C#. That's fine. Let me just see that specifically that third number is something that can conceivably go to 11. Is that this number? 3.44? Yeah, okay. I guess that makes sense. So it's a rounding thing. When it prints the arrays, it just has to move. Okay. Fair enough. So my second idea... okay, so one idea that I have that was something I had in the back of my mind when I was doing these linear lines, but I'm now realizing might be more of a problem, is that this line isn't being drawn like left to right. So neither would this polygraphic, neither would this polynomial line. Instead, it's going like back and forth, back and forth, back and forth, which is fine. It's kind of covered up by the fact that it was a linear line. But here, yeah, it's jumping all around the place. Where it's hard to tell what the line's actually looking like. In fact, as a test, just to see something, I want to see what this looks like as a scatter plot. Then I can't control the color of it. Or maybe I can, but I haven't learned how to, and I don't need to. So they draw just that one, which again means I have to close these. because that like halts the program and doesn't allow it to like restart. Huh. Okay, so right away this is not correct for this polynomial line because it should be, you know, more of a wow sloped. But alas, beyond this, there's more problems. Even if I can get this to be correct, it'll still have the back and forth problem. So I'm gonna try solving that first. And I need to solve it before I do the linear line. So I think what I want to do is just sort the data. Import it. Do I sort it before graphing it? Yeah. Yeah. Import it, sort it, graph it. Sure. Okay. So next, so how are we going to sort the data? I'm going to sort both the test data and the training data. I guess I don't know if I actually need to sort the test data in theory, but I will. And I don't need to just sort it. I need to sort it so that like these go with them, which like these stay in the same like relative thing. Like, you know, this is the input where this is the output. I need to make sure that doesn't change. So off the top of my head, how do you do that in Python? I can think of ways of doing it in C#. Let's find out. Instead of trying to reinvent the wheel. I know quicksort is a thing, but that seems like it may be problematic in this case for how I deal with the second column. Python, 2 lists based on 1, sure. Okay, yeah, zip. Zip the 2 lists. Just zip 2. Again, I don't like to just blindly copy things from Stack Overflow. Yeah. Iterate over several items in parallel. Oh, tuples of each item. Oh, okay. Yeah, sure. Create a new sorted list based on the zip using sorted. Sure. Using a list comprehension. Extract the first element to care from the sorted zip list. Okay, yeah. Except, wait, no, hold on. This just gives me this one sorted. I need to end up having both sorted. This is very, very close and probably be something in the ballpark of what I want, but... Okay, if I had this, then I could keep them as tuples, in theory. I prefer not to, though. I prefer to kind of stick them back in their original arrays, just sorted. And like they are numpy arrays already, so I mean I could use something like this as well. Arg sort. Okay, I'll just go back to the first thing, which was this, which I'll grab this version. Which is like fine, but there's just like one missing piece of that, of what I need for my particular scenario. So in this case, we're looking at, this sorted, where this is this. No, this is going to be backwards. Hold on. No, this is different than what I'm doing, kind of. I need, so rather than being like, sort second thing, sort first thing the same way, which is kind of what I'm doing, I need to sort the first thing and sort the second thing in the same way, which would just be swapping these values, right? I actually don't know how these matter, but I do need to swap this. And will this be giving me, this would give me the input sorted, right? Let me double check. Just to start off. I said to start off. Okay. Ah, right, all these numbers I'm printing. Hold on, I need to print less of them. Am I even calling the function? I am, yeah, okay. I'll leave the average error lines, but just, I think I have some other print statements somewhere. I mean, yeah, whatever's printing out all this that I don't want for right now. Where'd you go? Why can't I find it? There you are. I'm fine just deleting that entirely. Yeah. Yep. Okay. Yeah. So is that gonna, can I just see the numbers I'm caring about? Yeah. So that's this, which, oh, right. I don't know if this is the input data or the output data. Going from, oh wait, this isn't sorted. It's not completely sorted. What's this? Yeah. Why would that do that? Where are the decimals wrong? It's like almost sorted, but not. Unless, unless this is the output data. X for... Yeah, this should be... Okay, either way, I was going to need to change this anyways. Because I need both. Look for something. So yeah, it's not this. This is not what I want. I want actually the opposite of that, but still get both. Together. Yeah, this is what I want. Yeah. Okay. Perfect. That I will take. Easily remedied. Does it matter whether or not they're lists or not? Oh, they're gonna be tuples instead of lists, which I guess, yeah, I don't know if that's gonna be a problem or not. Alright, let's try this out. This going into... I'm gonna dump it in, like, new values for now, and if it works, then I'll just dump it into the old values. See how that goes. Getting rid of that then. Just print one of them for right now. I mean, yeah, of course it's not defined. Oh wait, where the input is this, output's this, and again, if it works for the training things, and then that's all good, I can copy it for the test data. Okay, ignore all of that. Okay, that looks reasonable. Perfect. That's my going live notification. Huh. Okay. Oh, why do you think you're... Oh, because I don't use it. Yeah. Let's do that. Just double check that this one's also good. Oop. That's not what I wanted. Yep. We're good. So, yeah, for the record, this list could be sorted. It doesn't have to be. Oh, this is what was printing before. Oh, okay, got it. That's why the numbers, like, mostly go up, because that's what the data does, but it doesn't necessarily. Perfect. Okay, so with that in mind, so this is working now. Again, I'm just gonna dump this back into the non-sorted things. Like it's gonna be a feedback loop, but on purpose. What are you doing? Oh. Do you not like this? Need this to work properly? Okay. And actually, you're gonna need this too. Okay. And then I need to copy this for the test data. Then we'll be in business for better lines, I guess. Oh, missed one. Yes. So now running the other parts, I should see... Oh, errors. That's a problem. Why? Excuse me? Wait, so... Okay, just to double check, if I comment this out, it runs... Okay. So something's changing with, I would assume, the data types of these things. It's something probably with the data type I'm trying to turn it into. I had to guess. Maybe this will work if I... Because that's what it's meant to be. Please? Yes! Perfect. Yeah. Do I still call you T? I don't know, it'll be N, I guess. For NumPy. I was gonna go A for array, but that felt too generic. So now this, yeah, this looks more thin, or it looks more uniform in length. Yeah. Not in length this way, in terms of, like, width. Yeah. Okay, perfect. So now, if I go back to our quadratic line that is somewhere here. Turn this back into a plot. That is red. It's still not going to be what we want, but hopefully it'll be better. Okay, that's... Interesting. Fascinating results. So for the record, I believe we're trying to get something that's going to be kind of like, something that's going to do its best to kind of, I imagine it will kind of go up along this and then kind of fade out as it goes along here. That's my theory. Or it could go like, maybe. I'm not sure. We'll see. But it shouldn't be this. So I have one idea for something to try out, which is just, before when I was doing this, we found a function that automatically did linear regression for me. I didn't keep that code, like an idiot. Oops, yeah. So I could try to Google some things to find that then. Python. Oops. Did it not keep it around? Python polynomial regression. Oh yeah, this kind of thing. Except right now we're sticking to quadratic. So hopefully I can find something that like I can feed in what the order should be. Oh. Wait. 1D. Or, okay. Oh, one-dimensional? Or, I don't know. I'm gonna hope this 3 is what's making it which is eventually what I'm gonna want. So what does this spit out? I'm wanting to just know what is coming out of this. Like what like numbers am I getting from here? Okay, let me put this over here. Okay. So we're also, again, not worrying about this right now. In fact, let me just kind of do a little bit of... once this works, we'll be doing kind of the same thing down here. And I'm going to be messing with these values even more momentarily. Okay. So, where are you? So yeah, this is what we're graphing. It's not graphing the right thing currently. So let me do this. And we're going to have this one be green compared to this one that's going to be, the proper one's going to be red. But it's like an error amount, so that's why I'm making it red. I don't know, whatever. Or, no, this will be red and this will be green for now. Say, like, this is the right one. I guess it doesn't really matter. Anyways. Okay, so polyfit. I'm starting, I think the X is going to be this amount. The Y is going to be the output. Yeah. It's just, yeah, from this. I'm pretty sure this is like the degree of correctness, so I'll just leave it as 3 for now. In a minute, I think I'll want it to be 2, but I'll just leave it how it is for now. So my model, I just want to see what this is. What kind of numbers is this spitting out? Because apparently, not there. Apparently, how I do this is, what? Hold on. Start the X and the Y model. Well, this does this, but surely I make this somehow be different compared to how I'm doing things. And okay, this was after, but whatever. Okay, so 1 second. Also curious of what this actually is exactly printing. It's an array of some kind, but... so then the plotting is not going to be all of this stuff. It's going to be... this. Wait, so is this x values, which I replace with this in a minute, and this is going to be y values based on these x values? Is that how this currently is? Let's find out. In a minute. Fascinating. Okay, interesting. So first of all, again, so as I predicted, the 3, it's making it like this, except the numbers just aren't right. So first of all, let me have that be, make the line space what it should be, which, so these are basically my x values, I think. So I'm just gonna stick in this. And I shouldn't need this part, right? Oh, I didn't even look at what it was printing. I'll look at that in a second, but perfect. Okay. So this is what we're eventually gonna be having. Yeah. So we need to make this, except actually not entirely. I need this to be, I changed the order. I think 2 will make it quadratic. Right? Yeah, there we go. Okay. Oh, that actually makes more sense. I thought it would do like this, but actually this makes more sense. So this is what we're aiming to get. This is what our line should look like, which means that the a value should be negative, for one thing. Now, while we're here, I'm just curious what 4 will look like. Not much difference. I don't know if it's different at all. Or if it's just so non-noticeable. Now, I'm just curious if this can handle 1, if you'll draw a linear line. Oh. It did, okay. Just curious if it would. So we want this to be 2. This, my model thing, then. So this must be a bunch of... I don't know what this is, but I know that this is a bunch of x values, or y values. What the y values should be given these x values, I guess. But again, I need to calculate this manually, so that's what this assignment is. So... Oh! Interesting. That's fascinating. This 2 was something else, right? Or, I'm not sure, but we can see what these numbers are. So these are the numbers that I'm going for. And it is... Wait. Oh, it's... Oh, that's just the fancy way it's displaying it. That's interesting. I see what it's doing. I think this is actually meant to be an x squared. So this is the equation, and it is in standard form, which is what I thought. Cool. So now we have an idea of what we're calculating. So now I might try to fill with the numbers, but we are trying to get the weights array, which is of size 3. So that's like on the right track. We're trying to get it to have this negative 0.55, a 2.6, and a 2.7. That's what we're getting. If it's like, you know, a few decimals off, doesn't matter. That's totally fine. Okay, cool. Progress. And okay, yeah, okay. I'll still keep this around, but now if I go back up to the weights, let me print the weights again and just, yeah, see what we're currently looking at. How close are we? Completely off? Are the numbers just kind of in the wrong columns? That'd be great. Oh, of course. No. Okay. Oops. Yeah. So these numbers are completely off from these numbers. That is not a good sign, but I do notice if it has any significance, this one's negative, these 2 are positive, this one's negative, these 2 are positive. Don't know if that helps in any degree. So one thing I did that I didn't think I'd have to do was the fact that I had to transpose the training data features here, but I didn't have to transpose them for the linear one. That felt strange to me. So I'm curious of why that happened. Or like, I think there's something that went weird there. So first of all, if I printed out this, yeah, if I print that out, that's gonna be the first thing I see. Yeah, this is all of the, X values. Yeah, all the X values of our data set. Cool. Whereas down here, if I go to print this, what should be the same thing. Oh, it's not the same thing. Oh. You know what? I notice. One difference is that here, I just went straight to the source. I took directly from the test data input, where if I change this to that features array at element 0, which you should have a definition. Oh, well, hold on, I'm in the wrong place. But that still should have a definition, but I didn't change the thing I meant to change. Okay. I'm looking at the training data is the one I want to change. So again, this doesn't use this. But in theory, in concept, this should be the same array. But it's not, apparently. Yeah. But if I change this to a .t, then it is. And that goes back to the line 1. That's... Oh. Interesting. Because now this one's off. Huh. Why would that be? That's an issue. Why would... Because that should be the same array, and it's not. Okay, so there's problem number 1. So... Let me print these. If I take this and this, did it go .0.t or something? I don't know. Let me just print both of these so I can see them. Yeah. So one array was all this. The other array was all this. Now, oh, I was about to say that, like, oh, this is just the same. It's just these look rounded the way they're printed, but maybe they're not. Are these getting rounded for some reason? I think that's what's happening. Okay. Okay, that's why the calculations might be off, because it's getting rounded when it shouldn't be. That would make sense. Okay, so why is it getting rounded? Sorting the data didn't do that, I don't think, because this was happening before we sorted the numbers. Okay, so what did I do wrong up here? Let me go... And yeah, for the record, I could change this back to this and it would work for up here, but it won't work. I need the... I'd prefer if this was going off of this array, because then I'll make it consistent with what I have below when I get there. Okay. So let me go up and see... Right when I assign them, does it immediately become off? I mean, that would make sense. Yeah. Okay, question is, why? So this is, yeah, numpy to empty. I directly say, grab this thing and put it in here. So let me look at what value did I just put in there and what value is the, you know, get what both sides were. Because apparently there's something funky going on here. What are these two numbers? Excuse me? Why? Hold on. Okay, I have a theory. Does going numpy.empty set it up to store ints? It expects to have ints, so then it's truncating everything? Because it's not even rounding, it's truncating. Which means that just cuts off all the decimals. I don't even know. So what's the default then? If I want to just make an array that I will be filling in later, it would be .float. Oh, okay. I don't know which of these to do. I think it's float 16. I don't know. We're gonna see. Which that has to do with how many bits are being dealt with. How many bits are being allocated for each float. Did things do? I have to scroll down. Yes. Yeah. Okay. Takes one argument. Oh, okay. I'm an idiot. Okay, I had this here. That's why it's an int, because I'm specifically telling it to be an int. Ha! Okay, I guess I can go by just default float here. Wow, I can't believe I did that. Let me immediately fix it in the other place. Which is... where? Here. I did that ages ago and just wasn't even paying attention to that. Wow. Okay. Let's see if it just... Well, I won't delete that yet. Let's see if now it immediately goes to getting me the right numbers. Okay. Perfect. I mean, this is still wrong, but it's better. It looks like a quadratic function, which is a good sign. And then the linear lines, they're back to being how they should be. Good. Good. There was still the weirdness of how I had to transpose one but not the other. But I think I understand why, because this is just like a normal array, which is kind of going out, right? But yeah, with this I did it by column, so it just makes sense because it's going down. Makes sense. Yeah. Anyways, so with that being said, now this is correct. What I do still need to do though is make it correct on the test one. Just by doing this. Right? Double checking that I'm not missing anything. This doesn't need to be transposed? No? Okay. Get rid of some of these spaces. Okay. So now, these are floats. That should be good. Cool. Still's the wrong numbers, but like this is, you know, it's progress. Alright. Now it's got these in there. And yeah, I'll worry about the test one after, because... Oh. Uh-oh. Somebody thinks it has the shape of 20 and 40. Okay, oh, I know what I did. This test is not supposed to use the training data. Yeah, okay. Okay, back to sanity. So now, we're back to the problem we had before, where we have these numbers. They should perfectly match these numbers. And would you look at that, they do, they're just swapped. Haha! Okay. Perfect. Okay. Like, immediately I was like, hey, the Y's match. And then I'm like, wait, that one matches. Wait, that one matches too. Okay. Perfect. That's good. That's what we want. Now we just I gotta flip around. Now, yeah, I guess I'm flopping them here. Not what I was expecting for these to happen to match, but sure. Why not? Weird though, then. It went with the B value, the A value, and the C value. But it's doing it. Yeah! Woo! Okay. And I'm confident that it's like the red lines underneath, because it drew the red line first and then the green line. Yeah, and I can prove it by getting rid of this line. I thought that was going to take ages to do the polyline, but yeah. That's awesome. Wow, I'm surprised that it is working the way it is. Cool. Okay. Might be wrapping this up sooner than I thought. Okay. So I have to also I still have to report the average error. Oh, and I have to well, no, I do that, right? Let me get rid of this print that's not supposed to be there. I won't delete this yet because I'm totally going to use this for part 3. You know, I should have a handle on this now. What would be actually nice, though, is to... Would it be overkill to, like, turn this into a sort of... Or all of what just happens to draw the line, turn it into a thing where it's just like a, you know, one set of functions, but I put in, you know, input into the function that is the number. That'd be cool. We'll see. Yeah, anyways, okay, so... But, let's just finish this one off first. So we got this error amount, which, sure, it's less, and that's what we were going for. The fact that it was less than the linear version. Good thing. Is this one less too? It is! Because this wasn't even going off of what the line was doing. Oh. Because it was the training data thing being wrong. Fair enough. And that's why also that hypothesis thing from earlier, or yesterday, earlier today, because I was still streaming past midnight, that's why that was wrong too. Because it was getting flattened, because I just had the wrong thing in here. Poof. Very well then. Okay. I definitely don't need this anymore. I'm fine with that. Bring back the test thing, which is this. Bring back, have that be the only show that's there. By the end of this, I'll have each show thing be its own thing. But for now, just so it's easier to run, just having the one at the end. Simply enough. Okay. Oh, never mind. For a second, I thought this was the test one. It was using the training. No, it was doing what's supposed to do. So now I gotta make this kind of match that. I can get rid of these print statements. Move this. Move them together, actually. Move all 3 of these together. Yeah, I'm just gonna stick this in here. Are you fine? Yeah. Okay. So the rest of this is not completely the same, but this part will be, except replace, yeah, this, but replace training for test everywhere. Okay. This, blah. Right? Okay. I think we're good. Okay, I think we're good. Go. Oh. Interesting. Interesting results. I think it makes sense. but let me just, hold up. Putting these, oh, I'm not trying to do that. Yeah, display these all out nicely. Okay. So initial data, linear thing on the sample data, linear thing on the test data, and then quadratic on the this, and then quadratic on the training data, and then on the test data. Now, that's fascinating, but visually it makes sense that on the training data, this line is like, it does a decent job. But like the quadratic one definitely looks like it kind of covers more points on the training data. But on the test data, using the same lines, it does look like this is kind of closer to these points than this one is. Well, especially just how far these are off. This really causes a problem. Okay, actually it is close to some of these, but like definitely see some things that would be sort of skewing the data, which seems to lead. I didn't mistype something, did I? Still checking. This error amount is all I was saying, is that it goes up, which is interesting. And it goes up quite a bit, which actually I don't know if that's a problem or not. I don't know if it should be going up that much, though. Like, this goes down a lot, which is what seems like it should happen. But this compared to this is a lot of a difference. So I am almost wondering if I did make a mistake in here. Is there something in this calculation that's off? Or should this equation change depending on the polyness? Whatever. Let's continue for now, because I know that I know already that the cubed one to the power of 3, that's gonna like match this the best. Especially that should get these points up here. So that should have the lowest error thing. So let me just worry about that. Do this first, then I'll worry about that. Now the question is, with how similar these are, do I just do this again? Or should I try to actually make this a proper thing? You know what, I'm gonna do it again for 4. I'll do it one more time on 3. What? Because I don't know if linear is different enough that I might leave linear how it is, and then it's just the 3 polys that I combine into functions. I mean, the same functions with different inputs. I'll see. Let's find out. Yeah. It's obviously, you know, not the best coding practices to be combining things like, or to be pasting all this code again. Yeah, okay. So, this should now be 4. This part changes. Something I need here is either a power function or, which I don't know if Python has. Does Python have a power function? Python power function. It does have a power function, just pow. Okay. Didn't know that. That makes this easier. Okay. Okay, so this number can match the poly count. Cool. I won't bother changing this on the power of 2 one right yet. In time. Even if I don't mix all of these, but some of them can definitely mix. Like, I think calculating the weights was the same. Yeah. This, it's just this part that changes. Even the error calculation is the same. Fascinating. Okay, so now this needs to become This part I think will become more complicated to match, but hopefully we can handle it. Is this how this would change? No. Yeah, but then this becomes a 3. Yeah, this is where I need to see is how exactly do the numbers shuffle around for this. But hopefully that's how that should be. And then I gotta do the same thing on this part. Even if, again, I don't actually... Oh yeah, one thing I don't have to do, I don't have to calculate this all in one line. I could calculate it on the line before. Might make that easier. Or stick something, do something with 4 loops, I don't know, we'll see. Okay. Okay. Is that all? Is that all? Let's find out. Oh, again, close these. I have to close all these and then it'll open the next ones. Yeah. You don't like that. Oh, that's a new error. Oh, it's trying to do a multiplication thing. Size 3 is different from 4, okay? That would be here. Yes. Hopefully. So once I close these, then it should open the next 2. Oh no. Average error is all none. Alright, that was a slight concern. What happened? Also, just gonna comment at this again. Ugh. So I can just cut to the chase of the ending graphs. But yeah, in proper execution, I'd like it to be 1 at a time, or maybe like 2 at a time, or I don't know, something like that. So what happened here? Oh, still trying to print these numbers. I never stopped it from doing that. So at the weights are all problematic. So the problem happens earlier than this, with the fact that shouldn't have been printing to begin with. Okay, so why? My first guess would be, I guess just going, yeah, top down, calculating the features is wrong somewhere. Okay, starting on the training data, because I imagine if I fix the training data, then I'll have to do the same thing to the test data. Okay. So it is a bunch of numbers, which I'm going to... Oh, I didn't actually... Oh, there's empty categories in here. That's going to be causing a bunch of problems. Gotcha. Oh right, what's the order I'm supposed to do these? I forgot that it's not just that I changed the power of 2 to the power of 3, it's I still need the power of 2 part in there. Right. So it used to be x squared, x cubed. Got it. Nope. Getting there. Okay. What? Oh, right. Need to remember to change that to test. Then I gotta fix these. Okay. Now will the numbers be right? Hey, that looks good. Hey! That's promising. And the, oh. Did I hit the run button more than once? Cool. And the average error is really tiny. That's good. For a second I was like, oh no, it's bigger because it's like 0.5. But no, it's 0.05. When I think the first one was 0.5. Perfect. Okay, let's delete that. Delete printing the weight. I think now it's only printing what it needs to, no like test statements. And yeah. Oh, I guess I should have a I guess I should have proper I don't know, sectioning off of the different pieces. Okay. But yeah, this is perfect. This is how this should be. And it looks like straight here, just the way that it's drawing it with the points, but that's fine, I think. Perfect. And yeah, as I said, I had the feeling that these two outliers and this one down here was going to be causing a lot of problems. Yeah. Okay. Because I imagine this is really, like, these are probably really skewing the numbers. But that's fine here. And as I also said, I don't predict that polynomial to the power 4 will make this any better. I think this is as good as it can get. Unless it would go, like, up and curve over here a bit more, but I don't see that happening. Especially because this training that doesn't go this far. Or be here, but it wouldn't. I don't think anything in this would make this try to turn over. I don't know. We'll see. And we can just calculate the numbers and find out. But now, before I do this, should I be trying to combine these functions together? I'm gonna vote on yes. Let's try and do it. Well, one step ahead of that is, should I try to do it the linear, or do I leave the linear on its own and put the poly on its own? I think I will just combine the polys, and then once I've done that, if I see, hey, if I put in a 1, it works for linear, then I'll do it. But for now, just pretend, I'll focus on like 2 and up. We'll see what happens. I'm just gonna actually, section these off for a minute while I'm doing this. Because something like this should be there anyway. Something along those lines. Anyways, so now if I'm going to combine these into 1, I'd probably use the triple one as a base, I think. Yeah, and then all of these. It would be smart of me to keep this old code and change it, or like, don't delete and then regret deleting. So let me just go to here, cut this out. I keep just dumping, code at the bottom. But now, once again, copying just 3 enough. Because, oops, not like that. Copying it. Oh, you don't like this, do you? Oh. Yeah. And then this putting a lot of spaces so I can just easily separate this from everything else. So now these are going to take in inputs where it's going to be an int degree. And that's the premise of what I'm doing for all of this. And we'll see how things change. Although I think calculate weights actually doesn't change. But yeah, okay. We'll see what changes and by how much. Okay, let me now also change these. Getting there. 3 is everywhere. And then, if this works, I'll be doing the same with 4s. But I won't worry about that just yet. Okay. Wait, why do you have a problem with this? Oh, right. This is Python. This isn't not Python. You don't like that very much, do you? Okay. So actually, first of all, yeah, as I said, weights actually doesn't need the number, so it's not going to get it. And even then, this could just change to calculate weights. I don't have one that's just called calculate weights, but whatever, it's fine. Okay. So now, where is this degree used? This degree is going to be Oops. Oh, no. Not what I wanted. This degree is going to be this plus 1. Right? Yeah. And now, this is where things get weird. So first of all, this number would be the degree, and this would be degree minus 1, but it needs to be like a for loop of keep going down like a factorial until you get to 2. I mean, this could be this to the power of 1, but that's probably redundant. So I'm going to have 4 I in range, I mean, not I, but I guess J. This is going to be D for degree, I guess. Degree. Can this go down? Can I go degree to 0? I don't think I've done this in Python. Okay, degree, brackets not needed. We'll see if this works. Let me just Google this to double check. Python range down. Can this do down? I can't down it for loop. Start and step. Oh, you need a step. Okay. You need a -1. Okay. Good to know. Yeah, and then whatever I do here, then I can copy down here, but we'll get there. Okay. So going from 3 down to 0, down to 2. How do down to 2 will it run to? I don't think so. I'm pretty sure in range goes up until that amount. So I want to do degree until 1, except I put it in the wrong place. I think. Then the 1's column is a extra thing. Where actually this is going to be degree. But that will be the wait, no. It will be... Yeah, it'll be, because this is degree plus 1, and the third spot, yeah, it'll be 3. Okay. Yes. So now, this needs to be in spot D to the power of D plus 1. And this also makes me realize that this can just go up, and it's probably actually fine. So, yeah. 20K, 1 hit! Hi, hi! Hello, hello. Welcome to the stream. We're continuing to do game devy things to varying degrees of success. So now this actually needs to be degree plus 1. Actually, no, we're not doing game dev stuff. We're doing programming-y things that are... well, okay, right now the code is broken as I'm changing a thing. What kind of music is that? Random video game music. Currently, this is the hub world music from Crash Bandicoot Wrath of Cortex. I have a playlist of like 150 random pieces of video game music that won't get copyrighted. Nah. Yeah. But so we're doing some what's called linear regression and polynomial regression, which I'll just gonna show you in a second what that actually means. But right now the code is in the middle of being a bit broken because I'm refactoring stuff. And it looks cool. Basically having like a scatter plot of lines and then doing like a line of best fit. And then doing like a polynomial line of best fit. That's what we're currently doing. Yeah. Rocking out there with the emotes. Yeah. This is Sonic Unleashed, the second to final boss music. Yeah. Love the emotes. Great. Okay, so what was I just doing? So blah, this. Is it both the test data? I plus 1. Blah. This should be fine. No, it won't. This needs to be degree. This might be good. I might be able to stick this in here, have this be a 1, but I will not worry about it for right and now. Love it. Alright. Global weights is the same. Regression on training, poly, by a degree. This thing changes by this. This is going to be a mess. I do know that this part stays the same, though. I believe? Yes. This is going to be some other weird for loop thing, where I'm going to separate this into multiple lines. So with graphing, basically this is calculating y values. These are x values, these are y values, to have a nice smooth curve line thing. That's what we're trying to do. I'm going to separate this onto another line. What do I call you? I don't know if this is the proper term, but regression y vals. I don't know. Something along those lines. Alright. So now this weird thing needs to be what? How do I turn this into a formula that uses this degree thing? No. And this is an array, so let me do this and then some kind of do the same thing. Do the same trick. Indeed. For I. Oh, by the way, I fell off my chair yesterday on stream, so that's great. If you look at my most, I don't know if it's my most viewed clip. Well, most viewed clip as of like it's like I think the default like last 7 days or whatever. Yeah, I fell off my chair, so that happened. It was shortly after getting raided, so I was very like, "Oh, this is cool." And then I went to show off. It's not repeat the same mistake. This water bottle with my old logo on it. And while doing what I just did, the wheel of my chair got stuck on something and just I fell. Didn't hurt myself, so I'm good. Okay, so I in range. Actually, I'm just gonna make this D for degree. Going from. Wait. Oh, interesting. The order that I add these doesn't matter. This is just this thing plus this thing plus this thing, right? I forget if I don't know if this matters, but you know I'll do it in the same order, whatever. Okay, so for I in range, D to 0. No, it'll be D minus 1 to 0. Because if it's 3, then I want to start at the 2 to 0 and go by minus 1. This is complicated Python-y stuff. If it's confusing, then yeah, it was confusing to me. I spent so long figuring out how to do all of this, and I'm still like not entirely sure what I'm doing, but I think I'm getting there. Oh wait, that doesn't work. This needs to be this. Yeah, and this is for a school thing, by the by. So yeah. Okay. What was I just doing? Changing this line, because that's not how that line should look at all. Ah. Placing it down there for reference, it should just be like... regression values, add on this with this being this D value. I don't know if this is going to work or not, but we're going to find out. And then after the for loop, then go plus equals the last bit. I don't know if it's gonna work. to be frank, we're gonna find out though, and then do this stuff. Actually, I'm gonna stick that back together. Lower the play horror game thing to 20k. Why is that how much you? Oh, that's you said 20k earlier, because is that how much you have? How much is it set to again? I don't remember. How do I find that out again? This button. What was it? 10,000. No, it was 100,000. That's what I set it to. I don't have time to play horror games on stream right now. I'm way too busy. Oh no, how do I? There's the X. Yeah, you gotta. Yeah, work up to that level. It's not something meant to be redeemed all the time. It's like a once in a blue moon kind of a thing. And again, it needs to be when I actually have time to do it. Which is not going to be until, like, May at the minimum. I am super swamped with all this school stuff I'm in the middle of doing, but it is how it is. Okay, what was I just doing? Right, I did this. I need to do the same thing down here. Onto this bit. Ah. Except this should have the word test. Yeah, not trashed. Is that gonna be the same? Everything else is the same? Oops, I got rid of a line that I didn't mean to. This line is supposed to still be there. Yes. With this also saying test. Okay. So now, is everything else the same? I'm gonna hope so. Alright, let's see. Fingers crossed. Don't crash. Oh. No, I was worried that wouldn't work. Did I already delete the old code? I did. Well, it's lower. Yeah. Yeah, I need to do this differently. This is annoying. I get why this doesn't work, but I don't know what to do to make it work. Okay, I'm gonna redeem 20k worth of Rubik's Cubes. Oh no. Why does that one look like my face a little bit? The shaking one, that kind of looks like my face, and that's great. Lol, JK. I will be solving Rubik's Cubes for the next month if you do that. But, yeah. Okay, what was I... well, I know what I'm doing. I don't know how to accomplish what I'm doing. So I need, how doth I do this vector math? So, is there like a function that might be like numpy dot add? This might be what I need. I basically want to take, I think what I want is to take two different arrays and add them element by element. Well, back to work. All right, one hit. Thanks for dropping by and all that. I know, yeah, what I'm doing right now might not be super interesting. It'd be better if it was working, which it just was, but it just broke. Not so much of that broke, is that I went to add new functionality, and I'm in the middle of getting that new functionality to be existing. I guess. But I think it's about to work, so... Oops, I didn't mean to delete that. Oh, no. Numpy dot zeros. Is that how this works again? D-type float. Although I don't know if that's the default. Okay, something along these lines. So I need an array of size 40s. Okay, actually that's hard-coded. I need to have that not be hard-coded, but let me stick this here. I just need to be zeros by the default. Where this is going to be, so instead, yeah, length of blah. Still not happy. Why? Regression vowels weight 3. So actually, I didn't even. I still have to change code down here, but the fact that it errored up here means something up here is still wrong. It got that down here though, and that's actually surprising. Index 3 is out of bounds for axis 0 with size 3. What do you mean? Oh, because this isn't supposed to be an actual number. It's supposed to be the degree size, which -1 or +1? I think. No, I think just the base amount. Yeah, because the array is one higher than it because of the ones column. Yes. Which also I meant to put this down here. Okay, so now I got to get this to match what is below, which I'm actually just going to do this the easy way and like this. But then I need to, up here, I need to exchange the word training for test everywhere it comes up, which isn't that many times. There's only 2? Okay, sure. Let's see if this works. Hey, oh, It brought up the graphs, but it didn't do the linear one. These ones are blank. I notice it says non. Non is not a good sign. Oh, it got a warning. Overflow encountered in MatMul. Great. And that was in Poly 2. I didn't even get to Poly 3 because the code didn't get the chance to try and finish. That's concerning. Good thing I still have the backup code pasted all at the bottom of this thing. So currently the problem is, I think in this. I think everything else is fine. The 1 second. Yeah, the way I'm trying to add arrays on each other ain't working too good. So let me go back and look at the original line, which was this. This. Sure. Okay, so. This was this. So how do I make... Okay, let me... For the sake of testing, let me hard code something for a second. Just to test that this is the problem, and the problem isn't somewhere else. Because it did run without errors, which is actually a decently good sign. So the only... I run this with a value of 2 and with a value of 1, currently. But obviously I'd like it to get to work regardless of the number. Degree is 2, do this. Else, elif degree equals 3, do this. Where the only difference is that this should have this plus like that. And then this should be 3. Okay. Hey. Oh, because you don't like that because I put it in the wrong place. One, like this was supposed to be here. 2, down here, if I'm going to put it down here also, this should, again, have the word test on all these variables. Because it's a different data set. It has a different size. Okay, try it again. Oh, it's still the non thing. That's actually a good thing, because that means that it's somewhere else that's the problem, which means that this might still work. Fascinating. I'll keep this commented out for now, but that means I need to go up and, yeah, locate the imposter that's causing the issues. So, runtime warning. Overflow encountered in met multiplication. While calculating the weights? Okay, that must mean that it's the features that are wrong. Let me, again, double check what I initially had there. Skip down to the power of 3 version. Yeah, where are you? Where are you? Regression on test poly. I'm looking for this. Okay. Nah. Okay, there we go. So, this, I tried to turn into this. They should be doing the same thing when this is like a 3, but it's not. So the question is why? Am I assigning things in the wrong places? Okay, so first of all, I mean, this line is the same as this, so that's not a problem. This line's the same as this, right? Where this would be degree 3. And this is right too, because that was a 4, and if I put it in degree 3, then yeah, that should be correct, I think. So now, pretending this is 3, this is going D in range 2 to 4. Which it should be. Or 2 to 4 because it goes up until that number, I believe. Right? Double check. Python range. Be too careful with my assumptions. Yeah, 0 to 5, you put in that. Even if you put start and stop, not included. Yeah, thought so. Okay. And it's going from 2 to a higher number, so it's going to go up by default. I don't need to put in a step amount. It can be the default that is 1. Where's the problem then? Okay, so so it will go training data features to, oh, it's supposed to be 1. Oh, right, because it's supposed to go up. Right, okay, yeah. Right, that's a problem. Okay. I was thinking in terms of powers and not in terms of, you know, arrays that are off by 1. Okay. Is that all? Let's find out. Hey, we got our lines back. And we got our betterly curved lines back. Awesome. Okay. So now, let me test that I should be able to bring back this, and in theory, it should still work. I guess we're gonna find out though. Bring back the other one at the same time. And this one. And well, nope, that's not quite right. Something just a little bit wrong about that. How'd that happen? Fascinating. And then these are even more wrong. Okay. Okay, so I thought that, you know, this was equivalent to this. But, you know, obviously this is all super hard-coded. But this shouldn't be. Like, this should be, you know, the same sort of logic. But apparently it's not. I thought NumPy add... I mean, NumPy add does not work the way I'm thinking it does, or in the same way that it is to add these two arrays. In some kind of different logic. Yeah, they need to have the same size, that makes sense, which the originals do. Is it the same thing? Do I have the same problem, perhaps? Where this should be... I have degree -1 going to 0, but it's not going to hit 0, it's only going to hit 1. That's the problem. That's part of the problem. Because I'm trying to copy this, I'm trying to... So if the degree number is 3, I want to go 2, 1, 0, and then afterwards I manually add in the last one that is this. So it should be degree -1 down to 1, -1. Actually, I might be able to flip around the range, but cause I think this would still work if I go in the reverse order, but whatever. Let's get it to work in general first. I'm just gonna draw the 1, so one's gonna be off, then the other will be right. Yes! Okay, that's what we wanted. That's what we want to see. And this one's still gonna be off, because I still have to fix it. Okay. Perfect. And again, the solution was to do this. So I should be good to delete this part and this part. Okay. Cool. Cool. Next, I just want to see if I actually can rearrange this and if it works the way I'm thinking it does. So, the reverse would be going from 0 to degree, right? Again, I'll just draw the 1. If it works, then I'll copy to the other. I just want to see it actually work. Which does. And that's the same, right? Okay. Perfect. So from 0 to degree. Okay. Okay, other little thing I would like to add is in the little text thing here, to put the degree in that. The average error on the training set for degree. Does it work like this? I go dot format, or I mean, I can work do like this. And then like this. Is it? Or I put in the first thing being degree. Is this how this works in Python? Let's find out. For degree 2 is blank. Okay, perfect. Now you just have the same thing down here, have it say test set. Perfect. Yes. Okay. So now, oh, hey, on Nightly. Hello, hello. Welcome back. Hey, look up F strings much better than format. Probably. I don't use Python that often. I'm more familiar with this kind of stuff in other programming languages. So I just kind of Googled like anything that would work. But I shall do that because yeah, it'd probably be good. F Python F string. Yeah. Yeah. Oh, this kind of thing? Okay, let me go to a different article that gets right to whatever F strings are. Oh, that. Oh, I recognize this. Okay. Oh, yeah, that is better. I have used this before. I forgot it was a thing. This is what happens when you're using a different programming language like every day. Yes, yes. Yes, yes. Alright, so this would then be how does that work for here if I want this to be a decimal? That, well, actually, if I just do this, does it work? Actually, for this, no, for this I don't need to even say the decimal places. Let's just see, does that work on its own? That would be this one, which it is cool. For this thing, I want all the decimal places. This is a school thing, and I believe that's what I want to do. Put that here, test set. Cool. Now let me bring back some of these show things. Because all of these graphs that are being drawn, they should be being drawn like one by one by one. Okay. Perfect. Also, hello on Nightly. Yeah, welcome to the stream. We are getting close to being finished this thing, and it is coming along well. Okay, so first thing is initial data set, test data, training data. Trying to do basically a line of best fit on the initial data, which obviously isn't linear, but it does its best job. And then applying that same line onto the test data and seeing how that's doing, and then printing out the average error amount. Then do the same thing, but with quadratic. Yeah, and then do the same thing with cubed to the power 3. And I'm about to make it do the same thing to the power 4. Before, I had doing it for poly 2 and doing it for poly 3 was like the same code, like copy pasted, slight changes. I just made it work where I can have the same code, but I just called some functions. Average :2f, if I remember off the top of my head. Fair enough. For this, yeah, I don't want decimal places, but good to know if I did want that. Nice, nice. Nice indeed. So now, another thing I did initially is, just to keep things simpler for now, I separated the linear code from poly 2 and 3. Now that I've done what I've done, I just want to see if this happens to work for linear, which in theory it should, but I'm not completely confident. It'd be nice if it did, because then I can simplify the code even more. That's the initial data. Index out of range. Right. Okay. Well, let's see if I can fix it. In calculate features. Over here. So you don't. This doesn't like when it has a degree of 1. Training data features. I degree equals 1s. And this. This is out of range. Okay. So when let me run through this when it's a 1. So this it's gonna make a thing of size 2, which that's correct. Because it should be 1 higher than the degree amount, because I need a, yeah, I need a thing, okay, I need a column of the initial data and a column of just 1s for the way the matrix multiplication works. But this should go from 1 to 1, so this should never run, in theory, for the linear thing. My guess is that it is. Or no, it says the index out of range is coming from here. It should be I, 1. Why do you have a problem with this? I don't immediately see why it's a problem without, like, printing anything. But let me back up, because something I forgot to do, and I'd like to do this first. Go back to when things were like this. I meant to, on the poly version of calculating the features, I should be able to get rid of this line and turn this to a 0. Wait, let me double check that that's the case. D plus 1, yeah. I should be able to get rid of that and turn this to a 0, I think. This is a bit of optimization. Doing the same in both places. Does that suddenly have errors, or do I get the same lines? Okay, initial data, mwah, fine. Linear line, cool. Other linear line, great. Actually, yeah. Oh, yeah, okay. Cool, that's all that should be. So now, let me take another stab at doing the linear stuff. I don't know if that change will suddenly fix this. Probably won't. Could have. It's something I wanted to do regardless, and yeah. Errors. Oh. That's different. No, that's the same error. Never mind. What am I saying? Okay, so back to those functions. That's this one. It's doing on the trading data. So this is, yeah. This is running with a degree of 1. I could do breakpoints and stuff, but put a breakpoint and check the variables. Yeah, I should. I always don't. Okay, how do you do breakpoints in VS Code? Is this gonna do? No, I have to specifically. There's like a run debug mode. Start debugging. Yeah. This is it. Ah, things are happening. Okay, so it's after this. Hit the breakpoint. Okay. Degree is 1. Okay. I've done this in different IDEs, just not this IDE specifically. Yeah. Okay, so, right, what am I even looking for? Yes, okay. So, this for loop should not run a single time. Wait, no, should it? Going from 0 to 1. No, it should run once. It should run a single time. But how it was before, it shouldn't have ran at all, but now it should run a single time. Okay, so right here, this is where the error is about to happen, so I'm not going to go forward. Degree is 1. Oh, globals. Yep. Can I find training data features? Yeah. And whatever's happening here is going to have the same problem in the test data 1. Yeah. Fix it here, fix it there. Okay. I'm looking for shape. I'm looking for seeing the individual things. This? Cool. There we go. Okay. Right. What was I even looking for right now? I'm trying to... Well, right. So this is out of range. On debug console, you can call variables. What do you mean you can call variables? What does that mean? Oh, you put certain variables on a watch thing and then see how they change? as you go from line to line. Is that what you mean? Or, yeah. But anyways, I'm yeah. What am I looking for? I've like completely blanked out on whatever I'm doing. I am trying to. So this is having a going out of range problem where training data features at this and this, which this will be a 1. I will be whatever top thing. Actually, wait, does this actually have the problem here? Or does it after it repeats a few times? No, it's the first time. Cool. Which is why. Set of range. Oh, does this tell me things? Again, haven't done like this kind of thing before. Well, okay, yeah, I know where it's happening. Points, yeah. Okay. Why am I not seeing what's happening here? It's going out of range, which is why. I was 0. That's fine. The degree was 1. It went 0. 0, 1. That should be fine. Why is it not like that for linear? But it likes it. It's fine with it for. What's the problem with this again? Next to terminal debug console. Next to terminal. This. In this. What about this? Then you can call variables. Like what if I were to just type in degree, and it'll tell me what that is. Okay, got it. I get you. Okay, cool. Didn't know this was a thing at all. Oh, okay. It didn't autofill. Does it not autofill? Does it autofill if I hit like tab? Oops. Yeah. So this, the whole list. Cool. Oh. No, this is fine. No, it's not. Should this be? No, this is wrong. Currently. Well, actually, it's just values that aren't set. This should be an array of numbers, and this should be an array of empty values that I'm about to set to a bunch of 1s. Okay, let me back up. Rerun this. How do I rerun from the top and see things before everything goes haywire? Okay, now I want to see the this. When I've just made it, it should be a bunch of empty data. Okay. That's stuff to do is F11. Okay. Before it even does one thing, am I gonna see this change, or is this only printing what it is right now? No, okay. It only prints like, so this is only like what it is now. It's not telling me how it's changing. Okay. Fair enough. Yep, shows 1. Mm-hmm. Blah and blah and blah. Okay, this. I want to see it as it's changing. I need to find it up here. Unless I put it in this watch thing. I guess that's a thing. Expression to watch. Eh. Nope. Does that do? F11. Okay. Well, it was. Oh shoot. Oops. Did I just do that? Hopefully it's fine. See changing set as watch variables left side there. Got it. I'm ahead of you there. So I'm familiar with some of these concepts. Just again with this IDE, knowing where buttons are, and also I tend to not use this kind of debugging ever. I just always use print statements, and it does do the job. Yeah, definitely something's funky here. Why does this have these numbers? Because these are just like some artifacts of, you know, it being like empty memory, right? Because, like, if I, here, let me if I were to change this to 1s, which actually I guess I could do, and then I could skip on this entirely. Huh. That's a potential optimization. If I rerun this again, actually not like that, but like, whoops, nope, didn't it. Go again. Debug. Un momento. Just wait for this do. Okay. Go forward a few steps. No, it should be all ones, right? My understanding. Yes, except the first one, but that's because that just ran through. Yeah. Still don't know why that's causing a problem. Why that's having any sort of an issue, but especially because so it doesn't have a problem on degree 2, which makes you think that something needs to be like +1 to. But I'm not sure what. Because this shouldn't be a 0. This should be like whatever row that we're on, go out 1, or however many what the degree is equals 1. Like this part wouldn't be the problem. What? Oh, I'm an idiot. I know what the problem is. I see the issue. I see the issue, and something I just didn't account for. What had nothing to do with that variable is the 1. Like, that can't be wrong. Because I didn't, because I was under the assumption that I always had the linear thing first and not the poly one. So under the linear one, I set up this ones array and then never change it or anything. Also, I probably don't even need it. But for the moment, let me just kind of bring it back. That's why so the problem was just that I wasn't calling the linear version of it. That was the only problem. It had nothing to do with this. I don't know why I was like, yeah, okay. Let me not do this and just run it like normally. I'm going to be overly confident that it's going to work. There we go. Bam. Linear. Yes. Linear on the test one. Quadratic. Yes. 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 And yes. There we go. All right. Huzzah. Doing what we want. Except, so it's working, but I having the column of ones is really redundant. And also, also, yeah, it is working on the linear stuff, so I can get rid of that, make the code even better now. Okay, so I'm just gonna rename all of these to not have the word poly in there, and then rename. Yeah, so right now I'm just not changing any functionality, just renaming for the sake of now. This is including the linear side of this. Great, yeah. Woo. And I learned how to do some debugging stuff in here. Not that I ended up needing it for what was actually a problem, but like, yeah. Anyways, still helpful. Okay, well, yes, changing these up here now. So I'm also gonna be, yeah, I'm fine with actually deleting these functions now. Yes, being extra sure before I delete something I regret. And then change the names of these. Yep, which I could have done this to begin with, but it was easier to comprehend by worrying about it all separately and then combining it later. But, yeah. Okay, that's all good. Just run it, make sure everything's good. Yep, that looks all the same to me, I'm, like, pretty sure. Yes. Perfect. Okay, so next, next, the ones thing. Yeah, I do not need this. It's just an array of ones that matches the size, which doesn't need to be there. Oh, especially because it would have had a problem. Interesting. It would have had a problem and errored if technically there should have been two things of this ones thing. One for the training, one for the test data. Because this is under the assumption that the training data is bigger than the test data, which isn't a guarantee. Anyways, like this, I can just hard code this to a 1. I just didn't at first. Usually I don't like the hard code numbers like in here, but this is a worthy exception. Okay, is that all fine? I think that's the only place I use that. Because essentially I need a column of 1s at the end of the data for the matrix multiplication to do better. Do correctly. Okay, so perfect. We got all this. So now, actually, last bit of this is that I'm supposed to do it again with poly4. Which, also, I can change the actual print statements to be more descriptive, but for now, it's just for my sake. Okay. Shazam. Skip straight to quadratic. Or not quadratic, fourth power, which, I don't know if that even has a name. It does some special name. Okay, so this is the linear one. Or, I'm sorry, what am I saying? This is the training one, and then this is the test one. Which is actually worse. That's interesting, because this is trying to go down, I figure. Yeah, cool, cool. And this has some straight points just because it's going from point to point to point, which is fine. Interesting. Yeah, and as I suspected, the average error is higher because of the way it, I think, tries to bend. So the best thing here. Oh, I didn't change the name of the print statement, but whatever. It doesn't actually matter. The best version of this, and I think it only matters in the context of the test set, is the Poly 3 version of it, which makes sense. And I that was obvious enough from the get-go, but the sake of this assignment was to eventually get to that conclusion, I guess. Okay, perfect. This has all the functionality that it needs to have. Cool. Well, we're about to be doing more stuff that's going to be even more complicated. Regularization and cross-validation. Yeah. We'll be getting to that momentarily. But first, to make this better, one thing that I actually want to do, that I didn't do initially, is I want to, when I run this, the first graph here, it's the training set and the test set on the same graph, and then after that, all of these are independent. I want to make it like the first one, where the first, or all of these are in groups of 2, based on the training set and the test set. So let me do that. Okay. In order to do that, I just need to first not have the show part here, and not make a new figure here. Is that it, actually? No, that's not it. I need the code to actually do the subplot. Right. Where do... Yeah, okay, is that all? Okay. So at this one, go wah. Where this is gonna be 1 row, 2 rows, 1 column, and this is the first thing in that. Oh, it's gotta go through and comment it all, but I'll do that. And then this going here. And this being 2. And then show, okay. Shazam. Oh, Shazam, there we go. Yeah, and yeah, this doesn't go as far over because they're mapped to their borders. In fact, this doesn't necessarily need to go 5. Maybe I actually might stick that back down to 4. Yeah. Okay. Cool. Yeah. I'm just gonna put that at 4 instead of 5. Same here. Same here and here. This is the graphing the initial data. Okay. Try that again. This, okay, that's better, I guess. Cool. Yep, those are graphs, all right. Where again, the best one is the Power 3 one. Mainly it's these two on the end where things get funky, but yeah, woo, perfect. So now I do have to do some writing about this, but I'll do that on my own time. Just wanted to do this stuff on the stream because I can. Okay, I'm actually going to be doing some more programming stuff in a moment, but yeah. All right, let me get these print statements to be better. So data imported successfully. I don't need error checking on the data. For the context of this, I think that's okay. I more so just want to, make this, okay, linear regression. This is, what's the proper terminology orders? The proper terminology being something like this, with some capitals. Put some colons. Yeah, okay. Something along these lines. And this. Yep. Okay. I don't need to go to 5. That's all good. All right. Double check I'm not missing anything here. Yeah. Okay. Let me it didn't change much, but let me just make sure nothing broke. Yep, all good, all good. Now, looking at the actual numbers here that are being printed here, yeah, they make sense, I think. Actually, hold on. One thing I'm going to do is actually go like this. That's the way that goes? Yeah. Have each of these be a new line thing. Just prettying this up because I can. But looking at the numbers here, they're all good. The lowest test one is this one, and the lowest training one is this, but like barely. But in terms of which one's better, the test would be the one to go off of. And even just like as a human looking at it, it looks like a power 3 kind of a thing. All right. Yeah, okay, perfect. So now, deciding if I want to comment this now or later. So that's just going to be more tedious work, but oh well. Gotta do it at some point. Might as well, yeah, just get it out of the way. Well, this is all fresh in my head. Good. Do this at the top. Yeah, that's my name. It's Cyberchroma. Okay. Just BSing this. Importing libraries. This doesn't probably need to be commented too heavily, just like enough. Raise for input data, which this is like it's stuff we're getting as input into the program, but it is output. I don't know. Initial data. Whatever. Arrays for I don't know. I'm not commenting each of what each of these are individually. The names are good enough for that. Arrays for something like that. I don't know. Okay. I don't need to comment these, but getting all the data from their respective text files, I guess. So I guess while I'm doing this, how are you all doing? What is this from? Oh, that, yeah, right. That's from Crash 4, part where you're in a ball getting chased by a big truck thing. Yeah. Okay. The teacher is gonna look at the graphs. You can add titles and labels to plots. Ooh, I could do that. Do I need to do that? I'm not sure. For the record, this data doesn't mean anything. So in terms of labeling, I mean, I could label the training versus the test. That maybe would be a good thing to do. But like these aren't quantifiable things like meters and heights. But yeah, I can figure out how to do that. That'd be more I have to figure out how to do matplot stuff of how you actually add a title. But yeah, okay. But I'll finish commenting first. Okay, what was I just doing? This. So sorting the data to. I'm trying not to do comments that are like describing so meticulously exactly what's being done. Trying to give more outer context, which would be like sorting the data left to right. So like in the graph, it's like sorted by the x's, and having the y's being sorted together. But how do I translate that into a sentence? Sorting the data, I don't know, from lowest to highest x values, and there's definitely a better way to word this, but I can't keep together. I don't know. Whatever, it's fine. Okay. setting up the... I don't want to say setting up the graph, but sure. Setting up the graph. This is not stuff that that came from code that I copied, but I'm not going to keep that. Current axis. That's not a thing I've done. Yeah. Graph the initial training data. Graph. Letters, yes. Graph the initial data. Set the frame of what's being graphed. I don't know if that's worded entirely correctly, but it's good enough. Okay. This is the initial training data. Okay, and then this just gonna, yeah. Show the graph. I guess that's what we're doing. Okay, now getting into more, okay, this is gonna have more meaningful comments as I'm commenting more of the actual, what the functions are doing. Okay. This was the adding a This is okay. Well, can we skip to this part? Is adding a column of ones for the biases. Biases. That's that part anyway. And these are gonna be like the same. Oh, well, this should be test data. Do that part. Repeat based on the order of the regression. Using order just have slightly different terms than what's exactly there in the code, so it feels less repeat-y. Okay, setting up the columns of features to do the regression. I don't know if I actually use the test features, but I'll leave that there anyways. I might use it. I don't know. Anyways, so how would I describe what this part's doing? This is like, oh yeah, okay, well, yeah. Adding a column for each. This is like doing, you know, x squared, x to the power 3, x to the power 4. Adding a column for each power of x. Should be a feature for the regression. And that's a long comment, but oh well. Better overly explained than underly explained. Maybe, I don't know. Okay, that's fine. I don't need a line here about repeating for each thing of input. Okay. Calculating the weights. This is a, yeah, more complicated math. So this here, I don't have the picture anymore. The form. Oh, found it. Hold on. For explanation, it's right. Yeah. Grabbing a picture to show stream what it is that I'm doing. Just paint. There it is. That's small. This function is encode this. Multiplying the transposed data by itself inverting the matrix, and then multiplying it by its transposed version thing again, and then multiplying it by the output. So, how do I describe that? Calculating the weights by first I guess I'm just going to describe this meticulously, multiplying. Actually, this part is important of me showing my understanding of these kind of functions that I'm having to, I don't know, do stuff with in this class or something like that. Like, if I had to implement stuff with this in more writing questions, like just doing straight up like linear algebra math. Right, so calculating the weights by first multiplying the feed, the input matrix by its transpose. And also, these comments hopefully make it look more like I didn't just copy this directly and I actually am understanding what I'm doing or something along those lines. I don't need the beginning part here, but multiplying, let's go by, or getting the inverse matrix. Something like that. Then this is multiplying. Okay, we're getting there. Multiplying like by the transpose of the input matrix again. Put again, because back in time we're doing that, basically. Yeah. And then multiplying by the output matrix. Well, it's an output. It is an output matrix, but it's only has a degree of 1. It's more just an array. Multiplying by the output vector would then be the term here. Terminology. Okay. That good. Next on to regression on training. And then doing the regression on test. Yeah. So, this I'm just going to be copying some of the comments from up here. And separating that out. Okay. The more I copy it, the less I have to type. Okay, so this is, once again, this is graphing the initial training data, unmodified. And then this is calculating the y values of the regression. I should say how it's being done, maybe. Using the weights. I want to somehow say something about the degree. Well, actually, I had a comment up here where I was like, try something like that. Okay. I'm just gonna say this. Add the last weights for the y-intercepts. I guess. Works. Okay. Then plot that line. Oops. Plot the regression curve. Or line. In the case of it being linear. And then, had I described that before? Set the size for the graph. I guess. Okay, next is calculating the average error. This was also just implementing a function in code. Let's see if I can find that real quick. That was this one. Eh. Still quite blurry, but you get the gist. So I did implement that as code. Okay, I'm gonna start here by going through each thing of input. I actually forget whether this was... Did this go off of each line? Added features. Or something like that. That's, instead of calling up the variable name directly, this amount to add, what is it more so? It's kind of more like a, it's each individual data point, how much that's off from where it should be, right? Isn't that how this is? Or something like that? I don't remember where this equation comes from, and I don't know if I want to calculate, or want to have, be as meticulous with the explanation of this. I could just put a each line of input to calculate the average error amount. It's also usually the case of, as I'm commenting things like this, the further down I get, the more the less I care about my comments, but it's fine. I probably am already being too meticulous, but whatever. Better to not comment it at all. Report. Single report. Okay. Oh. Show both graphs. Now I just gotta copy the top to the bottom, because they're effectively not the same thing, but they are quite similar. Actually, it's the same thing on the test data. That's, but still using the line from the training data. So, okay. I'm not gonna put initial on there because it's not like I'm modifying the test data. You know what? I'll keep those together because these are kind of one clump, or that's connected in what they do. Okay. Where did I miss? Down here. And then okay, and then report. Cool. Then we got these. I think I don't need to explain these because they get explained in the functions, and the names of these are descriptive enough, hopefully. Okay, so now I can get rid of all this at the bottom. It's just left over. Don't want to get rid of... Yeah, I can go. Okay. Perfect. Okay, let's make sure I didn't accidentally break something by, like, when I was commenting, I deleted, you know, one letter or something. Okay, that seems good. This seems good. I don't have a thing that's going below 0, do I? I'm pretty sure I don't. Let me double check. Just taking any of these and going like -1. That's going to be on the... that's on it. Okay, whoops. Which, no. That's still before 0. And yeah. Bring it back. How it was. Okay. Ta-da! So yeah, I guess I should have titles, shouldn't I? Some more fanciness. How do we do that? Let's find out. Probably like a one-line thing. Okay, actually, I was about to Google it. I might be able to just like search and figure it out. Okay. Do I do before the plot or after subplot? Yeah. This dot title. I'll call this training data. And assuming that works, I'm just going to paste it down here. Test data. And I'll see if it works here. I have no reason to go on the others. If it doesn't work here, which it did not, it's a method. Well, it didn't error, which is interesting. Alright, yeah, just do this. Actually, surprised it didn't error then. But okay. Unless that's a different thing where I can, like, unless that's a different use case for this where I can set the title and then actually use it later or something like that. Okay, cool. Perfect. Okay. Well, I need to, no, because I hit the button so many times. Okay, now I need to add it to the others. I just, you know, did it on one first. Okay. Where art thou? Okay, over here. I guess the name of this should have the degree, and I like a special thing where, so I could go, training data, wait, regression, here's all this, okay, polynomial regression, order to do that F thing, degree, but I want a special thing for if it's 1 to say the word linear. If e equals 1. This will be the only part that really has this, because it's for fanciness of how it's printed. Okay, if I can print the right buttons. Okay, yeah. Okay. Then... And I don't need degree if it's linear. Oh, wrong side. Yeah, okay. Cool. And assuming this works, I'm just gonna also paste it to the down here, and I need to comment them. I'll do that. Where this needs to be test, but also this needs to be up here. We're getting there. One step at a time. Okay, and go. Cool. Linear regression. I don't know if I can space this apart slightly, but that doesn't really matter. I'm sure that the yeah, how this looks doesn't super matter that much. There's more doing it. I mean, it matters a little bit, but this should be fine. I also make sure I have the right names in the right places. Is important. Okay, cool, awesome. Anything else I want to do? I don't think I need to put labels on. I mean, first of all, like, there is nothing I can call what the data is, other than just input, output, I guess. But nah, should be fine like this. The line itself, like the title says what it is. It should be fine. Yep, and then I'm reporting the average error amount. I'm pretty sure it's supposed to go down here. do I want to actually change the amount of decimals? I'm thinking of maybe changing the amount of decimals. Let's go like 4 decimals. And you said earlier on Nightly of how I do that. It was something like this, 0.4, yeah, or something along these lines. That's not even the right place I want to put it. Find where I'm putting it first. This. Let's see. I don't know if it needs the F. I don't know if Python floats have the F at the end. Hey, it worked. Okay, never mind. I just want to see what it does without an F. I'm just curious, because I don't know if it'll error or not. Oh. Okay, this is gonna... Oh, no. I don't know if there's a way to stop this. Whatever. Let it go through everything I was trying to do. Okay. It did the same thing. Oh, no. It, hold on. If the 4th decimal here is a 0, it looks like it's rounding it, or just kind of chopping it off. Is there a way to make it do 4 decimal places, including, like, have zeros there, if nothing else? Oh, and there, the first thing was a 0, so it went to 4, things like that. Oh, would the F prevent that? Hold on, yeah, okay, yeah. Was it here? And let me put it in both places, just to start. Okay. I'm trying to fix it. Again, I kind of... That's not where I want you. Hold on. Where are you? Oh, over here. Okay, well. I have to wait for this to go through this thing again. Yep. Yep, that's not what was supposed to be there. Okay, try again. Oh, now is it doing it? Okay, it looks like it's doing it now. Perfect. Beautiful. Okay, that's easier to see. In terms of number of decimal places, yeah, 4 is probably fine. Enough to see what numbers are bigger, because that's mainly what matters. Okay, so yeah, 0.5, 0.4, 0.2, 0.8, 0.03, 0.01. Yeah. Okay, I think I can call this done. I have a little bit of writing to do with this, but I'll do that later. I mean, writing, that'll be like 2 sentences of like, or a few no, more of an explanation of comparing them. But anyways, so that's that. So with linear and polynomial regression done, we are now moving on to regularization and cross-validation, which is going to be more stuff that might vaguely relate to this. Or it's going to relate to this. I don't know if I'm going to just continue off the same bit of code or if I'm going to copy things. But I might duplicate the whole project before I start. Like, even if I am reusing some of this code, just to have this as it was existing. Okay. So using the training data, wait, excuse me? Okay, this is a typo. Okay. Using the training data, implement an L2 regularized for the 4th order polynomial regression. Vary the regularization parameter, lambda, bunch of numbers. Plot the. I can't show this on screen because I'm reading from like stuff with my like university. They probably would not like if I. By the way, are you in college? Yes, I am. Oh, university. But yeah. So it's literally this is a university assignment I'm doing, which fine that I'm working on this on stream. But they probably would not like for me to show straight up like my school. Like PowerPoints and all that stuff I'm paying tuition to see. They probably would not be happy with that. So we'll ride the line with this. Yeah. Actually, also, I'll be right back, I think. And actually, I might read this quickly and have an idea of what I'm doing before going into this. Thing I was going to write. I might write that now. I don't know. By the way, I'm going to take a quick break, and I'll probably actually rename the stream for regularization and cross-validation, which I have to figure out more what that is. I went into this not entirely knowing what I was doing, but I was able to figure out. We're about to do the same thing again, where I'm going to go into this like a buffoon, not knowing what I'm doing, but I'll eventually, hopefully, figure it out. And a lot of this will be me Googling things and reading PowerPoints and Stack Overflow things and all that, but we shall get there. Because again, like, I would like to be streaming more of like what my actual stuff that I do, which is this over here. Oops. Ta! Unicycle thing. Well, no, game dev more generally. But currently we're working on a game that also happens to be a school project where I have to make a demo of this by the end of the month. Well, March 4th, I think. Is when I need a vertical slice of the game done. Here, let me get rid of these gizmos. Yeah. So this is more my domain of expertise. This unicycle, how it moves, is all through, there's no animation going on. It's all through programming. All procedural animation and physics. But, like, yeah. A lot of, like, the wheels turning, that's not happening through physics. Other than getting what our velocity is and doing stuff with it. But, yeah, also tightrope stuff. That was a lot. This is a lot of pure math. That, and also a lot of, like, sine waves. It's a big part of just having this go, like, up and down. And leveraging a whole bunch of stuff that I vaguely remember. This is like a few weeks ago when we did this. But yeah, this is the thing I'm usually would be working on. Looks awesome. Thank you. Yeah, this is the handyman with a unicycle. Oh, right here, this is the one thing that does have an animation, but yeah, actually taking damage on things. Yeah, this is a work in progress. Yeah, the main idea of this is that you ride around on a unicycle with some hopefully interesting, unique feeling movement, and at this crazy carnival where there's like the hazards everywhere, you're trying to ride around and fix rides before they break, where right now they all just break all at once. The actual game would be like every few seconds, it's like this one's breaking, 2 are breaking over here, 3 are breaking over here, here, and here. So they kind of spawn into breaking, and you have to, yeah, keep running around with lots of hazards in between, and a lot of interesting movement stuff. Like there's boost pads over here, and hopefully more types of obstacles and hazards that I'll be making. The main moment-to-moment gameplay is like dodging hazards and all that, with the fixing rides being more of like an excuse of get to this destination, have fun with all the stuff in the way. And also being all, yeah, hectic and, yeah, within your goal being to last out a timer. That'll be like a clock, so it's like you're trying to last to the end of the day. And the main shtick with this carnival is that each day they open up in a new location, which gives an excuse for the levels to be different, but then like the story thing is that like that's why everything's all like very run down and breaking all the time, because every day they tear everything down, move it somewhere else, and build it all up again. Yeah, so that's that. And also main character is Handy Harold Henderson, so that's a thing. And the carnival is the some stupid acronym that's like the Pier Avion's Yesteryear Universally Shifting Carnival, which acronyms to pay us. So, yeah. And the main antagonists are like a council of clowns of like other circuses and stuff that are like competitors that are trying to get you shut down. Partially for like how unsafe your carnival is, but like nothing is actually broken down yet, so you can't get sued. So they're trying to like break your stuff and get things get your carnival shut down. So that's just excuse for there to be like enemies and stuff. And there are going to be the safety clowns, which is also some acronym for something. But the idea of professional, like, board, like, council thing, but where everyone's just all clowns, just is really funny to me, so we'll see how that goes. Now, again, for this project, I only have to make a demo of this, so a lot of these ideas I'm saying out loud won't actually be in the demo, but I would like to continue working on this game after this demo thing is done, so we'll see how that goes. And then, yeah, like some of those ideas will be more fully realized. Like also right now, we don't even have a character model in here yet. The unicycle is pretty nice, and hopefully that'll be the final model of the unicycle, maybe with some slight modifications for when we put a person on here. I had to like adjust for leg length and all that. But yeah, I have ideas with this, and it's coming along. But yeah, in addition, oh, actually here, I also have this loaded up. Other project I'm working on for a school thing. This is a VR game where you sort garbage, and this had to be like an educational VR game, and we're taking the concept of sorting garbage and trying to make it as fun and entertaining as possible. So we got like timer and score. This one's gonna be more of an arcadey kind of, there's a conveyor belt of garbage coming by, and you're having to quickly like pick them up and sort things into the right things. Got this raccoon mascot here. Oh, this is like our dev camera sort of thing. We have like the VR stuff all working. Just I have when I'm not in VR, we built a non-VR, like, just able to, like, zoom around for the sake of not needing to be in headset the whole time. I mean, like, for the consumers, it's a VR game, but this is the developing thing. Anyways, make it easier to develop things. Also, this raccoon thing is a thing I made. It's like the mascot of our game. It's Raz, the raccoon. So, yeah. And as you saw for a second there, he is animated and all that. I'm going to be voice acting him at some point, so I had to figure out how it is I'm going to be doing that. I also got these cool timers that are kind of floating up and down. And yeah, very, very neat. And actually, this timer is just a UI timer thing on a world canvas that's just stuck behind this grate, which actually, yeah, looks quite nice. Ideally, maybe it'll have a better font. Like right now, it's just the default Arial, but like it works for now. And yeah, so that's coming along. Oh, and we can pick up things and throw them, and there is like the score system of when you put things in bins, they disappear and you get a score and all that. Right now, the score is super simple, where it's like you put things in the right bin, you get 10 points. You put stuff in the wrong bin, you lose 10 points. But we're hoping to implement more of a combo type system, and yeah, make it more intricate, I guess. But anyways, so yeah, that's some of the other stuff that I've been working on. This I call more of my usual content on these live streams. In addition to other Unity games and all that. That's my forte, my knowledge of expertise. Anyways, but yeah, so with enough rambling about that, yeah, we'll be getting back to doing this stuff where you saw what I'm good at, now you're about to see what I'm very bad at. But again, I think I'm going to take a quick break, and then we'll get back at this and yeah, see how that all goes. All right, I'll be back. All right, we are back. Wait, I don't have my lab coat. 1 second. Have to have the proper attire here. Forgot about that entirely. But yeah, all right. That's also music, and you guys can hear it. Yep. Okay. So now we are attempting to figure out regularization and cross-validation. The keyword is attempt. Okay. So, oh yeah, ignore this. This is some of the writing involved in what I was doing. Yeah. Okay, so, right. The first thing I wanted to do is actually separate this code. Well, they're going to be using some of it, but I want to cleanly separate what we've done and what we're about to do. So I'm going to go ahead and do that to start. Can I rename this without causing massive issues? Please. Yeah. Yeah. You're fine. You're fine, okay. Nice, and copying it is easy. Sure, okay. Cool, so I can change this without completely messing up the other thing. Yeah. Okay, so... to start off here, I need to figure out... a thing with regularization. So the point of what we're getting out now is handling the overfill problem that can happen when you have too high of a polynomial count. Actually, yeah, to show that off, I want to see something neat. If I make this, I don't know, this like 100. No, okay, I guess we're going 1,000. This might run slow, but it'll be neat. Actually, I think 1,000 actually is too much. Let's go 100. If I do this and skip ahead to it showing that data. Oh, okay, it didn't do what I was hoping it would do, which was... Aw, yeah, no, it didn't do what I thought it would do at all. I was hoping it would do this line that goes like, whoosh, 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 like weaving through all of these individual points, because that's what it would try to do at that size, which could perfectly map to the training data, but it wouldn't map nicely onto the test data. So you want something that's more of a this kind of average sort of thing. Just hit F2, lol. Oh, with that thing, zoom out. I maybe was going really far up, really far down, but I think that was too much. Let's go 20. Just curious of what it will do. Oh, Francesco, also, hi. Hello. I didn't realize that was you. Like, people keep... Oh. How long has chat not been working? Oh, no. I've just been alerted to that. No, with rename. Yeah, hi. Yeah. What happened here? No, I don't want to break chat. Hold on. I'm gonna do a thing. Kind of been here for 2 hours just in the background. Ah, fair enough. Well, yeah, welcome back. I'm just realizing that chat's for some reason broken, and I don't know why. So let me try to fix that real quick without completely destroying it. If I press this button... Oh no. Excuse me? Why is this not working? Hold on. Is this a problem with me or with Streamlabs? Huh. Has this been a problem the whole stream? Hey! Oh. Now it's working. Don't know why it wasn't, but sure. Woo. Refresh the thing to get a new URL. Never mind. Alright. I'll take it. It's all good. Does it have the... Wait, hold on. Is it doing the very subtle outline? I can't tell. I think it is. Let me double check by doing one thing. It didn't reset the custom CSS, I don't think, but just in case I'm repasting it what I copied before. Yeah, it's fine. Okay. Don't know how I went the whole stream without noticing that. Or was that happening before? Oops. Ah, you guys get infinite OBS. Alright, whatever. It's fine. Okay, but yeah. Hi, Francesco. As you can see, yeah, what we were doing here. Oh, I guess I don't need to recap if you've been, yeah, here seeing it. Basically, lines of best fit and all that. Huh. So it does seem to break when you get super high. I'm not sure why that is. I don't care about that. Like, that's not my problem. Actually, I'm curious now, though, of how low can I go for it to get back into normal numbers. Okay. That, this. Interesting. Yeah, fascinating. But anyway, whatever. Whatever. I was just curious of how that do. Anyways, so now what I need to do is, I'm just gonna turn this down. Okay, so now what I need to do is something called regularization, which has to do with trying to fix this overfitting problem. Now I understand conceptually what it is, but I gotta figure out how to actually do it. So hold on, let me actually see what my so the actual thing I have to do here, this last three-part question here. Use the training data to implement, so L2, I don't know how it's supposed to be pronounced, but I recognize the symbol. Oh. Also, I saw someone use, so I saw someone said to use F tags. I keep using format lol. Is there a particular reason why one is better than the other than just... Oh, I mean, I get the things you get out of both. In one, you get to put the variables there in the line. With the other, you get to put all the variables together at the end of the line. That's the trade-off. I don't know if there's an under the hood, this one's super slow, the other one's super fast, kind of a thing, but... This go from playing... It did. No, that caught me off guard. Again, playlist of like 150 random games from different soundtracks, and it went from playing one from one game to another of the same game. Anyways, actually two levels that are literally like right beside each other in game, I think. Anyways, but yeah. So right, what was I doing? Lost my train of thought. Oh yeah, there's two ways of doing, or that I've learned, of doing the regularization thing, L2 and L1. The symbols is a fancy cursive L2 and fancy cursive L1. I don't know how that's pronounced, but I'm going to call it L2. I have to implement that for the fourth order polynomial regression. And then vary the regularization parameter lambda between a bunch of different things. Plot the training and test error. Plot the... Okay. Yeah. Average over all instances using the error equation that I've actually implemented already. That is this. Yeah. As a function of lambda. Should use a log 10 scale for lambda. Great. Which lambda is the best fitting for the data? Okay. So I gotta understand what this I'm doing. Alright. So going through this one thing at a time. Implement this L2 regularized thing. I know what it is, but not... I need to like look it up, what it is equation-wise. And this is stuff I've said before. I probably would be best if I didn't show on streams. You're just gonna. Oh, I'm an idiot. I was just like, huh? It just went and played the next song from the next level. One of the things I have here is the entire playlist of this game, which I meant to remove. That's gonna go bye. Yeah, we're just gonna short. But that was a misclick. Sure, whatever. Okay, so Streamlabs is all fixed. Let me just actually and this and this. Did I just close the other? No, I didn't. Hold on. Okay, we're good. Anyways, here, while I'm figuring this out, what's something interesting you guys can look at? Hold on. How about? Where are you? I have a particular thing I'm looking for. Where are you? So here. Glenda. This. Wait, no, that won't play on loop. Hold on, never mind. I was gonna play a video thing. Never mind. You're gonna get Blam. Both my unicycle-ness and my cool. Actually, hold on. Taking more time to set this up than I should. Okay, this player lean move. No, where's player tightrope move? Where did I put the player's tightrope movement? I was doing this ages ago. Excuse me? It's not down here, is it? It is. Okay. Balance, speed, fall angle, off balance, acceleration. So if I made this 0, actually go into play mode and then make it 0. So I'm not actually messing with these values for realsies. Also, so I don't like change values and then completely forget about them. So now we should not be capable of falling off. Yeah. Oh no, it does not like those numbers being 0. Okay. Never mind, I'm just gonna comment out pieces of code instead, because that's the easier thing. Because I have this, I just need to comment a code called, or a function called balance. I don't know what division by 0 error was happening there, but oh well. You're taking your sweet time. Whilst doing that, I'm gonna continue to read more things. This. It's taking more time to set up than I wanted to, but oh well. I'm committed. Committed to my decision. Okay, there's something else that I need to fix eventually, that like, when he turns, he's supposed to prefer forward to backwards, but sometimes like there, he'll do a full turnaround. He's not supposed to do that, but oh well. Okay, there, now I can't fall off. This is what I was going for. Nice shot of, actually you get all the level. Yeah, there you go. That's all I was trying to do. I put a lot of work into this tightrope. It needs to be shown off. Okay, so what was I looking for? This L2 regularization thing. Certain equations that I need to implement into code. It requires me to quickly skim through a PowerPoint that I've already read, but skim through again to find the particular thing that I'm looking for. So, okay, and then screenshot things and put them onto Paint things so you guys can see them. I'll make them bigger. In. Paint. Shazam. Yep. 1 second. This. Over here. So here is one equation. Of the general concept of... Is this just for regularization in general? Yeah. I think JW is basically the error amount. Has to do with the line itself. But then taking into account some kind of a reduction kind of, well, this is the regularization amount here, to make it so that the more complex the line becomes, the more that's a problem, like penalizing it, so. But not too much. And the exact perfect amount to penalize it is a key thing here. So in our particular example, I think degree 3 should be what gets the highest score, effectively, on the test data. Okay, so oh, this is extra complicated. Hold on. And here. That's a thing. Am I implementing all of that in code? Hold on. Hold on the phone. Or I think there's more, okay, there's more stuff to reduce it and make it better. I'm just copying a lot of these equations at face value. This one. Which is similar. Oh, is that taking into account, yeah, weights being a whole matrix? Okay. And you have I being, like, is that an identity matrix? It looks like an identity matrix, but the very first thing being a 0. So it's like close to an identity matrix. Okay. Is this just this function again? Yes. Multiplying stuff out. Sure. I forget what the double line thing here means. Usually like a single one on both sides is absolute. I'm pretty sure the double one, is that magnitude? Or something like that? Of a vector? I don't remember, and I should remember. You know what? Yeah, I'm just gonna keep copying equations for the right now. Actually, this is gonna replace this. Yeah. Because that's this, yeah. And we're gonna take this one that's gonna be much more important, I'm pretty sure. So I'm also gonna need to make that identity matrix, I bet. That's right here. With, I'll be supplying in certain lambda values. That's gonna happen. Yep. And that's for L2. I need to make sure I'm getting the right things. I'm not implementing L1 regularization, which is a different thing. Same general concept, just 2 ways of going about it that have different pros and cons. Well, L1 I think tends to be better, but L1's more computationally expensive. Also, you're not getting that nice view of my tightrope. Okay, so that an equation I already have. No. What? Why is that transpose? That's not. I actually don't remember why that's the case, but Or you're not pacing. There we go. This one's like the same, but without the transpose part. Oh! And that's just the normal identity matrix, isn't it? Is it? I think so. Okay. And then we're on to L1 stuff, which I don't care about. Okay. So somewhere among these equations, we are translating stuff into code. In order to note that we do not penalize the bias term W0. W0, the bias term? Is that the, like, my column of ones? Is that how that works? Might be. Okay, except I'm gonna, I think the column 0 is at like the end, but whatever. Okay. So, being indecisive. Okay. So with this, I want to implement this for the fourth order polynomial regression, where the lambda value I'm putting in, I put in a bunch of different values. 0.01, 0.1, 1, 10, 100, 1,000, which is going off the logarithms. So that'll be how I decide what that is. Yeah. Okay. So cool. So one thing, I can get rid of some of this that I don't need, I think. Because I'm doing all this only with fourth order regression. And if I need to bring back something from the other code, then I have it. Okay. I'll still, just for the heck of it, I'll still graph the starting data. I'm like, do I? Yeah, I will, whatever. Okay. And this is actually applying this regression. And we're just gonna make it a new function at the bottom. Regular. I'm not spelling this right. How am I spelling this wrong? Oh no! It's just because it's like that's not a function. And of course it's not. And we're gonna only worry about the training data for right now. Okay. Wow. Name it the same as this. And it'll still take 3 degrees input. I'll still leave it being like that. Okay. So, of these equations. Now I can look up more with remembering the context of how I actually need these. But, okay, so first of all, I need a lambda value. Hold on, see the size of this. Am I really, like, Hold on. Just want to make sure that I'm doing what I should be doing before I invest all this time and then realize I was calculating the wrong thing this whole time. Maybe I plot the error. Average over all instances. Okay. I'm really turning all of this. Like, I'm calculating this W value and then sticking it into all of that. Except I noticed that this is basically the same as this, so that's fascinating. Interesting. Very interesting. Where's the lambda term again? Oh, it's here. Yeah. Right. I'm just not sure. Is this gonna be a bunch of y values again? At the end of the day, like I have the x values and then. No, not. Well, these are the y values of like the training data. I mean, y values of stuff to plot. But I need just trying, what does it mean by plotting? Plotting the training and test error averaged over all instances. Like, is that gonna be What's that getting at? Using I have to use that other error equation again. Hold on, let me bring that up. Oh, which means zooming in. Okay. This. Add it onto the board. Okay. Well, how do I... Yeah, zoom out. Okay. I'm a bit lost here as to what I should be doing. Yeah, use the training data to implement L2 regularized for the fourth order polynomial regression. Yeah. And then vary the regularization parameter lambda by a bunch of numbers. That's fine. But plot the training and test error. Average over all instances. I just don't know what that actually would look like. I'm trying to see it in my head before I... Because, wait, using the equation as a function of lambda. Oh, I missed that. Okay. So this equation here, but like, because I'm expecting if I'm plotting this, plotting and test error, I'm not getting a single number. This error will be a single number. But this as a function of lambda. How do I stick lambda in this? Oh, because this is the weight? Are you just saying... Because I'm putting in, what? 1, 2, 3, 4, 5, 6. 6 different values of lambda. If I just start plotting 6 points, where it's more like... With these 6 values of lambda, here's what the error amounts are. And that's... Is that what I'm graphing? With the training data and with the error data. Sure? Okay. Yeah, so which lambda value gives the smallest error? That's what I'm trying to get. Okay, that makes sense. That makes more sense. Okay, I'm wrapping my head around it better. Okay. Got it. So this is the graph I end up making is calculate this with different values of lambda, stick that in here, this, graph that. So how does that apply to all this, though? 'Cause that's what I'm missing here. Unless I'm not actually using all this yet. There's more parts to the question getting there. Am I missing anything? I feel like, wait, so I'm using the data equivalent blah blah blah. Oh, hold on. Wait. Page 12. So I'm looking on the wrong thing. Okay, that would doesn't help. Excuse me? Oh. Right. This is the sort of the thing that we're trying to minimize. Right. Yes. Okay. Yes. Got it. Okay, right, because this is getting sort of like the error amount based on like whatever the order is that has to do with the weights. And then this is like a penalty for how high you go, so you don't go too high. Because if you go too high, then you can eventually perfectly fit the training data, but then you will be really bad on the test data, and that's what we're trying to avoid here. So this becomes this all expanded out, but it's this thing that we're trying to minimize. The only impact we have on minimizing that is the W value, because it's like we're told the X, we're told the Y, and well, we're testing different lambda values. That's something I'm ranging between, and this is like a modified inverse matrix, identity matrix. Yes. So off of that, it's, yeah, with different W values. Okay. This is making more sense. Wait, so what is the difference between this and this? Are these the same? I just want to double check that. I don't know, and I don't want to, I mean, I could test, but something just seems... I'm not sure. I'll just go with this one, because it's the one I'm seeing more used, where I would expect it to be used. So, okay. Okay, so what we're going to be doing is, with different lambda values, with a range going off of logarithm values, we will do this equation, calculate W, and then through W, calculate the error amounts, and then plot the with different lambda values, plotting different error amounts. Right? Okay, let's do it. And I'll do it after doing, like, I'll just plot the thing to the power of 4 on its own first. Regularization, that's going to be starting to here. So we've already plotted the stuff here, which meant calculating the initial weights just to make that happen. Okay, so now, I don't know how much of this I can reuse. Except this, once we have the weights, is that equation. Yeah, okay. I'm just gonna kind of go like, put this up here. Okay. Except that's not the first thing we're doing. I said the first thing we're doing is implementing this. Put this off to the side. Okay, so weights. So we're changing how the weights are after graphing the initial thing. So the weights are, we're starting with x transpose times x, which is going to be, what is our input here? It is training data features. All of it. Times one of these being transposed. It's not necessarily the first one, depending on if this is transposed differently than how my data is, but we'll see. I'll do this in multiple lines. No, hold on. Okay, plus equals... So this is going to be our lambda value, so I need to do... how do I want to do this? The lambda part of this. I mean, I can go lambda equals 5. Is lambda a built-in term? I don't like the way it's been colored. Val. You get lambda val. If I place like that as some number, 10. I need to loop through with this being different values. Based on logarithms. Okay, so let's just put this in a big for loop. No, that's not Python. Iron range. This is gonna be an L for lambda, I guess. I don't know. Based on logarithms, it's like -3 to 4. 3? No, yeah, something like that. Or then it's gonna be like cur lambda, actually. Let's go with that. Cur lambda is gonna be, does this have a log thing built in? Awesome. And I'm assuming by default it's log base 10. Log L, right? Because, don't check this. I have a log button on here. I know I do. Yep. Log -3 is gonna be you lose log 10 scale for lambda. How do you? Oh no! Oh right, no. Logs can't go negative. Right, that's not how that works. How do you? What log gives you a value of 0.1? 0.01? yes, you can use lambda, then why did it get colored differently? It got colored like it was some special term, which seemed concerning. Like it's some, like, it could be something I can override, but if it's some default term in Python, I don't necessarily want to override it, probably, so I don't cause myself issues. Log 1, oh yeah, log 1 is 0. 1? No. Is it? Negative 1. What is... I'm just gonna go to Desmos to be faster. I'm forgetting basic logarithm stuff. Desmos. What value gives you like a 0.1? How do I get to a 1.26 off of a logarithmic scale? Or... So, okay, again, I don't know why I'm expected to do this through logarithms. That seems strange. This isn't gonna go to 1,000. So, the sentence here is like, well, using vary the regularization parameter lambda in the range of 0.01, 0.1, 1, 10, 100, 1,000, which is multiplying by 10 each time, right? But, that later, oh, I'm misreading this. I am misreading it. Okay. Plot the training and test error, blah, 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 blah. As a function of lambda, you should use a log 10 scale for lambda. So that's for the graphing it part. Got it. Not for the actual, that's what lambda should be. Got it. Okay. So I need this to repeat, start at 0.1 and multiply by 10 each time. You can't do that in a Python for loop, could you? In like a C# for loop, you go, yeah, I times equals 10. Can you do that here? Oh, I mean, okay, actually no. I guess I could just go from 0 to 7 and go like 0.1 per lambda equals 0.1 times I. Or, times L, because I guess that's the letter that I'm using. No, wait, that's not what I want. Times, times 10 times... Why am I being an idiot here? Why can't I think of what I... no, 10 to the power of, that's it, okay. That's what I want. I got this. That's what I want, right? I don't know if 7's the right number, but it should end on, like, 10 to the power of 6, 10 with 6 zeros. Right, times 0.01 gives me 10,000. What's the number I actually need? 1,000, so you go down by 1. Okay, that was close. Okay, that's it. Now everything here should be bumped up. Okay. Continuing. I now have lambda values. That'll be in here somewhere. So again, implementing this function, which we've done this part, and I was just getting onto this part, I need to multiply these things together. Which means I need to make this matrix. To my understanding, this is a modified version of the identity matrix where the, like, so an identity matrix is a matrix where it's like all zeros and then a one, like a diagonal of ones, I'm pretty sure. Identity. Let me double check that I know what I'm wrong. That I know what I'm talking about. Yeah. Yes. Yeah, all zeros in a row of ones. I'm pretty sure this modified version of identity I'm pretty sure this modified version of an identity matrix is the same thing, but this here is a 0, and that's the only change. That's what I was able to gather. And then I multiplied by lambda. And that's scalar multiplication. Let me verify the thing I thought to be true of, yeah. Lambda, or is it identity? The little thing is that it's a hat symbol, so I don't know what you call them. A lot of these terms here I know by what they look like, I don't know what they're actually called. But this is what I'm making, and I'm assuming this is the thing of 1 to 1. It's safe to make that, yes. So first of all, is there a built-in identity matrix? Perfect. That modified one, I don't know if it has a name, but I'll just make it manually. So not like this I won't. So I need to make... Lambda, I don't know, Lambda identity is going to be equal to this. Well, actually, this times lambda. Actually, lambda times it. I don't know if the order matters for scalar multiplication with matrices, but not this on its own. I need to specifically set the first thing to 0, which I think it's fine to do that after. I don't know, and I don't want to take chances. I'm like 99.999% sure, but okay. Do this in 3 steps. How do you actually access the 0 equals 0? Is that what's gonna do that? I hope so. So that should be... I have this part individually, and I have this part individually. Now, gotta put them together and then do this part. Okay. Yeah, okay. So now weights. Yes. Weights plus equals lambda. And then weights. I have a line somewhere where I have inverted numbers or inverted matrix. So let me just copy that somewhere in here. There you are. Yeah, this. Actually, I did it to a thing called weights as well. This is kind of a different context. It's very similar, but okay. Yep. So invert it. Cool. Next. Equals matrix multiplication. Between or to x again. Transposed x. Which again, the transposing might be all flipped from how it actually is, but we'll see. We'll see based on whether this runs. Okay, so then lastly, I need to stick in y. Oh wait, this takes in 2. Yep. This needs to be the output. Yeah. Cool. That good. I have these weights now. I then... that would be this equation done. And then I stick this as this W into this, which I already have that equation. That was right below. I just need to calculate a different W, I believe. And then I get this error amount. And then we see what happens. So first, because I imagine I've done a whole bunch all at once, I imagine I'm gonna get errors. So let me just start by we're gonna print weights. We're gonna print error average. Yeah. And also just because I can, I'm gonna print cur lambda. So I get all 3 together. And then down here, actually for now, I'm gonna just comment all of this out. And yeah, this will happen after all the lambda stuff. Okay, let's run it. And see all the errors that are about to be coming my way. So it still does the test data, then it does the, what's the initial data, then the to the power 4 thing. Yep, there it is. Ah, that's the transpose thing. Okay. So this is all transposed from how it should be, which means I should have to transpose these, I think. I don't think this one. Excuse me? Oh, wait. Oh. No, excuse me? I can... You didn't like this either way? Really? Because one way, it's 5 and 40 by 40 and 5, and the other way, it's 5 and... No, wait, why is this a problem? Isn't matrix multiplication, like, you can have different, Oh, because I'm an idiot, and, must be this. Yes. Which means that, this might be back to being a dot T. Or, what was the way I originally had this? This way? Yeah, okay. See what happens now. I also might comment the code that's making the graph show up, because I don't need that right now. Lambda identity 0, 0 goes 0. Does not support item assignment. Okay, I will fix that in a minute. Let me just comment out all the graph showing, because I don't need it currently. Okay, so I'm not doing the setting a thing to 0. How do I do that with NumPy? Let's find out. Probably just like a similar kind of function, but some special syntax. NumPy actually, is it? Yeah, matrix set value. Item set. Item set. What's just this do on its own? Fourth item to 0. Is that, so that's that. Why is that? Is it going 0, 1, 2, 3, 4? Okay. Oh no, that would make sense. Set the fourth item going this way, sure. And then this, or I can do, you know, rows and columns. Well, wouldn't it be 0, 1, 2, and then 0, 1, 2? Oh, it's oh, it is. Okay, perfect. I shall yoink that. Actually, well, it should be from here. Item set, 0, 0, 2, 0. I'm gonna get rid of that up here. Hopefully that's fine. Function object has no attribute item set. Oh, is this not, what? I thought this was a matrix. Is it not? It's an array. Well, if it's an array, then why couldn't I set its values? Let me just look through what is here. Maybe I'll find something useful. Was this really not it? Excuse me? Function object does not support item assignment. I'm just trying to set an individual number. Okay, so let's try Python. It's not just an array, it's a multi-dimensional array. Set item. Set value. It's a NumPy array too. Yeah. Why is that not working? Unless this isn't... Try that. Sure. Oh wait, oh, never mind. Different errors. Woo. Function object is not substrate. Well, what do I do with this then? Why? Is it weird because I'm grabbing numpy.identity? Is that becoming some kind of constant that I'm not allowed to change? Which would be weird. Mario Sunshine? Yes, it is. The first level area. Delphino air strip. NumPy identity. Set change value. I don't know. So weird. Like, I don't want to just put it in another variable. Let me just for the sake of testing something, because just to go away from this, if this works, that means it's a problem from getting identity. Oh, it's a function. Oh, I didn't. Oh, it's a function. That's why. Okay, that's why it's weird. Okay, got it. Got it. Okay. Different error. Yeah, made it to the next line. That's. Or no, it didn't. Missing. Oh, okay. I assumed that the default would be 1, but fine. Oh. Doing that. Hey, this also has the full OST in here. You know what? Fine. I'll let all of that. I tried to not have full game OSTs in this playlist, just individual level musics. So more variety or something. Also, typically when I've tried to, or in the past when I've tried to find full game OSTs that will also cover a lot of like random like cutscene music, I'm like, how about no. Okay, did the thing. Here, let me just so I can see this better. Oops. Clear that out, and then run this again. So I can tell what's properly from this time of running. Or, never mind. Could it just not do? Okay, whatever, fine. Yeah, 0.1, it did this, it got 5 values? Does that make sense? Yeah, I think so. 4, 3, 2, 1, then the row of ones, except messed with because of the weights. I'm so tempted to buy a GameCube just by hearing this music. Ha! Well, that's what emulators are for, you see. Actually, I think I literally have, I literally have this game on a Dolphin emulator. Bam, there it is. Want to divert the stream and start playing? No, it's not the same. Agreed. Especially Super Mario Sunshine specifically because it with the L and R buttons, how having to like only hold them down like halfway and that making a difference. Which you can kind of emulate that, but yeah, it's like not the same. Because it's not just like pressing it all the way, pressing it halfway is like the analogness of it. Anywho, what was I doing? I calculated this, and I got these being these numbers, and then this being the average error amount based on these weights. Yes. So with this being the current lambda amount, this is the that error amount. Are these numbers the same? These aren't changing. Oh, that's concerning. That would be a good indication that something's going. Oh, even these numbers are the same. I didn't even process that. Uh-oh. That seems slightly problematic. I have an old big box TV that's perfect for nostalgia. Ah, very cool. I beat Mario Sunshine. My sister took back her GameCube. Sedge. Yeah. Emulators, man. No. Yeah, no. Super Mario Sunshine's great. Yeah. The one singular thing that I mean, we have many quirks, but one main thing above all else that I don't like with it is that so Super Mario 64 has, to get to the final area, you have to get 70 stars. Actually, you forget what the number is. You need a certain number of stars from anywhere to get into the final area. Super Mario Sunshine doesn't really have this. It has, like, you need a certain number of stars to unlock one of the levels. I think, like, 10 gets you to, like, Peanut Park and stuff like that. But then you just need to have beaten Mission 7 in each world to unlock the final area. Meaning that every star past that is completely pointless unless you're going for 100%, which I always would. But, there's less of that, like, pathingness that I think is cool in games that give you choice. Especially, like, from a speedrunning perspective. Like, oh, you know, you're routing, you're like, oh, go here and get these stars, and here and get these stars. But, 65, I think. Is it? I swear it was, like a number that ended with a 0 at the very least. Could be mistaken. Here, let's find out. Super Mario. And I'm talking about Mario 64 in this case. There's 120 stars as, like, all of them. Star... I don't know, requirements? 70. Haha, I guessed right. But, yeah. For Sunshine, though, actually, I'm curious of... 50. Oh, yeah, so, wait, really? Beating Mission 7 in each area ends up being 50, with the addition of... I think there's some other extras in there, because how many worlds are in that game? Bianco Hills, Rico Harbor, the beach with the giant caterpillar thing, the other beach with the hotel, Peanut Park. Now I'm just testing my knowledge to see if I can memorize the areas. Noki Bay, the one that's like the big, the village, Peanut Village or whatever. The village that's on the giant tree. 70 but 80 on the DS. Yes, because that game has more secret stars, because that one to 100% is 150. So is there 7 areas? Does that make sense? Am I missing one? I might be missing one. And there's the final area. That has a name that, very unfortunate. how it's aged. But, so 7 times 7 being 49, plus the one from the Delfino airstrip. Okay, so that's a solid 50. I mean, sure, but there's less variety in that. It's cooler when you have more options of... Yeah, that's just my little gripe with it. I mean, anytime I play the game, I would go, like, 100% it, so it doesn't really matter for me, but... I hate the boat on the last level so much. Yeah, fair enough. It's not that bad. Well... I mean, it's not... no, it's not great, but, I don't know. When I see any people like playing that game, they have like a really tough time with the boat. I don't that much. It's terrible. I think maybe it's only because I guess you're a programmer as well, but being a programmer and then having an underlying understanding of like how I think the programming behind the boat exactly works makes it easier to do. I don't know. But, here, no, I shouldn't. I was like, here, I'll load it up right now and do it. No, I'm not saying that it's easy, for the record. It is bad. But, in my opinion, it's not as, like, it's bad, but not as bad as a lot of other people seem to think. But that's only, well, no, correction. It's bad, but I find it hard, but not as hard as other people. Just a little bit, though. I'm not saying, like, I'm god-tier gamer over here. Definitely not, but specifically the boat thing. But maybe it's because I have patience. I haven't played it since I started programming, basically. My brain just couldn't predict it. It is funky. It is funky. Especially just the way it tries to, like... I don't know how to, like, describe it, but the way that, like... The way that, like, can, like, curve when it's, like, moving forward, you really have to account for that. And the way that it pivots is strange, where, like, it's like, oh, I'm trying to turn, but it's not turning. Why is it not turning? It's because of the way that it pivots around its center. So if you're shooting to the side based off the center, it's doing really like nothing to try and make it turn. You have to be like near an edge and spray to the sides to make it turn. That's like a thing. As an example. Yeah. Anywho. And then also, I guess, patience, which when you die a million times and you run out of... yeah. Anywho, though. What was I doing? Oh, I just printed these numbers, and I didn't realize that... Now I realize that all of them are the same, which is not correct. They might be similar, but this number should be greatly, or at least to some degree, affecting these numbers, and then by extension, these numbers. So, let's get that to happen. Okay, so, my first question is why is nothing happening? So I've got this cur lambda value, which that is being the right number, so that's a good start, I guess. But then I'm adding this to here. At this point here, is it changing at this point in time? Actually, no. Let me print this and make sure this is actually changing as a result of this, because maybe it's not, because maybe I'm not doing this right, and I should be putting in this, or there's some special function for scalar multiplication. That would be my guess. Okay. Is it going? Did I just misclick? Oh, I didn't scroll down. Got it. Oh. Yeah, that ain't right. Okay, yeah, that ain't right at all. It's basically just, yeah, okay. If I print it before, when it's just this, is it fine? No. Okay, I'm probably not using NumPy identity, right? Oh, wait, is this the size? Oh, this is probably the dimensions of it, isn't it? And then the only thing that's there, I'm saying it's a 0. Got it. Okay, I got it. So this size, I don't know why I thought it would have the right size by default. So this is going to be training data input. Errors, great. Weights plus equals lambda identity. Hold on. Oh wait, no, I need a separate thing to make this work, I believe. Okay. I did this somewhere else. Where did I do something that had to do with adding? Oh, numpy.add. What is this? Okay. Yep. Where are you? What was I going to change? This. Putting this in here. Okay. Blep. Different errors, but different errors still means progress. Okay, this I never yet tested. Does this need to be like scalar multiplication or something? NumPy.add. Oh wait, you still have a problem with this. Okay. Operands could not be broadcast together with shapes 5,5 and 40,40. Oh. Wait. Oh. Does this have the wrong size? Should this have the size of... Going to my equations here. Oh yeah, that would make sense. Is this meant to have the size of the dimensions of... No. What? No. Either this should have a size of 40 and this should be that size of 40, or this needs to be a size of the 5, and I'm not sure actually which one is the case. I'm gonna try... How would I get that 5 though? I know that... Oh, I guess it's the degree. Degree plus 1 or minus 1 or... degree to being 4 plus 1. Yeah, maybe, possibly. Let's find out. Okay, those are different numbers. Huzzah! The problem is that unlike before, I don't think I have an easy way of actually knowing whether these numbers are correct or not, other than, well, to start, just I'm pretty sure, yeah, the final thing here should be 5 different things. Yeah, and these numbers, yeah, 0.5, 0.4, 0.7, 0.3, 1, 2. Okay, is that correct? Like, is that the pattern I should be seeing here? Possibly. Okay, if that's the case, cool. That's the error amount, which only goes up. That doesn't... Is that right? Because I almost expected it to, I almost expected it to, trying to find, not that, over here, the time description. I'd almost expected the number to do a bit of this, where it, like, go up and then go down, and look at, okay, which one is where it's the highest. Am I doing this right? Am I supposed to be doing this based on the order? Because right now the degree isn't actually factoring into this equation of weights, other than, well, like, it is in terms of the training data features, which is a thing. Am I supposed to be looking at this? It says use the training data to implement L2 regularized for the 4th order polynomial regression, which right now we're doing 4th order polynomial regression. So that to me doesn't imply that I need to go back and like do it across all of them, and that we don't penalize the bias term double to 0. Nothing of that I've really implemented here. No, but I think that comes with not. I think that came with the way the equation was, maybe. I hope so. Very. Oh no, actually, that may have been setting this to 0, or something like that. Maybe. Vary the regularization parameter lambda, this guy, between all the values that this is accomplishing. Yeah. Plot the training and test error. Average over all instances. One thing I'm curious of before I go any further, I'm curious just to see what does. So this was the code that did the 4th degree regularization, just printing that out just for the training, thing. Which means at the end of this, I'm just going to add a this dot show. You're gonna eat BRB? Alrighty. When you get back, this will be done. Probably not, but one can dream. Okay, so I just wanted to see what this looks like. Ooh. Wait, why did it print twice? Oh, because it's not. It's gonna print every time I close this and open it. It's gonna then keep printing. I'm gonna look at all these in a minute. I just want to look at if I untab just this, then it'll bring up all of them at once. Yeah, that's what I want. Okay. Yeah. I want to compare them to each other. Oh, right. This got it got all split. Like it's, you know, half with the screen, but oh well. So this is actually, I'll compare it to the default, yeah. So there's this, 5, 6, 7, 8. I can't organize this nicely. Here, let me actually, well, one thing I wanted to do anyways, let me just stop the subplot part. Unless I put all of them on one graph, but nah. I mean, actually I could, I think that would be better. Close one, keep up two. Here, this one will go off screen. And then I can organize the rest of these nicely in a thing like this. Well, that messes up things. It's fine. Okay. Don't know why I'm bothering making this all nice. I just want to see it visually how these kind of all look with each other. So this is the default, which is stretched, so it kind of messes things a little bit. But then we got this one, this one, this one, this one, and this one. And you can clearly see that the higher the number goes, it seems to get more and more off. But wouldn't the same thing happen even in a degree 3 kind of thing? So I don't get entirely why this helps, unless I'm implementing it just wrong, which is entirely possible. Because again, also the degree 4 was not the one that best matches this data. The degree 3 one does that better, so that is a thing. Okay. However, yeah, it's just like the more this goes, the more it just kind of stretches weirdly and gets further away from the data, which makes sense. Okay. Let me just close out all those. Okay, so... Oh, right, and I had this one over here too. That was like very far off. Alright. So plot the training and test errors. So using that error function as a function of lambda. So I think I basically want to make a graph where this would be after I calculate all the things, because I'm doing it with all of the lambda values. Okay. Get rid of those for now. Okay, so I need to make a list. I need to make an array of the lambda values, lambda vals equals blah, and then the y values, the error values. And then here, I'll add this here. This, and then this. Okay. When I hear this, all I can think of is the bullet bill noises, like every like few seconds. Like I can almost hear it with parts of the song. Yep. Anyway, so not doing it as a subplot unless I decide to make all of them on a single subplot, but I'm not gonna. No, I'm not making multiple graphs in this one. I'm just doing one single big graph. Titling it is not. I don't even know. Training data. Yeah, regularization. Regularization. Order 4. And I'm not gonna bother with this if it's So then, still gonna have this part? Oh, perhaps not. Oh. Why are you not like? What do I do that? Oh. There you go. Do I need to? I don't know if I actually need to print this out for this part, so I won't. For yet. I'll change my mind later. Okay. So graph this, where I'm doing. I think I'm only doing the one line, right? Like I'm not doing a scatter plot. Or am I? I'm gonna choose to not, but I won't delete this line yet because maybe I will. So this is calculating a bunch of y values. I basically did that. So now these are my x and y's. And it can stay red. Or now I'm gonna not limit the graph this time because I don't know what these numbers will be. I kind of know, but I'll just like let it do as it wants. Oh. Float object is not iterable. I just want to add. Is there not a dot add? Dot append. Aha, this is a thing that Python has over other programming languages without having to pull out more complex data types. This. Whoops, wrong area. Okay. Okay. Now, here we go. Interesting. Huh, it just kind of does that. Oh, I didn't do this right. I'm supposed to, you should use a log 10 scale for lambda. Lambda being the x. I think I should be labeling these graphs, or at least this one seems more like it should be labeled. Oh, close the wrong one. But this, what is it? Okay. So, no way I can just go log this, right? Or no, I have to go, I just want to do it to each one. I can just do it when I add them. Add the logarithm of current lambda. Does it have a built-in log function? Not defined. Okay. Probably some built-in. It's gotta be a built-in thing. It's like logarithm. Math.log. Okay. A base. Do I have to put in a base? No. Okay. Math.log. Oh, is math something that has to be imported? Let me go back to what I should have searched and closed out. Oh, I just saw that NumPy has a log thing. If it does, I might as well use that since I've already imported it. Why not? Eh. Okay. And yeah. Is it doing things? Oh right, it won't until I've done that. And now it's gonna do it like twice. Let me just get it to, yeah, sort itself out for however many times I click the button. Okay. Now let's see what it's doing. Interesting. Logarithms. So that's fascinating that it seems to do... Why does it go like this? That's interesting. But it does seem quite obvious that the lower the better. Which is... makes sense. Because it's like the lambda value is kind of just putting in bias on the numbers. It's just stretching out the graph, so of course it's gonna make it go up. So what was the... I don't get what the point of this necessarily was. Oh, I have to do this for the training and the test error, so oops. Oh, I have to do this for the training, and then if I apply this to the test data. Oh, okay. So I'll do that. Maybe I'll get more astonishing results. Where would I add? So this is all stuff I got rid of. Yeah. Am I gonna apply it on the same graph? I could, but I think I'll do two different graphs. Just like before. So. What was the function? It was dot subplot, and then I put like 2, 1, 1, and then after that, I might do like the limit thing. I probably should eventually. Oh, I don't necessarily need to. We'll see. This will be 2. Copy comments with it, so just a little less to do later. That's not entirely correct. Oops. Okay, so now this needs to be... I need to do, how do I do this again? Training and test error. I don't do this, wait, so I would apply, like, I use the same weights, but I apply different, I get different error amounts, right? Yeah, I'll do this all in the same function. I won't separate this into 2 functions. Or actually, all of this maybe should separate, but whatever. Do it all as one for now. Organize it later. Okay, so this is... Everything here needs to be the word test instead of training. Yep, okay. Then this error vals, this will just be 2 arrays. So error vals training and error vals test. Yep. Okay, just making sure, like, is that good? Training. Test. Okay, let's have a look at that. Yeah, fascinating. Interesting results. Does it really happen to look linear? Huh. Oh! Just go down? It goes down! Oh, that is revolutionary. I was like, this just constantly goes up, albeit slowly. If this actually goes down, that's actually interesting information. Okay, I want to actually print out those numbers and actually properly see that it goes down. Or do I... Could I change this? I should use a log 10 scale, which I am. Wait. No, I got the logarithm of those numbers. Is that is that the same as having a log 10 scale? Maybe not, actually. Would I do that? Setting the scale of the graph might be a different thing. Let me look up how that happens. Python matplotlib log scale. Well, okay, this will be the same for x scale, I imagine. Uh-huh. So I just go this dot y scale log. Okay. X scale. Okay. I was almost doing this wrong. Where do I put this? Just before I plot, I imagine? Or maybe in the setup? Let's see what happens if I put it up here, if it would apply to both. It's gonna be X scale is gonna be... Let's see if this works. Nope. Well, let me just get a clean reset on. However many times I've clicked this. Okay. So this is doing this now. Okay, so it is different looking. Still doesn't help too much. I don't know. Doesn't really. I can see stuff happening here, but this isn't really yeah, revolutionary information. But actually, I did want to see if that one number did go down. Where was the number? I'm worried that I'm not doing this right necessarily, because it just feels like I'm missing a thing. Like I'm not getting this revolutionary conclusion that I should be getting. There's more parts to the question, but even just on this part of it. But maybe when I do the other parts, then I'll realize my mistakes. But anyways, so I'm also, I don't think I will. Actually, I just want to see something. So this goes, yeah, from 0 to 1,000. If I, for the minute, were to limit the x to, let's say, 10, I'll be able to maybe see the left side of the graph a bit better. A lot better. That didn't do it on both of them. Because if I were to do that, it would have to be up here. But that right there is useful information. The whole, you can set the x limit before you go into the subplots, and that will universally, it'll apply to both of them. That's cool to know. Or not? Oh. So first of all, I think I'm actually fine just deleting these, because right now I'm just messing around with this, and then I'll fix it momentarily. Okay. And go to 10. Perfect. Kind of. It does go down, doesn't it? Fascinating. I got a 1. Am I doing this wrong? Oh, wait, no, I think I might have this backwards. I have to log the errors as a function of lambda. That's like x as a function of y. I have this backwards. The error amount is supposed to be the x, and the lambda amount is supposed to be the y. Okay, that might make the graph look different. So let's try that first of all. Oh, I'm going to have to change the scales of things. Okay. And then I need to make the lambda part still, which is the y part. So that's now the y scale is going to be logarithmic. Although actually I don't know if this is really going to change how the graph looks, but let me also get rid of this because that really should be there. I was just messing around and see what would happen. Okay. Interesting. Really, just both of them stretch the edge of the graph like that? Was this max out of 1,000 or something? I don't know. Huh. want to see what happens if, for the moment, let me actually just try giving it its own proper thing, so each graph can be bigger. Oh, 1 second. This one. That might just help, and I'll full screen it too, both of them. I just want to see it. It looks like there's a bit of a dip. I just want to like verify that the dip is real. Oh. I can print out the numbers as well. I was going to do that in a second anyway, but yeah, still messing around with this. Oh. These two look different. Why? Huh. So this is the training data, so yeah, the higher it goes, the more it becomes wrong. Whereas this, looks like there's a little something going on there, but it goes up differently, that's for sure. Very fascinating. Huh. Okay, I will go back to putting these back on the same thing. I did swap both of them, right? Yeah. Make sure I'm not that I'm doing this right. Let me go do xscale log. I'm just curious what that's going to look like. Oh, whoops. Still though. Wait, that didn't change the xscale, did it? Let me get back to the... Oh, because this one wouldn't have been affected by that. Okay. Huh. Oh, wait, no, I know why one was different than the other, because the xplot thing was only applying to one figure. That was why. They do look basically the same. That makes sense. And then having basically the same shape, yeah. Makes a lot of sense. But now I want to do one thing, and that is mess with the... I want to actually print out these values for the test version of them. Actually, just print them out all together. For the test version. So let's see. It does go down. No, it doesn't. I mean, yes, it does. Yes, it does. Okay. That's what I wanted to know. Okay, because this concept seemed weird. Like it doesn't make sense if the number always goes up. Because then it's like, yeah, 0 is the best number to have in this circumstance. Kind of, sort of. But the fact that the number does actually dip is good. Good in that I have more revolutionary information here. And the weird thing is that it's not very... other than printing it out, like as I saw, it's not as identifiable in the graph, which makes me think that I maybe should be doing something to this graph to make it more stand out. Because there's a tiny dip there where this number goes slightly down. Unless I have wrong error values, and like it should be the same kind of proportions, but a lot bigger or something like that. Which is entirely possible if I like messed up something in here. Double check that. All these say training, all these say test. These get reset, so nothing's being like, you know, copied from one thing to another. They do use the same weights. That was, I believe, supposed to be a thing. Because I'm applying the weights from the training onto the testing. Yeah. And I believe I've implemented this equation right. Oh, I think I also just realized something. This is the version... I get what this is versus this now. This is the version for if I want the bias term to be penalized, or this is that I'm not doing that. Okay, that's the difference. That's why it's like a modified version. Interesting. Yeah. Okay. All right, but yeah, we've made what I think is progress. I'd like to hope. So now what I'm curious of is one thing I just want to do. So first of all, I want to mess with the scale again. The X limit thing. Make it really tiny. So now this would be X lim. I want to see that dip more clearly. This I put in, let's go -1 and 1, frankly. See what happens. Excuse me, but there is a dip. Was it there? Wait, am I, well, put this back how it was. There is the tiniest of dips. I thought there was one right there. Because the way that these numbers go. 0.1 and 0.04, 0.1, 0.2, 2, 4. And this goes up exponentially, but this one is smaller. At a lambda value of 0.1? Yeah. Did I make the proper thing exponential? Let me double check something. If I were to have changed y... Oh, wait. No, y is how it's supposed to be. I forgot I inverted it, but I didn't set it back. Right? That looks the same. Is this actually doing what I think it's doing? Maybe I need to actually put it inside each part. Well, it definitely was making something, it was definitely making it logarithmic. It looked like the... No, it's not. I don't know why I thought it was. Just I thought like, oh, the fact it's going to 1,000, that looks logarithmic to me. That's not how that do. Does it need to be after plotting, maybe? Yeah, because I think it's actually the same thing with the limiting, and that's why. No, but that was doing things. I don't know. Did it? Is it doing? Oh, okay. Okay, that's clear that this goes backwards, except it shouldn't, I don't think this is supposed to look like it goes back. It's. I think I'm expecting a line that goes forward, but, like, dips down. So again, so the lambda's on the y, and the lambda has the logarithmic scale, and the error amounts on the x. Let me label my axes, by the by. Let's figure out how to do that. Python. Actually, I can probably figure it out. Actually, before I do that, though, no, I'll do this first. Is it something like label, bar label, or axis label? No. How do you label x and y axis? Python. Matplotlib label axis in. Teach me x label and y label. Okay, I was close. I tried. X label being x label is error average. Putting those capitals. Or average errors. I'll word it. And the y-axis is going to be lambda. Wait a minute. Am I misreading this? So if you have using a as a function of b, I'm potentially not saying x and y there. If you're graphing like a as a function of b, Usually the second thing is the y-axis. You usually word that as you graphing x as a function of y, not y as a function of x. Is the wording here weird? Because it makes more sense, I think, to have lambda. Lambda should be the x. I think this might be like a typo or something, or maybe I'm just, I don't know, I might be misreading something, but I'm like pretty sure that actually the, because usually you have x being the consistent thing, and then y is the what happens. Like, you know, x being days, and y will be like a height or something. So, yeah, I think I had this right the first time. Because I'm also expecting to see a dip, which only makes sense that it's the error that does the dip. Okay. So do the plot, go y scale log, x labels lambda, this is average error, give it a capital L, why not? With this, whoops, there. I mean, okay, actually, these should probably go with the title. No, not by copying, but by deleting. Almost there. Actually, might be there now. Oh, that's not like not what I wanted to be seeing there, but it did it. Okay, is there a way to do do something about like spacing? Subplot spacing. Figure.type layout pad 3. Okay. Sure. With the 3 just being some arbitrary number. Do I have to put it anywhere, or can I put it like up at the top? Oh, Does that do what I want? Didn't look like it. Putting it down here. Hey, okay, perfect. Now the amount I will change. Let's see if I can have it just be an int. Okay, that's perfect. Beautiful. Just a bit of being spaced out. In fact, even these, I might actually space out a little bit. Let me go, oops, this, back to this one. Anywhere where I have a graph. Yeah, that, there. And then, where do I do more graphing? Right here. Yeah, whatever. Actually, this can go up here. Okay. If I run this one again, just all these are going to be, yeah, a bit betterly spaced. I might actually, I wasn't going to label those because it was just X and Y, but I guess I probably should. Don't want to lose silly marks on that kind of a thing. Where I put this, I usually put this, yeah, where I had title. Just gonna be X and Y, but those are labels because these are just arbitrary numbers. They don't actually mean anything. What's the title here? Yep, once again, do that. Same thing on the part at the top right, printing the default things. Okay. Okay. You good? X, Y. This is sideways, but that's fine. They are labels. That's all they need. Okay. Oh, I didn't do that on over here, but I don't think I need to print the default stuff on this side, or like on question 3 here. I just haven't deleted those parts yet, but whatever. Okay, so this is still not right. I'm expecting to see something that dips, which is because I need to invert the scale things, the X scale. Yes. Okay. There we kind of go. Still, like, this dip here is not as obvious as I would like it to be. What happens? I'm curious what happens if I were to make the Y scale be a log. I just want to see what happens. That's not a thing I'm supposed to do, I don't believe. I just want to see what happens. Ah, there we go. This is what I would like to see. This is clear of what I'm looking for. Of just line go down, then line go up. I.e., this is best number. But based on the way this is worded, I don't think I'm supposed to necessarily make the average error be a logarithmic scale. However, another little eensy beansy thing is that if I don't have these on Matcha-chan, what you doing? Hi. This grass, like line of best fit kind of thing, with training data and applying that to a test data. It's part of an AI class, but this isn't really AI stuff. It's, I mean, machine learning in a way, but it's cool. What is best fit? So basically, having a bunch of points here, and then drawing a line that kind of like is the average of them. So it's kind of, it's not like a connect the dots thing, but it's like a, let me show you the other version of this. So taking this training data and this test data, make it big. Oh yeah. So a line of best fit is this linear line where it's like, look at this data and be like, try to find a line that, I know what you mean. Yeah, fair enough. But the idea here is that I take this data, draw the line, and then look at this data, and I don't do anything to this data, I just draw the same line, and yeah. Kind of like how if you have an AI, like you train it to do a task, and then you test it with similar tasks and see how well it does. So this is doing the thing with a linear line. It doesn't really match. Do it again with a, this is an attempt at a quadratic line. It's like, okay, yeah, that's better, but still not great. And then this is like to the power of 3, and it's like, yeah, and that's a line. So you draw the line instead, kind of. Yeah, so I use these dots to draw a line, and then I draw the same line here. That's the idea. And then I measure basically this sort of error amount, where it's like, obviously these aren't perfect, but it's like, how close did it get? I calculate, like, you know, it's like this one's slightly off, this one's slightly off, this one's slightly off, and basically that average, I'm trying to minimize that on the test set. Because here's the weird thing is that if I could do some really complicated stuff that could make the line be perfect here, get an average error of 0, but then be awful here. So I'm trying to, my goal here is by only looking at this data, effectively, I look at this data, but by only doing some calculations with this data to draw the line, I draw a line that minimizes how off it is on this data. So with this, like this is ta-da, perfect line. And for the record, with maybe there's more complicated things I could do, but this is in the context of a school thing. Obviously, I'm no master of programming in terms of like making the be-all, end-all perfect thing, right? for sake of example. Anyway, so then if you were to go a step further though, so that was drawing a line that was like to the power of 3, which normally, if I go to Gizmos, graphing calculator, so like first, you know, line of best fit like this. Then I drew a line like this. It was quadratic. Actually, technically, well, it was negative, so it was more like this, but quadratic. And actually, it was like, you know, more stretched out, so it would have been like, you know, that kind of thing is what you saw with the second one. Third one was like this. You know, that's like stretched out. And I'm just putting in numbers to kind of make it look like what it was. So like, I would do more messing around, but like this resembles very abstractly what we had before, what we had in this thing. But now I tried to make it to the power of 4, and which looks like this. And actually, if you do more stuff, it ends up looking like a W shape, giving me tangent vibes. Kinda in the ballpark. I do 3 plus x power of 2. This isn't doing what I want, but like normally, like most ways that you would see this, it looks like a big W. I'm trying to mess with values to get that to happen. If this was negative, if this was negative, there's the W. Hold on. W, there we go. Yeah, tangent stuff, yeah, oh. I was hoping by making it upside down it wouldn't, anyways, what it looks like is not the point, but this was super stretched out. But the thing here, what I was getting at, is that making it to the power of 4 actually makes this slightly worse. When I do the calculations, this is a worse line than the one that goes to the power of 3. Mainly like over here, you can see it's very far off, where the other one was like a lot closer. So doing stuff with that, or bringing back to the this is the power 2 one, this is the power 3. Yeah, it's better over here. Better on the, and when I say better, I mean specifically better on the bottom one. The bottom one is all that matters, conceivably. I want the bottom one to be as best as it can be. In a nutshell, the AI guesses the dots, kind of. Except I wouldn't call it AI. It's more hard-coded than that, I guess. Just want to be clean. Yeah, that's it. I guess, yeah, it guesses the dots. Kind of. Where these dots could represent actual things, like, I don't know. But just say, like, but said that like I had an example. I could think of one, whatever. Anyways, so it's actually looking at these dots to predict where these dots are gonna be, I guess. Like beans. Yeah. Yes. I don't see any Among Us characters in here. I mean, this guy's kind of Among Us looking, but oh, by the way, I don't know if you've seen this in a while, but tightrope thing. Except that I have some commented up code. Actually, we get out of play mode. Whoa, that's a different thing. Lots of cool Unity stuff have been also going on. Very, very cool. That I'll be returning to at some point, but I got lots of complicated stuff. Woohoo! Except more letters. Yes. Okay, so yeah. This is this, and it's very awesome. Shazam! Lots of very, very cool things going on in this. And I stick the landing. Oh. Did I comment it? Oh, no, okay, I think I was fine. But, what the stick doing? He will be a person eventually, someday, somehow, some way. But for now, like, the unicycle looks cool and is more not placeholder-y. But eventually, yeah, there'll be an actual person at some point. Or a bean. I intentionally did not make this guy red with a white face. I did not repeat the same mistake. I almost did, funnily enough. And then, yeah. Actually, this guy went through many random color changes as I was, like, comparing, like, okay, here's some old player movement to some new player movement. Let's slap on some new colors. Like, this guy started as, like, green and, no, blue and green, and then he became this yellow and purple. Then he almost became, like, orange and green or something. And then that didn't happen. I don't know. These are all placeholder things. Like, the actual guy would want to be more of a human and would be wearing more circus-y attire, like looks kind of like a member of a quartet. Yeah, so that's that. This right here is the only actual animation in the game. So, yeah, that's there. So that's that. Okay. What am I doing back to? Over here. I have a million things open, but yeah. So now, taking this, continuing over to here, doing something called regularization, which kind of, sort of, has to do with... Oh, let me go through some of these today. I don't even know how to describe this because I barely understand it myself. This is just a school assignment where I'm doing what it's telling me. But essentially, this has to do with there's so when you're trying to do this line of best fit, there's too low is bad. A straight line does not cut it here. But also, music making me trippy. Ooh, this is Super Mario Sunshine music right now. Actually, it was just playing was of the final area music, which is called Corona Mountain, which is a very name did not age well. And right now, actually, this is the final boss music that you only hear for 10 seconds because the final boss is so short, so you can beat it really fast. But yeah. And does this sound like music where you'd be fighting Bowser? Corona, yeah. Actually, it's spelt the same too as well with a C, but volcano-y. Volcano. I don't know where I was going with that. But yeah, anyways, right now I'm doing something called regularization where basically, so it's bad if the line is too straight, but if the line tries to be too bendy, that's also kind of a problem. So there's a perfect sweet spot, which for this specific sample, it happens to be 3, but I think I'm pretending I don't know that. And doing calculations that eventually ends up going hey, the best thing is 3. I think that's where this is going. Maybe. Or maybe not. I'm actually not sure. I'm not sure. We're working on it. I don't entirely know where this is going. I'm making guesses. But anyways, right now, though, we have this graph that does things. Basically, I think it's I don't know. Frankly, I'm pretending I know. I know. And I knew more with what we were doing before with the line of best fit stuff. This time, I'm less understanding the relevance of why this is a necessary thing. But I think this is going towards kind of a... the larger order that we have, the more it's kind of penalized for to try and have it go high, but not too high, to help it find that sweet spot or something like that. Yeah. And for the record, this isn't really a learning thing. It's like machine learning. I would not call this AI. I mean, I guess you can under some definitions, but I think eventually later in this class we'll be doing more actual training algorithm things, which would be cool. Okay, so what was I just doing? Oh right, just messing with scales and stuff, and just that I'm pretty confident that so you can't really see it. Sorry, I just woke up. Fair enough. Last night I was streaming quite late, so yeah. And I fell off my chair, and that is, I think, my funniest clip right now. I was going back to grab something, and my chair fell over, got caught on something, and yeah, that clip is around somewhere. But so yeah, with this, what I'm trying to do is just the fact that you can't really tell it, but lol indeed. There's a tiny dip in the graph here. It goes down slightly and then up, and I'm trying to better make this dip apparent. I don't care about this graph. I mean, I do a little bit, I guess, but I more so care about the fact there's a little dip here. But I'm also not doing things that, my assignment doesn't say I need to. Yes, lol. Oh, Francesco. Yeah. Cheese dip. Ain't no cheese dip here. Oh, this is credit music. Okay. Sure, why not? Usually, I have... my oh, I have so many tabs open. Actually, oh no. It is... 1 second. Already did. Okay, yeah. My stream music playlist. I'm just adding random games OSTs to. Okay, so what was I saying? Anyways, this here looks better for showing this dip, but I don't know if I'm allowed or like I'm supposed to be changing the scale of this. I mean, I guess I can. I was told to change the scale of this to be logarithmic, but yeah. Mainly, yeah, the fact that there's a dip here is like, ooh, that's a thing. Anyways, this equates to 0.1, I think. I'll worry about that later. There's a bit of a writing component to this that I have to do alongside this. Not that much, it'll be like some sentences of explanation, but I'm gonna worry about that later. Like, I'll do that off screen. What is this thing? I don't know what this is from. This is from something during the credits. That would be like... When does it have like a big wind sound? I don't know. Whatever. Anyways. What's that? Oh, I'll definitely let this play through. Acapella, baby. Anyways. Okay, what was I just doing? I think I'm done with this. Yes. Oh no, right there. One thing I wanted to see was, without scaling the y-axis, that's not the right buttons. My favorite one? Oh yeah, me too. Yep. I've completely forgotten what I'm doing. I wanted to take this, but then have these be on their own separate graphs and see if I can see the dip even when it's normal, when they're on different things. Okay. So don't do the subplot. Instead, go this and this, and I think they'll be their own graphs now and full sized. Yeah. So yeah, if this is full screen, you can't really tell. Now, one thing here is that you can see here that it's going like line, line, line all the way through, as opposed to being more smooth, but that's just how this is. It's fine. Because it's basically like all the points I care about is drawing straight lines between them, and then I'm looking at how it's curving to make that happen. Yeah. Anyways, but I'm gonna go back to how it just was, because I think it's better. Like this. Double checking that is working, and then I think we move on to the next part. Booyah! This, which is a 0.1 for the lambda value. Okay, no. Before I move on, do I want to mess with any of these? Or, like, optimizing this a bit better. I don't know if I necessarily need a lot of this code up here, but I'm not going to delete it yet until this part is done. Right, so... regularization on training. Training is... Actually, that's not even true. I do this on the training and the test data all in one chunk of code. How do I want to split this up? I mean, I don't... Doing things in its own functions does make this more complicated. Unless I... This could go in a function, and then all this will go in a function. So regularization weights is what it's gonna be. See, this is why I don't grab a full game playlist, because okay, now it moved on. It's just like playing random like sound effects and stuff. Or that's what I did initially because I was lazy, but then now I was I'm swapping them out for for individual level music things, and they don't have to be great because I'm trying to have the playlist be like as long as possible so we get as much variety. If I pick only like the best of the best and there's only like 20 songs, that'll get repetitive fast. So I'm like, this is fine. Or take this. Here's a game. Take every single level. Bam, put that in. With some exceptions, but yeah. Anywho, and also things that don't get me any copyright trouble. Like the Cuphead OST is more problematic. I try to stray away from ones that sound more like songs. Like a Cuphead, like has really good orchestral music, but there's certain like songs in games that sound more song-y, like the main theme of Super Mario Odyssey, for example. Not the main, I don't know if it's the main theme, but the one that's like in the festival. I don't know if you call that the main theme. Speaking of... No, this isn't that, but speaking of Super Mario Odyssey. That's funny. This is the 2D music in the wooded area. Cuphead OST is moi? Yes, it is, which is why I had that on this playlist at one point, and then I got some copyright claims, so... Which is not, like, really a problem. I don't know how it affects Twitch. For the record, I don't think I got any of that on Twitch. I upload the VODs to YouTube, and I got copyright claims there. But I'd rather just stay safe. I'd rather just, like, not have to worry about it. Just don't have music that is going to be copyright claim issues, and I don't have to worry about if it's going to cause a problem down the road or not. Which, yeah. Anyways, do you know how strict Nintendo is on copyright, Amal? So far, I haven't gotten copyright claimed on any Nintendo-y music, so I'm gonna keep that way. I would bet, though, maybe, that the what's it called? It's like Jump Up Superstar or whatever. That would get claimed, probably. Maybe. I mean, I could be wrong. Here, I've just been reminded of a thing. Let me see if my VOD from yesterday got any copyright claims. No. Oh, no, it says check still running. So as far as I'm aware, currently there's been no copyright things on that, but when you upload a 9-hour video, it takes a while. But yeah, I'll be able to see from that. It's basically like my... I mean, all of these should be claimed because it's copyright, but it's only luck it's not detected. I think more so because it's video game music, and from prior knowledge, I don't know, from my experience of watching other YouTubers and stuff, video game music tends to be fine. Like, I can think of many examples of YouTubers that have Nintendo-y music in the background, in streams and video stuff. Doug, I think Scott the Woz, and I have at least one more example. I know I have one more example. Small Ants. I have one more, Game Theory. I know that Game Theory has had some Nintendo music in backgrounds of some things, usually, or Mario gamey or Nintendo game-themed videos, but, yeah. Funny thing, actually, I don't know what video it was, but ages ago, I remember that, so I have a game on Steam called Washed Up Wizard. All the music in that game is royalty-free random stuff I found on the internet. I remember at one point, in some Game Theory video, background music of a certain part being some royalty-free music that I had in Washed Up Wizard, and that was really funny. I don't remember what the video was, I don't remember what the music was. I mean, it was like one of like 10 things, so I think there's 10 different pieces of music in Washed Up Wizard. I think it was the music of this circus level? No. I don't know, it was something, but anyways, but yeah, I just remember that being really funny. I mean, but yeah, in terms of copyright stuff, hopefully we're fine. If I'm not, then it'll be a learning experience. Yeah. There's some Shovel Knight music. Anyways, okay, what was I just doing? I was in the middle of something, and I'd forgotten what it was. This code is still running. It's not in the middle of being broken, right? Yeah. I was about to turn some functions into... or turn this chunk of code into different functions. Yes. Oh, wait. This is... Wait, did I do it? Oh. Okay, yeah. Wait, no, hold on. Over here. Yes. The short answer is no. Using someone else's copyright material without permission to use the content in question is a copyright violation, and that includes video game music. Again, as long as it doesn't get clipped. There's certain, there's some things to it. I don't remember the exact rules, but I remember stuff I've looked into that, like... So, okay, I guess, like, the proper thing I should be saying is not, it's more so, am I allowed to have this music in Twitch stream / YouTube video without it being claimed? Which the answer to that is yes, and for now, that's all I care about. Not that I'm trying to steal other people's music, but I think video game music is fine in that domain. I don't know. I wouldn't consider that. Like, it's not like also, yeah, it's not like I'm stealing someone's music and claiming it as my own. I would not take, like other video game music and put that in like music in my games, and except maybe if it's like a game jam game or I need something small. Anything I'd be selling for money, I either would find royalty-free music, which would be fine, and you know, I would like to make my own music, but I'm developing the talents for that. That's a in development skill. No, but no, I get what you're saying though. Yeah, but I think I should be fine with this for now. And my proof of, not really, I guess proof, my claims for that is that I haven't been copyright claimed so far, and I'm aware of other YouTubers who, to my knowledge, have used similar music and also have been fine, apparently. I mean, because it's also the whole thing of people who do Let's Plays and all that, you don't have all of their videos getting demonetized necessarily. Some exceptions, sure, but in the grand whole, you don't have every single one getting like copyright claim for music of like, they're playing a game and then the music in that game getting copyright claim. It happens, I'm not saying it doesn't happen, but it doesn't happen 100% of the time, is what I'm saying there. Anyways, yeah. But, yeah. Now what was I doing? Keep losing my train of thought here. This. And I am putting this in its own function. That was it. Where this is regularization, draw graphs. I just graphs. Draw graphs. I don't know. Sure. Yes, except I'm gonna need to, like, some of these variables need to go here, so I need to do some of the global things. I think it's these three that need to be made global. Actually, let me not delete those and copy them so that I can change them in a minute. Go wah. Go like wah. And then go like oh, and also for the record, I do know that there's some games where people have, actually, as an example, Crash 4, It's About Time. The people who made that game released the entire OST for that game for free on YouTube. And that is in this playlist, so that's in the, well, actually, no, it was until then I took that out and put in each individual level music as its own thing. But yeah, that's an example. And I think A Hat in Time, that OST as well. So, yeah, other examples of such things. Anywho, okay. Regularization, draw graphs. This needs those three numbers, and this needs to change those numbers. So this needs global at the beginning of all of these. Okay. Then I don't need the global part on these. No. I need the global part on any of this. Degree? No. Okay. What I do need, though, is to actually call these functions, because otherwise I'm going to be like, the function's not being called. What's going on? Okay. That's done. Okay, this is going to work. Let's find out. Should get the same thing, but just be better now. Okay. Perfect. Cool. I gotta fix this chat thing at some point of how it gets squished and doesn't go all the way around. I've attempted, but not successfully. I don't know. So I look into it at some point. Or, correction, I have looked into it. Was unsuccessful. I might try to look into it again. Anyway. Let me close some of these tabs of all the million things I have open. Don't need you. Don't need you. Don't need you. Don't need you. Or you. Or you. Or you. Actually, that's most. You need this. Okay. Identity matrix stuff. Yep. Okay. Cool. Am I printing out the average error here? No. Because I'm graphing them all. Okay. Yada yada yada. Okay, moving on. Next part. So, yeah, so plot the value for each weight parameter as a function of length. Excuse me? Each weight parameter is going to be the array of 5. Actually, there's going to be a new plot, so I'm just going to go, like regularization, draw weights, draw errors. And I just need to change the names. And then this, I'm going to copy this to start. Okay. What is this? Okay, so there may be misunderstanding with what this is asking, but let me do some of the starting things I need to do here first. Okay. Blah, blah, graphing. So I have calculated the weights, I can access them. If I were to try and calculate, so plotting the weight, each weight parameter, which I think there's 5 of, with this thing being a size 4, which is weird, with lambda being, there's 6 of them. Am I missing a value on the weights? Like, it says including the bias term, but the bias term is already included in that array of 5. Otherwise, it would be an array of 4. So some number I'm supposed to ditch off this. Otherwise, that doesn't make sense. But I just weights. Let me go change this while that's on my mind to do such things. Yeah, weights. Weights is on the Y. But this is going to have a problem because it's going to tell me that they're incompatible sizes. No, what? Excuse me? Wait, or maybe I'm mistaken. Maybe it actually is the correct sizes. Oh, no, wait. No, it's not. Now, there we go. Yeah, 6 and 5. Never mind. It was applying the old ones. Yes, of course. Let me actually have it not do that for now. And also, let me just rename the graphs while I'm at it. This, something like that. Okay. So now I need to. So now if I go run this again, nothing's gonna change. What's sparking me as odd is that the weights here. So these lambda values, it tells me to have them be 0.01, 0.1, 1, 10, 100, 1,000. That is 6 values. So the lambda values do not change. I can't change what they are. So they need to be this array of size 6. The weights, on the other hand, so the weights have to be 6. But I thought that including the bias term. Okay, I guess I have to add another term of, let's go, weights dot append 1. The bias term would be that's a 1 usually, right? I think, maybe, or do I have to calculate what that is? I'm just gonna have it be a 1 and hope for the best. Let's see what happens. What mean you don't have an append? How have I added to this in the past? Or do I just go plus equals? Is that what I've done? No. No. Oh, for here I need to go global weights. Okay. No. You shouldn't have a problem with this if I've potentially now made you have the same size. I guess I didn't. Oh, now you recognize having an append value. What? Oh, it's because I didn't. In order to append, did I need to do this because it's like setting something? Okay, hold on. I just need to Google this. Python numpy append. You do have an append thing. Oh, I need to pass in. Oh, just how I'm calling it is wrong. Insert elements into array. Or value is intended to be a copy of this array. Okay. What's the difference between this and this? Okay, so if I do, you're saying that if I do this, all right, I don't know if the brackets need to be there for that. Has no, you do have an append. I just was looking at it. What do you mean? I think I just have the input wrong. No. What do you mean? How am I using this wrong? Look, just go to another thing. Do I need the axis part? Is that required? No. This looks like you have an append. Oh, it's np dot. Oh, I get you. It's not the name. I got it. I'm an idiot. Yep. Got it. Okay. I think I have to go equals. There we go. And now maybe the one brackets, maybe not. There we go. That's not right. So to start off, I should unlogarithm the axes, which I don't know if I should be doing it to. Let me do it to both, and then I might bring one of them back. Yeah. Okay, so this is the same dip up over. I might want to do a logarithm on the lambda part, yeah. So that's going to be on the x. Okay. Ah, that looks more like recognizable data. Yeah. Perfect. Okay, that it's promising, I think. Okay, so I mean, this number is the lowest. This number is the highest. Cool. So, actually, the one thing I didn't really consider is just that should the weights have been the one that I added, the bias term. I actually just realized I don't know if that should be at the beginning or at the end. I just want to see what happens if I reverse these. Yeah, not like that. Just want to see what this. It's like, can I do this? I think I can, but I don't hope so. Does that with this number being the highest now, and this one being the lowest. It didn't completely break the data, and that's almost concerning because that's making more an uncertain position of what this is supposed to be. Now it says W0, like it's the first term, but with the way that I've done this, or with the way that the weights are, like W0 seems like it would be at the other end. Like the far end, because the first thing is like the bias. Well, I don't know how the weight with like x to the power 4, and then x cubed, then x squared, then x, and then a constant. Which I thought that constant was already there, because that's what that constant is. I thought that was like the bias term. But that makes it only have an array of size 5. It needs to apparently have an array of size 6. So, plot the value of each. Plot the value of each weight parameter, which is I think would be each element of the array, including the bias term W0. Unless that's something completely different, I have to calculate what that is, which could very well be the case. Like it's not just like a random one. Let me look back at some of these equations that I screenshotted earlier. None of them. This one has a W0, but there's no way I have to like rearrange this equation to like find out what, like to W0 equals that and then find out what that is. Unless I'm supposed to. Other idea is that. Okay. Unless I'm supposed to calculate this instead, because this is calculating double W, where this is an identity matrix where you put a 0 in the first thing, and that makes that effectively getting rid of the bias term here. But if I don't do that and use a normal identity matrix, and I don't know why that trickles onto doing this, like not having the t there, but not being a transpose, not having that part. But if that makes me have a different size, I don't know why it would, other than this. If I calculate this and I get a different, like I think it's actually an array of size 6, then maybe I will get what I need. Well, yeah, let's try it. It's worth a shot. This looks like data, but I will try, because this felt too simple. Because for context, this is worth the same amount of points as the initial regularization stuff. So this felt too simple for how much it's worth. So that's why I'm more like, am I doing something wrong here? But either way, I will keep what I started with, which I think also will be the one on the other end, because I think that makes more sense. Because it's equivalent, it's analogous to adding like the column of ones on the far side of the features. But yeah, and definitely also not being my scale there. Okay, I also don't want to destroy this, so actually this will be the same. Just getting rid of this, doing a new weights calculation, and hoping that it's fine. So this is where I calculated these weights. So let that be as it was. And then down here, regularization weights with bias. Whatever. Okay. And actually, these need to be reversed. This still isn't that much different, I don't think, but this is worth a shot. If this gives me an array of size 6, then that would be good. If it gives me the same array of size 5, then I'll be more concerned. Or I'm more dismissive of this being something that will work. But, yeah. Anywho, okay, so weights, blah, 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 blah. What do I need to change here again? Okay, so the formula, which is, this is the first part of multiplying this and this. Then I calculate like this part, which is, I take this identity, I think just be taking this to start. And if I'm doing that, I don't need this to be 2 lines. I mean, I do. I don't, yeah, I'll leave it how it is. This, that, then, weights being blah, then it's power 1, that part being the same. And this part changes where I just take away the T here, supposedly. Actually, because of that, I'm actually gonna sort of space between here and here for the can. What's the other part that does the same thing? Quick maths! Yes, yes, Mata-chan. What was this? I don't know. The spacing. I'll come back and comment a lot of this eventually. Okay. Okay, so with that, I also need to make sure that because I'm recalculating the weights here, I need to make sure that I don't, things get reset from the first time that I calculated them, which specifically means I need to just, I think just, yeah, resetting these lists. Good. Because even the error, oh, I don't need these error values for this part. I don't need them. Wait a minute. I've been changing the weights, but they're not going here because I'm not going global weights. Oh, that's a problem. How did that not cause problems before? I should be going global weights. Was he using the weights from the first calculation? Huh. Oops, that's been wrong this whole time. Great. That should be here. And yeah, it's more important than these ones. It was the first, I guess. Okay. And yeah, global weights, and that's a global variable. Yes. Okay. Blah blah. These two aren't needed for this part. This I need to make sure to reset before I go up in here. Append. Blah. I can skip these calculations because I just don't need to do them. Just do the weights. That's all. And then drawing them, this does this. Except this doesn't change it. It does if I append, so I won't delete that line yet, but this doesn't need to be here in its current state. So let's see what happens now. Because I recalculate the weights, this should be changing a little bit anyways. Oh, mismatch. In the multiplying. Which is, first of all, that I call the right things. Yeah. Okay, down here. Operand 1. What line is this? I'm guessing that it's where I took away the 295. Yeah, this is where I took away the .t, right? I can scroll a bit to see the identical version from before. Yeah. That's kind of what I thought would happen. First of all, let me just bring it back as a test. So the only thing this is doing differently is having the identity thing here. But now this will still have a size of 5. But I still should have been changing that anyways. Yeah, so we have the same 6 and 5 problem. Yeah. So here's what I don't understand is how in the world either this is a typo, which it could be. I've seen some typos before in some of these lecture slides, but the fact that this has the T and this doesn't, like, the main change it looks like here would be that it's replacing this modified version of the identity matrix for just the normal identity matrix, so that it doesn't dismiss this biased term. Right, that's my understanding. But then, but then it still then has a size of 5 and not 6, which seems odd. 6. Yeah, I'm not just counting wrong. It's 6. The values that these are supposed to be. I can take a little screenshot of that too. Over here. These I can count. There are 6 individual numbers here. And oh, there's definitely something I'm misunderstanding here. I might have to go back scrolling through more lecture slide stuff. Trying not to. Unless... Do I have my W values reversed from how they should be? No. Maybe. In this context, possibly. It is possible. Hard to know. I have an idea, actually. To test something. If I were to take out these, I just want to test something here. Go back to these. Make it a degree 2. No. Oh. Yeah. Make it a degree 1, which means it'll have a weights thing of size 2. I want to be able to tell which side is it going to go slope and then y-intercept, or y-intercept and then slope. Just to have that. And is that intercept different than this bias amount? Which it might be. Possibly. Maybe. Still not letting me multiply things together now. I don't know why. I did not test this at all with the size of 1, but I shouldn't have needed to. Because if anything, this part specifically is more hard-coded to be of size 4. Or it can be. I have it that it can work for any degree, which is nice, but not necessary. Okay, in regularization weights, which is in here, 215, this part. What actually do you have a problem? Weights currently are the size of 5.5. Why? Because I don't recalculate the training data features. Got it. Okay. I would want to recalculate them here as 1. That's it. It's starting it off being like, oh, it's going to be of size 4, and then it changes to being size 1 partway through. I don't need this part because that's kind of what this is doing. Or this function just happens to not need the degree at all, so I don't pass it as input. Okay, right, that did things. Wait. It didn't give me any graphs? Oh, right, of course, it's not going good. That's not what I was going for, yes. Okay, regularization weights, where I just was. I wanted to just print out these weights after they're calculated, so once they're done... Wait a minute. Oh. Wait a minute, I'm an idiot. I'm not using these weight values correctly for the second part. I'm only using the last weights. That's not how this should be done. I am doing this wrong. Oh, I'm doing this very wrong. Fascinating. But that makes me more confused. Interesting. Interesting. Okay, so... Because for each lambda value, going through this gives me a list of 6 lambda values. The weights, I calculate these weights and use that to calculate this error average. That's fine for the first part of this. I think that was a-okay, no problems there. Where's the show part? Oh, that's here. Oh, I commented that out. Here it is. I just want to see this do the linear line. Not really, well, not these parts aren't linear, but it's effectively drawing a linear line and drawing these conclusions from that linear line. Interesting. Okay. So that's fine, but then going forward, and let me uncomment that line, going down here then to regularization weights bias. Yeah, this can't be right, because for each lambda value, I'm calculating these 5 weights with a this is fine. Bringing back the bias thing, that's okay. So that part was a correct thing to do, I think. But then as soon as I move on to a new lambda value, and then calculating them again, that's not good. Because then by the end of this, I'm only looking at, okay, what were the weights when the lambda value was its highest thing, which is 1,000. It doesn't correlate. So somehow I need some information for each lambda value. I need something with the weights, right? For each lambda value, I need something with the weights. Rather than for all these lambda values, I'm looking at the last weights. Problem is that that's a bunch of numbers. I need individual numbers here. So, oh, these are starting to die. Okay, well, oh well. Plot the value of each weight parameter, including the bias term, as a function of lambda. Unless... No. Do I... No. Well... Am I calculating all of them? Like I'm drawing multiple lines? That seems strange. Because... Wait, weight parameter, including the bias term, W0. But the weights here, that's not a single number. It's 5. It's the power plus 1. Is it actually? I think that's where that comes from. Yeah, pretty sure. Either way, yeah, this is of size 5. I can print it out. And double check. Oh wait, I did change this to be 1. So let's it's not even running that code. Let's put this back to being size 4. No. I wanted to actually test these numbers. I just wanted to see which one, left or right, which one's the slope and which one's the y-intercept. Which I should be able to tell that by the number that's like close-ish to 1 should be the y-intercept. Don't like that. I should be able to get this to run without errors even for a linear line, so that's another little quirk. Or at least I think I can. 496? Oh, that's not, or did you start having problems? In regularization, draw weights, plot. Oh, in the plotting thing. Okay, you're trying to plot stuff where you have problems. Oh, no, yeah, I knew this was coming. Where is that? Down here. Right, let me just stop grabbing things for a minute. Is this gonna just have empty graphs if I just only comment out those parts? Yeah, it's fine. But I don't care about these, I'm caring about what's being uploaded. Okay. Okay, so... Yeah, okay, so this is what I think this is what I initially suspected. Where is it? Like, which of these numbers is a slope for a line, and which of them is a y-intercept? I'm pretty sure this would be a y-intercept. Let me kind of double check. I'm going to go 2 Desmos. The thing that makes me uncertain is just that this number also eventually gets to being this around 1 number. So if I go 0.76x plus 4. This is a line I could expect from such a thing versus the alternative, which is, I guess I'll put in the actual 3.7-ish. Yeah, and then 3.7x plus 2.76. Yeah, I'd expect it to be shallower in this case, I think. Yeah, okay. So no way, even when this one goes that low, this one still stays in that range. Okay, no, yeah, that's fine. So it's actually, so it is the same way I thought it was from before. Okay, that's good. Just wanted to, like, make sure of that. That's what I thought, what I predicted, wanted to verify. Okay, so back to here. So I printed out these weights. So what needs to happen here is plot the value of each weight parameter, which is, so of each of the 5 values, with each as a function of lambda. But so am I printing, that's 25 values. Now it's 30. 30 values, so it's times 6. But I have 6 x values, and hey, Atkinstone88, hi, thanks for the follow, I really appreciate it. Woo, hi, hope you're enjoying this stream of me just fumbling around trying to figure things out here, but I am getting there, I think, hopefully. Now, the problem here I'm stuck on is just kind of understanding the poor wording of this thing that I'm going off. This is, I'm doing a school thing, but I'm not showing the school thing on screen because it may not be a smart thing to do. I don't want to get in trouble with my school. Especially the thing I'm paying tuition to see. I'll read it aloud all I want, but... Okay, so what was I just saying? I have 30 y values and 5 x values. That does not work. I could get an average, but that definitely doesn't seem like the thing I should be doing. Unless... plot the value of each weight parameter. What's weird is that that's singular, which could be a typo, but there's been some typos in this, so I wouldn't put that, like I would, yeah, use that as an absolute. Am I supposed to be doing something here that's giving me a single weight parameter? It includes the bias term, W0, which I did recalculate the weight so that that is factored in by just not getting rid of it. Specifically, I had to do extra work to get rid of it. I just had to get rid of that for this section, where earlier I had it, as a function of lambda. Where, again, 6 lambda values, 30 weight parameters, 5 each. That's just basic multiplication. Go back to the drawing board and be like, am I misreading something here? I did bring back the .t. I didn't. But does this actually give me some different number? Does this actually make it an individual single number? That'd be great. No. No, because, yeah, it'd be a mismatch in not having the right dimensions to multiply together. That's a problem before. But let me, what are they? You don't like, yeah, this. At this point, though, print both of them. Hang on, I only care about the shape of them. It's fine that that one's not being colored. Yeah, so it's a 2x2. The weights are a 2x2 currently, apparently. Really? Wait, really? Oh, because it's linear right now. Hold on, let me put it back to being the degree 4 that it should be. All that. Okay. Yeah, line, where am I going again? To line 357? Can't believe this has gotten that long. Oh no, that's just the calling of this. 298. Dang, I've been doing so good with not getting this stuff. Well, I've been stuff earlier in this, but I've been making through it. Now I feel like very uncertain. Again, mostly because of poor wording. Is this the one that's supposed to look like, looks like the circle? Oh. No. There is this. No. Surely not. Here, 1 second. There's this. There's no way that this is what I'm gunning towards. I'm not drawing circles here, am I? Where this is represents the different lambda values, like and how far it's going out. I just noticed that the axes xi of these are like W1 and W2. And I don't know. But what's strange to me, well, currently in the immediate right now, is that there's no way to make this work how I have this set up currently, because the numbers just don't multiply together. Like, getting rid of this T is a problem, because this is not a square matrix. Oh, one headphone died. Okay. Still got one more. Then I switched to my wired ones. For those unaware, this broke recently, which I was going with. I've gotten new headphones. I'm getting new headphones, waiting for them to arrive, but yeah. I got some wired ones in the meantime, as cheap as I could get. But yeah, whatever. It's fine for now. I can manage. What am I missing? I could start Googling things. I'm just not even sure what I would Google. Go through. And these are like lecture note stuff of like things I've done like inside my classes like eons ago. Nah, but like I do not remember, as I've been doing so much other things in other classes since then. Am I supposed to have something here I'm missing? I could get the magnitude of W as like it being a vector, maybe. Something along those lines. But that also seems wrong. I'm misreading here. I'm almost glad that initially I had that 5 and 6, like almost thinking it was right and then not going with that, because that would have been very incorrect. Which, yeah, good. Yeah. Plot the value of each weight parameter, including the bias term, as a function of lambda. I have the lambda values. That's not a problem. Lambda is the zero, like these that I'm going between, using logarithm stuff. But like this is not as a function of lambda. As a function of lambda implies that it would be the x, right? Like lambda is my x, my y is some weight parameters. What am I missing here? So if I go back to this with the t, I get a thing that's of size 5. Unless I make 5 different graphs somehow. But that also doesn't track. That can't be right. I don't know, start Googling things. I don't really want to like, my brain also. I don't want to just be, I don't want to be sitting here on stream humming and hawing, but that's what's currently happening. Okay. See, I have more stuff I could look into with some of my lecture notes, but I don't want to be doing that on stream either. So I might like take a break for me to look more through some of my notes and stuff. Things I can check and then come back to this when I have a eureka moment, but for the best. Yeah. Yeah. Yeah, it might be better than me, again, just sitting here humming and hawing. So yeah, I'm gonna cut away for a bit, figure this out, and I will be back when I have a breakthrough, hopefully. How much longer will I stream in general? We shall see. I was hoping to finish this tonight, which I'm very close to doing, which would be great, because I also have more work to get done, so, but we shall see. All right. I'll be back when I have more stuff to try. See you momentarily. All right, I have some ideas. Let's get that and this and this and that. That's not playing. I'm not hearing that. Why? Was that because I did this? Hold on. 1 second. There. I can switch back to this. There we go. Okay. You guys may have been able to hear that, but I couldn't. And we're going to do this. Okay. So, thing I realized is that I'm pretty sure that this equation, I think this equates to a number. Like a single number as opposed to a matrix. I think all this math makes this a single number. I might be wrong on that, but that is the next thing that I want to try, which means converting all of this into an equation to do math with. Or like, turning this equation into code. Okay, let's do that. So I don't remember the name of this, but we're gonna do that in here. And if that gives me single numbers, then we're golden. If for each lambda value we get a single W, that's like a combination of all of them to some degree. Okay. So, yeah. Where do we start? Oh, we're setting the lambda values, going through them again. I guess I don't really need to do this, but I will for now, just to keep each part separated nicely. Okay. All right, let's do it. So it's this. Then we kind of start in and work out. So first of all, oh wait. This uses the modified lambda thing. I don't think it should. One modification to this, I think, will be just that. Plot the value of each weight parameter, including the bias term, as a function of lambda. Which I think would gear towards this being just normal identity matrix rather than the modified one, because it's the modified one that gets rid of the bias term, I believe. I think so. Because, yeah, this is all the same equation, just all things being equivalent, but this is the easier one to turn into code. Right? Okay, so the way that this is initially written is to have this one be singled out. Whereas, yeah, I want to not do that, which I think is done by turning that back to normal high. Okay, let's put this over to the side. Cool. And do this. Okay, so we're going to start with the first few steps are the same. xt times x plus add in lambda times just normal, the identity thing. Then go add them together. I don't invert them, but this is where things change. Okay. I'm going to have a lot of multiplication and a lot of adding and subtracting. Okay. So what I would do is go weights.t, multiply that with this. No, wait a minute. Wait a minute. No. Oh, right. Oh. Right. I did all of this to calculate a W value. And I need to stick that in here a bunch. I forgot about that. Okay. Interesting. Right. That changes things slightly. So I need to calculate that W value like this. So leave that the same. This is calculating the weight with the bias. You know what? Because of that, we're gonna make it its own function afterwards. Where this is, I'm gonna bring back the .t here. I think I'm basically gonna give you a combination of these. I'm gonna use this one, but with normal identity matrix, not the one with hat. We're gonna see if this works. I don't know if it's gonna work or not, but we'll find out. So, wait, vectors. Oh, wait. I was going to make this its own thing, but I'm just realizing that I need to do it based on all these lambda values. Which is, I could just go through each lambda value, but... Here, I'll have this called this. Not like that. I don't know. How do I want to do this? I don't know. Whatever. I'll just stick it in one function. It's fine. Okay, so this is going to be a new thing. So this is the weight. These are the weights. And now we have a new thing that is parameter. Or weight parameter, I guess. Okay. So starting off this equation, going kind of inside out, I have to recalculate this bit and then go blah, da, 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 and then divide it all by 2 at the end. Okay. So this is going to start off by being just like this. I'm going to get rid of those. Up to here would be the same, starting. Okay. Oops. And then changing all weight parameters for weight parameter. Yeah. I don't need to calculate lambda identity a second time, so I can skip out on that. Yeah. I'll have to see whether I want it to be the modified one or not. But I'm pretty sure I don't, because modifying it gets rid of the bias term, but I want it there for this. Apparently. Okay. So, weight parameters equals, so multiply those two together, add on the identity thing, and then go another multiplying. Multiply weights dot t by what we currently have as weight parameters, and then multiply again by this by just weights. Am I gonna do all of this and then test it? I guess so. Okay, now there's an add. I'm gonna hope that there's a subtract of some kind, because that's what I need next. Cool. I think I can maybe stick this all in one massive line, but that would be messy. Especially when parts of this start to not work. It'd be nice to see what specific part is failing. Okay, so subtract what we currently have by... Oh, I need another term. I need another, like, middleman. Sub EQ, like sub equation. And I will need multiple of these. Alright. Yeah, okay. More multiplying. Oops. Okay, so this is gonna be doing weights.t by x, which is the features. .t, they're both .t'd, and then just normal y. Yeah, that's sub-equation 1. Wait, oh, I didn't realize, can I stick more than one thing in this? I actually don't know if I can, and I'm just gonna do it one at a time. Just one, like, operation per line will make this far easier to test. And then the output. Yeah. There we go. So now this will be sub-equation 2. That is going to be the, starting with the transposed y. I'm also actually just going to shorten the name of this. This is just sub-eq. And then this too. Or again, so it's starting with y transposed, and then x. I hope this works. We're gonna see. We're gonna find out. And x not transposed. If I copy this wrong, that'll also be an issue. Okay. This, and then I need weights. Normal, not transposed. Okay. Then sub-equation 3. Almost kind of there. Okay. So this is going to be y dot t, and then y not transposed. Is that all for that one? Yep. Okay, now to combine them all. So, weight parameters as it was, which is actually like the first sub-equation, but whatever. We're going to subtract this by sub-equation 1. And then we're going to subtract it again by sub-equation 2. And then we're going to add it to sub-equation 3, because that's the equation. That's what I'm going off of. I hope this works. Okay. Now that, as it currently is, we should apparently have a single number. I don't know how that works, but apparently. So then I just have to divide it by 2. So if this is a single number now, well, it's an array of size 1. Can I go divide? Divide itself by 2. Or multiply by 0.5 might be easier, but we'll just see how this does. And this should give me an individual number. What am I doing with this number? I mean, now I'll add this to a list of global weight parameters, where this is going to be, I'm going to add cur or current in front of all of this. This. Need to not miss any, because I'm gonna have some problems. Okay, so now that should be that, and then cur this dot append. Oh, because you don't exist yet. Okay, this dot append. Append this dot append the current one. Which those maybe shouldn't have an S on them, but whatever. Okay, so now we have these weight parameters. Now these are our y values, which means when we graph them, now I'm just gonna go jump straight into this. Be overly confident. It should be this and this. All right. I've just done a bunch of code without testing it all. Now watch it work first try. I wasn't expecting it to. I was so much more confident in it not working. What? How? Fascinating. But now this also makes me want to make this logarithmic as well, just to see what it's going to be like. Wow, I'm shocked. I don't know if it's actually, you know, the correct looking graph, but the fact that it ran without errors is a very good sign. I'm shocked. Okay, cool. I don't know how helpful this information is, but okay. Okay. Perfect! I mean, yeah, I don't have to append anything. Wow. Like, I don't know what to do now that it worked. Like, I have nothing to test and debug. Okay, Okay. Okay, one thing I just realized I probably should do is, like I do here, I should be resetting some of these variables, as opposed to appending indefinitely, if I were to recall these functions, which I don't happen to be, but it's probably good to do that a bit. Okay. Okay, well. So plot the value of each weight parameter as a function of lambda. Okay, I guess I've done that now. I'm more confident that this is, working. I, think this looks fine. Again, this is harder to tell. Like, I don't know what, this should look like, and like, once this project is done, I can, you know, revisit it later before it's due. But it'd be nice to just have it in a done state where I'm like, okay, I'm satisfied with this. I can come back to it later, but it's like done enough. Yeah. Okay. Like, and I guess this makes sense. Is wait, these are exactly the same. That's concerning. Did I actually separate them? No. Wait. No, I only plot one function for this part, I think. The weights are exclusive to the training. I don't calculate weights with the test data. Also, the lambda is a fixed thing. So that's one thing, is actually that this shouldn't be two graphs. This specifically should only be one graph. So no subplot. I'll keep the training data here in the name, but basically all of this should die. I don't know if I need the layout part, but I'll keep it for right now. Let's see what it looks like with and without. Oh, right, it's not going to run until I close these. Right, go. Okay. Cool. Uh-huh. Now, I only wonder if I was supposed to use that in any way. No. Alright. Cool. I'm confident. I'm much more happier with that than what we had before, because what we had before seemed very incorrect. This I'm more confident in. Cool. Alright, I think we can continue. To the next part where I'm gonna now be running into a lot of trouble, but, well, here we go again. For the last time. This is the last part of this. After this, then we're done. Other than going in, like, commenting and, I don't know, optimization and all that. But this is the last new thing to do. Alright, so... Oh, geez. Oh, wait, first of all, actually, I'm curious. I want to see what this stuff looks like on different powers. It doesn't have to run like this. It's fine if it errors. But, okay. Interesting. This one doesn't have the dip. That's kind of fascinating. It dips up here, though. Oh. That's kind of cool. Fascinating that it does that. Not something I would have expected. Okay. What about 2? I would expect that 1 might break, which is, again, fine. But I'm just curious. Like, better if it is able to handle it. Interesting. Fascinating. How'd that do? And then 1. Doesn't mean that these will be lines, but yeah. See what happens. Ah. And that. It did run. That's surprising. Genuinely. Yeah. This is still running with the order 4, but yeah. This has been looking different, right? This hasn't looked the same each time, right? This has definitely changed. And this is going off the weights that this is also using, so it should be. Alright, back to 4. Okay. Let me double check that it does look different now. Oh no. Is it different? It should look similar. Here, let me... compare this with 1. Because it's the whole logarithm thing, it makes sense why it looks like very similar. The way that it's like squished. But here, let me open up another paint thing. No, that's different. That is definitely different. Okay. That is distinctly different. Good. Good, 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 good. Okay, that's reassuring. Whew. Okay, back to 4. Alright. Onwards to cross-validation. That is what we're doing next. So, I need to do 5-fold cross-validation on my training data. Use it to determine the best value for lambda. Show the average error on the validation set as a function of lambda. And then, is it the same as the best lambda that we had before, which was, I think, 0.1. For the best fit, plot the test data and the regularized 4th order polynomial regression line obtained. Interesting. Okay. So, interesting. Yeah, okay. So for this part, what we've done so far, a lot of this was, yeah, test out what happens when we have different values of lambda and how it affects all this stuff. Yeah. But now, instead of hard coding values for lambda, we need to calculate what the ideal lambda should be. Now, from our testing, we determined that's going to be around 0.1. But I'm going to take it that, because we, like, you know, we're going to get an actual number that's going to be some, you know, in-between decimal thing. We shall see exactly how that goes. Okay, so... show... where do we start? Alright, 5-fold cross-validation on my training data. I guess we start there. I need to remember what cross-validation is, let alone 5-fold cross-validation. Okay. Un momento. Okay, oh, right, yeah, that happens, that has to do with, going up with each, polynomial, so starting at, like, 1, 2, 3, 4, 5, up until the one that we're testing with 4. Actually, no, it's gonna go up to 5, because of, that's what it says, right? 5-fold cross-validation, so it's gonna go up to, yeah, up to 5. So let me just make the function. Def, cross, I'm just gonna generically call it cross-validation until I have reason to make it more specific. Validation. This is gonna take a degree as input still. That's louder than the previous thing. When I do this, does it lower it for you guys? It doesn't. Interesting. When I do this, it does not change for you guys here. That's fascinating. eh. Although, just so I'm not getting drowned out, I will just turn this down a tad. I'll raise it up for the next thing that plays, but whatever. Okay. Yeah, I'd rather the music be too quiet than too loud, because it's just background noise. Rather than drowning out my amazing vocals. Whatever. Okay. So, randomly split the training data into K groups and perform the following procedure K times. Leave out the kth group from the training set as a validation set. Why don't I just use the test data? Okay. Use the other K-1 to find the best parameter vector WK. So to find just a weight, I guess. Find the weights using K-1. Measure the error of those weights on the validation set. Call this J. Okay. Compute the average errors, which we've done this before. That's going to be the same equations that we've used many times now. No, actually, no, it's not going to be that. It's just going to be generic, like, well, yes, it is, but of these new error amounts that we'll be calculating. Okay. And then choose the polynomial M with choose the order of polynomial M with the lowest error J. Okay. The amount of fold is how many we split it into. Got it. K is different than M. So we'll be splitting the data into 5 random groups. Are we still... we're still basing this off of order of 4. Yeah? Double checking. Use it to determine the best value for lambda. So how do we get lambda out of that? Did I not just read that it's to choose a proper, not a lambda value, but a polynomial value? Did I miss something? Excuse me? What am I missing here? Problem. Okay. I'm supposed to use stuff from the regularization part? Possibly. This seems more complicated. How do I get from... I see, like, the beginning of what I need to do, so I definitely have a place to start. So that's good. But how do I... So perform 5-fold cross-validation on the training data, and that will get me a best value for the nth order, which I know should be 3. I think that's what I can expect to get. But how does... The way it's describing cross-validation seems to be that it's a way to get the polynomial value, which isn't the lambda value. They might be related, but they are different. So how do I get from one to the other? I'm trying to kind of plan out my path ahead of time. Yeah. So you start with a polynomial M, which is 4 is what we're doing. Randomly split the training data into, we're doing 5 groups. Then leave out yeah, or no, yeah. Then go off of each one. Use the other to find the best parameter vector. Actually, what is the best parameter vector in this case? The best weights. Is that, oh, that's just, sorry, that's just finding the weights normally. Got it. Never mind. That's fine. That's easy. That's just copying code we've done before. And then measure the error. Yep. Okay, then I wonder if I can actually make use of some of the functions from before, but we'll see. And then compute the average errors. Yeah. And then choose the order of polynomial m with the lowest error j. Nowhere in there does that get nowhere in there does that get me a lambda value. Why? Test set, yeah, doing stuff with test sets, yes. Okay, I need to, I think, see more of this. Does that go into L1 regression or something? Or, I don't know. I mean, I already have a thing that is calculating lambda with a bunch of test values, and I could just find the lowest one, but I don't know. Yeah, what am I missing? What am I missing here? I'm missing something. How do I get from m value to the lambda value? Can I work backwards from something? Don't know. I mean, the polynomial value affects my weights, I guess, but still, definitely missing something. I'm not sure what it is. If I knew what it was, then I wouldn't be stuck like this. Choose appropriate lambda. Cross-validation is often used. Yeah, used how? It's not an answer. Okay, think. Okay, maybe I do need to apply this differently. So I can use. So the cross-validation is more so the I mean, could I use sort of cross-validation thing, but instead of going through each polynomial, go through each lambda value instead? And then measure the average errors, which is, and then choose the lambda value with the lowest error amount? I could, I guess, go through each lambda value, randomly split the data into 5 groups, test the thing with each of them, get the average errors, and then pick the polynomial with the lowest average error when doing that thing. But I'm predicting it's going to be the 0.1. Yeah. Show the average error on the validation as a function, set as a function of lambda. Okay. Is it the same as the best from before? Okay, that's what I think it has to be. Okay. Okay, I understand this, I think. Yeah. For the best fit, plot the test data and the regularized fourth order polynomial regression line obtained with the lambda value that we're going to be using. Which I still think it's not going to be better than L3, but, or not L3, order 3 being a cubed function, but what do I know? Okay, let's just do this. I can at least start this off. Maybe I'll get some new ideas as I'm doing this. Okay, so to start off, doing 5-fold cross-validation. I'll make this an input just because. What do I call you? What, fold num? Split num. K. Split num. Okay. So, what I need to do is, so if anything with this though, I'm going through all the lambda values, which are these. I mean, I could go through this. I could have this same kind of thing again. Let me copy some of this. Actually, let me copy the other one, because that's gonna actually be more useful in this circumstance. Okay. Okay. So, right, so using split num, so blah 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 blah. Look at this again. How am I need to randomly split the data, right, so let's start with that. Randomly split the data into this many groups. So how do we do that part? I mean, Python have a random class. In C# with Unity, I'm familiar with using random.range, but yeah, random range, okay. Does. But that's not what I'm doing. I don't just need a single random number. I need to take the data and chunk it up randomly. Wait. Randomly split the data. So it's not like I'm going blah, 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 blah. It's like splitting it all into 5 things. Right? Yes. Okay. So I need to, oops. Yes, I need to, whoops. No, I need to, randomly, split list into sublists. Yeah, sure. Stack Overflow, save me. Random.shuffle. Ah, my eyes. Yeah, bright mode. Whoa. Import random, okay. Random.shuffle. Problem is when I shuffle the X values, I need to also shuffle the Y values. I need to make sure that happens. Yeah, okay. Listening to 2 is preserving order. The number to take is drawn from a uniform distribution. Oh, jeez. Huh. Also, each time I run this, it's going to get slightly different numbers. That's fascinating information. This is shuffle. I think I'm fine with just, I can shuffle this with a seed. What I need to do is, where is it? I have the inputs, which are all the features. Oh, right, I need to shuffle just the rows. Right, that's to get a subset of this data. So, So what I need to do is sort I need to randomly shuffle this array some amount, only like the first row of it, or the first by each thing in the first column, and I need to shuffle this in the exact same way. So if I could shuffle with a seed, then I might be able to do that. Why is it so hard to shuffle this data randomly? Okay, yeah. Random seed. Okay. Just in. But that will make it happen the same way every time, so not as random. I would like it to be random, and then whatever random that does, do the same random, right? I mean, I guess it could. I generate a random number between 0 and 1,000, the first thing, and then use that as the seed for both of them. Oh, is this a built-in thing? Ooh. Oh, shouldn't, I shouldn't be, like, taking from too many libraries for the sake of this being a school thing. Arrange and permeate it setting. Oh, right, because it's also, again, I need this to keep the things, I like, You know what? I could almost recalculate the features after I sort the initial data. Or something like that. There's gotta be a way of doing this that's efficient. Or maybe I can just sort it from the features. And it's not just splitting it in half either. It's like, yeah, split it in like 5, right? I mean, I could hard code it to be 5, but I'd like good programming practices to have it not be 5. Oh, what happened here? I mean, I could have it keep generating random numbers and then get that from that indice. I would not use these. I don't like how it's forcing me all hunched over. I'd prefer to go back to these. This is more preferable. Turn them on first. Definitely got one with a cord too. That with a cord too short, but oh well. I'm not hearing anything. Bluetooth. Not about now. There we go. I don't think that affects the stream in terms of what you hear. So I have the dangling thing again, but whatever. This is preferable. So it's not bitter for my spine in the long run or something. Okay. How can I do this? List. It's actually, let me. There's 2 separate bits to this because I need to go off of randomly split array by first column. So that's that. Randomly split a numpy array. Okay. Okay. It's giving some repeated things, yeah. Random choice. Oh, weird. Interesting. Fascinating. Again, iterating over the list, yeah. Okay. Huh. Interesting. Trying to, again, not use this. Yeah, can I adapt this? Can I adapt this to do this, 5 times? I don't care about the speed that much when we're looking at 40 items, which isn't nothing, but it's not 5,000. Or like the 40,000 that was there. Okay. Okay, right. So okay, yeah. So to clarify what I'm trying to do here. Okay. I have 2 arrays right now. 2 different arrays. I have the input that is input features. That is something like, 1. Let's go 1, 2. Actually, whatever, the numbers don't matter, but 1, 2, 3. Bunch of things like this. Yeah. Actually, they all end in ones, but whatever. And then I have the output, which, some along these lines, as 2 separate arrays. In fact, technically, this is actually transpose. It's actually going out in just the way that they are. Yeah, these are going down. This is going out the way that it is in the code currently. What I'm trying to do right now is randomly, well, if this is 40 things long, with not so many repeats, actually there'd be no repeats because there's a lot of decimals, but I'm trying to randomly split this into 5. So take like, this, but like, evenly split into 5, or by some number that I choose, right? Where it's equal, or as equal as it can be, I suppose. I'm just realizing that if it doesn't divide evenly, in this case it does, but I guess I would care about if it doesn't divide evenly. So my idea, one idea that I'm currently looking into is to take this, shuffle it, and then then I have a thing where I can just go down, and then I'll be in business. Now the problem is that I would want to sort all of these by this first column of numbers. That's the important thing. These column numbers, sort all of this by that. So if I decide that this is going to go down here, it needs to be the whole thing that goes down, which means these 2 other parts of what is the same matrix and the output that's in the other array. So I guess first thing I could do, like one thing that might make this easier is if I were to append this all together to start, is make this a part of this. So I only have to deal with 1 array now, and that may make this easier. Deal with 1 array, do the randomizing, and then split it up, I guess. The second thing, well, it makes sense only do one or the other, but these numbers are actually calculated based on this number in the actual code when they're not random things here, where it'll be like, this is the number to the power 4, this is the number to the power 3, number to the power 2, number to the power 1, and then an actual 1. So I could go back to the original data set, which is just one thing of numbers and then a second thing of numbers. That might be easier to sort, and then I recalculate the numbers. I'm not sure. I don't know if I want to do that, because either way I'm dealing with this. If I append these to this, I'm dealing with big array that, like, it doesn't really matter how many rows it has, I don't think. So let me go back to NumPy matrix. Was it literally a NumPy.split function? Into multiple subarrays. I don't know if, like, one thing I just don't know is if it's, I don't know, very inefficient to combine them and then separate them, going through for loops to do all that. So I'm just trying to think if there's maybe a way I don't have to do that. I can keep these being two separate things and let them stay like that and just make this work. Okay, let's go Python, NumPy, randomly shuffle. Okay. This arrange. This takes a new code should use the shuffle method of a default RNG instance instead. Oh. Okay. Interesting. Standard normal. I don't know what this does. But fascinating, I guess. Generator.shuffle, which should be used for the code. I mean, if I can use this and So mp.random shuffle. This is, what is this? So mp.arrange 10. Again, I say, what is this? This is a different thing. This is just making an array to play around with. So this is, I think, making an array that's just 1 to 10. So I don't need that. And then this is shuffle that array, where I don't know, I don't have a seed for this unless I can pass in a seed. Which, no, along its first axis, which is good. That's what I want. Except, so this could work if I do combine and then separate. So ideally I want, if I can do something like this, where I can have a certain seed, which it looks like I might be able to get out of this generator.shuffle axis. Oh, this could allow me to mess up with which axis it is. Okay. Interesting. Okay. So I noticed this, default RNG. So it looks like if I mess with this, then I can, do things. Okay, let's try this. Okay, this looks like in the direction that I want. Okay, cross validation. So I'm trying to, the thing I'm shuffling is this, and where is it? Any of the Y? Okay. And we're gonna make new versions of these variables called randomized equals that, except not like that, but about to be randomized, right? Show this with some calculations in between. So first of all, it looks like I can do what this is gonna do. This needs to be this. So I don't know what this actually does. Construct a new generator. So parameters, a seed. So I don't want to put in a fixed seed right now, but I want just whatever it got. I want it to, if I were to do like this, it will reset to whatever it started with. Or, I mean, a funny thing I could do is use this to generate a seed and then use that as what I use for both. I'd like it to be random, but the same random for both of these, I think. But let's just see what this does. So let's take, so RNG dot shuffle. Shuffle. This. And then, same to this, except I know that this is going to have to be transposed because of the way that it is. Like it's going out, I need this to go down, and then, yeah. Okay, so let me print both of these and see what happened. Now, oh, I don't know how I'm going to actually know that it worked properly. That's going to be, let me just print one and just see, did it do anything? And not error in my case. Am I actually calling this? I don't think I'm actually calling this function. Yeah, that would make it not work. So 4 and 5 are what these will be in but a moment. Yeah, I don't need you guys. None. That's not a good sign. What do you mean? That's not what I was expecting that to become. Well, first of all, let me just turn off this so it's not going to draw any of the graphs. Do I not need twice? Or is having it twice messing things up? None. Why? This didn't get reset, right? This has values? Yeah. That looks different than it usually does. Maybe it's fine. We're gonna hope that it's fine. If I directly do this, I don't know. Let's see what that does. This is apparently being none. None. Why? How is this different? I doth not know. What's your problem? We're going RNG equals numpy.random default RNG, and then going RNG.shuffle. This. Why is it just not working? Oh, it doesn't return anything? Oh. It doesn't return anything, but it messes with this. I don't want that. I mean, I could do that, but I'm not gonna, I don't want to. I want to keep it, I want to keep the original as it was. So, I need this, and then this put in here. Yeah. Sure. And then, yeah, and then shuffle that one too. Dot T, put that, yeah, directly into that. Okay. Let's see what that's gonna do. Except it's still gonna print none, because I'm not printing the right thing. Let's print this thing. Numbers, yeah. Now again, I have no way of knowing if this is actually randomizing right. In fact, it's probably not. Actually, if I randomize this and then were to graph it immediately, that would be a way of knowing. It should graph the same scatter plot. So let's get to do that very roughly. Up at the top right, graph the initial stuff. Man, this is long. Jesus. Okay. So, just this. This part. Yeah. So, down here, don't need you, I don't care about the title right now, this is just to test things. Yeah. Input randomized, output randomized. If this worked, then it should look like, yeah. I can show it. Yes. When I do this now, it's gonna pop up with a million graphs. The last one being the one I want. Ooh. That ain't right. Okay. If I do this, this might reset the default RNG. Please. Oh, again, to close this, so it relaunches properly. Still nothing. Okay. Let me double check that the initial ones are graphing properly. Even with this one having the .t, which I think is fine. Oh wait. This isn't gonna work with it being features, right? No. Okay, so it is. Oh, okay. That did look like it was graphing the same thing. Interesting. Which means that I think it is working, but making this 0, that is actually going to be what I want. I'm pretty sure. Please. Oh. This then? Must be the same size. I guess you're not. This needs to be .t 0 equals that default. I'm using the wrong thing here. This is supposed to be the output. Oh, oops. That would make sense. Okay, well, either way, does this graph the line? No. And I'm not randomizing it. This is before randomizing. What do I do up here? Yeah, the input and the output. The input is not doing how I want it to do. Oh, because I am definitely taking the wrong numbers. It's supposed to be degree -1? Or... No. Wait. Yeah, okay. So this at row whatever, comma, degree... I want to do it all. I want to do in this column, do all the rows. That's why I was transposing it. Huh. Okay. Okay. Back down to here. Why? So, first of all, if I change this back to the input, it should work, right? Right? No. What happened? Wait, how's the input data skewed? When did the input data get messed up? I didn't modify this, presumably. When did this data get messed with? When do I ever go training data input equals blah? That never happens. Ever. Other than the initial getting it from the file, obviously. This. How is this any different than what I've got going on down there? Why? I'm confused. Just going back to like the basics of why is this not printing the number it should? Am I showing am I grabbing the wrong graph? Should be the latest one, which is this one. For the record, it should look like these dots. It should just look like these dots, and that's all. I did sort the data. Don't tell me I sorted the data wrong ages ago. This sort data, don't... No, this is before the initial graphing, so I know that that's fine. Okay, I guarantee it. Okay, cross-validation. 4 or 5. These don't matter, they're not being used. I don't know. Is this passing along like a reference or something rather than? Well, that's not how you do that. Maybe it is. What am I doing? What am I doing? That. Nope. Yeah, okay. There we go. Okay, okay, good. We determined the cause of this. So somewhere in here I've messed something up. So let me just start uncommenting lines. So my guess is that this is actually passing along a reference rather than a copy. So when I'm changing one, I'm changing the other. Yeah. Okay. That's fine, which I thought it would be, but gotta make sure when you don't know what's going on. Okay. So... yeah, just these. The lines that I know are fine. Everything but the shuffling, right? Obviously. Just doing this on its own wouldn't be a problem. Okay. Maybe there's like a... Let me see if there's like a numpy.copy or something. Aha. Does it just output? Yeah. Order... Yeah, okay. This, then over to here. Same dealio. Except this, not like that. Yeah, and I should be good to do this. So now we're good, right? Yes, there we go. Okay, perfect. Ah. So now we're trying to randomize the data and still get the same graph at the end, which I'm pretty sure is not happening. Well, actually, no, first getting this back to being using the feature data instead, but still doing the normal graph would look like this, maybe? This features, not defined, is it features? Oh, well, sure, why not? Okay. Cool. The same, yeah, okay. That's what we wanted. Then, replacing this for the randomized versions. But because these should be randomizing the same way, it should still be printing the same graph. But it's not, so that's the next thing that we'll figure out. Something to do with setting the seed. Yeah. Or at least I was hoping it would be. So let me try putting in a fixed seed. 2. Well, there's 1. I put this in as a... Yeah. But then if I have the same line, will this work? For the record, I can also just because I can. Reorder these. Make them both. Set the seed, shuffle, set the seed, shuffle. Good thing is no attribute shuffle. What? I'm just using it. No type. None type. Oh no. Is a convenience legacy function. Best practice is to not reseed a bit generator, but rather create a new one. Best for your example, best practice. Oh, I don't like all of that. I don't want to do that. I'm gonna keep this as it currently is, but so you're saying that what I do is this, but then go back to this being what it was before. What was it before? It was default RNG. And I don't remember if this was a thing or not. Oh, you take in a seed. Oh. Oh, it might just be that instead? Might be that instead. Okay. Hey! Yes! Okay. Sort of. It's not random the way I would like it to be, but, so we're actually, I'm gonna do a thing. Seed equals, oh, I just generate a random number. Dot, rand int. Oh, hi. Let's go with this. 0, 1,000. And this becomes the seed that I'm putting in here. So it's like, it's making it still random, but these two will be the same. And that's what I'm going for. Okay, and I can tell that it worked and that they are correlated the way they should be, because that's the same. Cool. Okay. So now, what now again? What am I doing now? I was doing something, got caught up with all this RNG stuff. Oh yeah. So I have the thing, I have these randomized arrays. Now I need to slice them up the way they should be. How? Or actually it's more like, it's not so much that I need to split it into 5 equal parts, it's more so go through a for loop, where in each for loop I have the initial minus a subset. Yeah, okay, so let's go for I in range 0 to split num. Yeah, then do something like the randomized split is going to equal, actually this is not what's taken out, this is going to be what's left, right? So double checking that is how I'm using this. I can just dump out what I'm getting rid of temporarily, or as long as I have like the original OG array on standby. Just double check. No, I measure on the validation set. Right, no, I split it up. Okay, yep. So this is gonna be, so this is going to be the training data split, and then we're gonna have training data validation. That's how this do. Let me do the validation first. So that's going to be everything in the range of, so if this is 5, it's going to be everything from 0 to 1/5 of the way through the array. Actually, it'll be a 4th, because like so you have 4 slices that like breaks it into 5 parts, right? So this needs to be, what does it need to be? Right. I need to do this just in order, because now the thing is shuffled. Okay. This subset, how do I take a part of this? Did I do it before? Dot range? How do I do that? How do I do this? Python numpy range. A range. Nope. Not that. Subset array, I guess. Especially, yeah, one that has multiple things being out. So how does I do this? There is a range thing, huh? Interesting. What am I doing? Oh yeah, I forgot that oh shoot, I forgot I need to attach to get the. I forgot that this needs to be input and output. So one thing, let me just do that real quick. Test data input validation, and then there'll be an output validation, which the output might be easier to do for the moment because it's less. Okay. Okay. Then output features randomized. So I mean, this doesn't work off like right away. And furthermore, I'd want this to be numpy.copy. But for this, okay, so let's worry about just the one-dimensional part of it for now. Slice data. One-dimensional, okay. Well, how do I do it? 3 elements. You can use that to select an individual. Yeah. But I'm not trying to get an individual number. I'm trying to get a range. This ain't what I'm looking for. Oh. Ooh. Oh, okay. Perfect. That's what I'm looking for. Yes. So, it is just, meh. Okay, actually, wait, so what is the range? What does the range now need to be? This needs to go from not 0 to split num, because that's going to go from like 0 to 5, but split num times the length. Is that right? No, length divided by split num. Or wait, hold on, no. What's the math here? It's not even 0 that it would start at. It needs to be So if this was, let's get me get some numbers here, and I can hopefully math this out what this should be. So this is for the validation set is the chunk in the middle, where then the split is everything outside of it. Okay. Yes. Okay, just double checking that I am calculating what I want to be calculating. Okay, so so let's say we have, or it's gonna be some nice numbers. If this is of size 20, the array is of size 20, and the our split number is 5, then we'll want, like, our nice cutoff points are gonna be, actually it's gonna be 4, or no, yeah, because it'll be, yeah, 5, 10, 15, 20, right? Because then we're gonna have the space in between here is 1, 2, 3. Wait, that's 4. I can't count apparently. If this was 4, it would be like this, right? 1, 2, 3, 4 sections is what we want. So it's gonna be so the end point of this is going to be whatever this amount is. So this divided by this is 5 times, okay, whatever our current I value is. So that's going to be our end point. Yeah. So split num divided by no, the length. This length. And I'm getting the length of the original thing, so it's less likely to have problems. Like, make sure I get that 40 in. I'm not doing anything with the two-dimensionalness of it, which is this. So the length divided by this is getting me that 5 multiplied by I. Yeah, that's going to be the end value. The starting value is going to be same thing times I minus 1. No, wait. This needs to be times I plus 1. Right? I think that's the range I want. And then what's left on the output is going to be everything in the array that's not this. I also don't want to just put this in here because I don't want to be messing with this data. But just in case, I'll go dot copy. Just in case. Less likely to have issues. Yeah, make sure we're looking at it completely separated. So now I need 2 different arrays. Like, I need this thing plus thing. I'm gonna do it in 2 lines, because if I go, like, plus, I don't... I remember that having issues. No, wait, no, in here I can just do, you can apply to add. What am I saying? No, wait, no, add is... No, I'm not trying to add. Append. Or, no, hold on. NumPy dot append. Values to an end of an array. Values are copied or appended to a copy of this array, and then the values. Yeah. So no, it's gonna be append this, comma, second thing. And I don't like how long that is on one line, but whatever. That's how it is. So now, well, first of all, I can start by putting a copy of that there. That's so long. And it's about to get even longer when I have this other part. Wait, why do you have problems? This should be fine. I put the same thing twice, but it should be fine right now. Must have something weird going on. Is it not like this, spitting this out? It should be spitting out an array and then trying to copy that. Do I have brackets wrong? Probably. Need 2 extra brackets on the ends. So it did. Why? This had one bracket, which was here. This is 1 too deep, right? Oh, no, 3 from the... Wait, no, what? Oh, no, this doesn't need this part of the append. Got it, gotcha. That's a weird bit. Got it. Okay, as I knew that was one too many. Okay. So now the other end that's not this is going to be... I need to make sure that this basically goes from 0 to 0 on the first iteration, and not try to go from... It'll go from like -5 to 0 though. I want to make that not happen. Unless I can like minimize it, you know, make it get stuck at 0. No, sorry, no, I'm thinking of this wrong. Hold on, no, the first side of this is going to stay 0. That's not how this do. Randomize from 0 to whatever the first number was, which is going to be this. And then, again, go from here, from whatever the second number was, and yeah, up until, and all that. And then go from there to the end of the array. So that's going to be the length. Right. Is this going to have a -1? No, I don't think so. Okay, you once again don't like this. Why? Move some of these so that it can be a smaller line. What's your problem? Thing was not... Square bracket was not closed properly? Brackets. I had this. Closes here. There's this. Oh, that does not close over here. Gotcha. That would be there. Does that also fix the other parts? Cool. So, before I do this to these, although I will go numpy.copy before I forget to entirely. I just want to see, does this run without an error? That's the test here. Nope. Ooh. Okay, in cross-validation, who could have guessed that? In the first one, oh no. Slice indices must be integers or none, or have an index method. I mean, I thought they were both integers, but apparently not. Does divide them, is that making them a float or something? Let me double check. I could try to convert it into an int, but... Print that number. Tell me what it is. Oh, you don't even get to? What? What? 0.0, okay. How do I convert you to an int? Okay. Python float to int. Do I round or do I truncate? I think. Round up? Is that what I want? Actually, I think, round up. There's a built-in round function, or rounding in general will be fine. I'm trying to just think ahead to like, because it's never been a situation where it can't be possible to pick the last number because of the way that it divides or something like that. Let's see, like 10 divided by 3. like 10 divided by 3 is going to get a decimal. If I round that down to 3, then 3 times 3 will be 9, which means it won't get to an actual value of 10, which I needed to for it to be able to actually be capable of selecting the last value. Whereas, but if I always round up, a 0.0 rounds up, then that would be not ideal. Unless, actually, I don't know that it does. So let's find out. This. And if it works here, then I'll put it in the other parts. You like math? Is there a NumPy version of this so I don't have to import math? Yeah, there is. NumPy might just import math in the background of itself. I don't know. But... Alright, what did we get? Is that the same 0? Did it just not do? It doesn't look like it did. I thought I rounded you. Does it, if it rounds, does the rounded thing that it outputs? Is it actually turning it into an int? Or is it still... If I just generically go around, that's not gonna change things, will it? I get why it's a problem here because I haven't fixed that, but this should be printing just a clean 0. Okay, fine. I'll just go back to float to int. Just int that. Okay. I guess I should round. What was? Oh. I guess I should round up. Well, I don't like how long this is being, but oh well. See if that does what I want. If not, I will be confused. Okay, cool. Okay. Now I need to put this where? On all of these values. This is so long. Actually, you know what? I am reusing a lot of the same numbers. I should be doing this on multiple lines. Let me do that. So go low bounds. Low bound? I don't know. Bounds is just going to be this number actually, and then high bounds is going to be the other one where it's kind of the same thing. That'd be this one. Yeah, that also makes the bracket situation so much easier to just see. Okay, is this fine? Okay, now let's make this much better. Getting to that in a minute. Which does mean, actually, this should be before this. Where is... Okay, so now I need to, not that. This needs to replace, and make sure I'm replacing the right things. This needs to go. This is going to be from low bounds to high bounds, and high bounds will take into account the like 1 minus parts. Okay, isn't that easier to read? Okay, so now this should go from 0 up until low bounds, and then it should go from high bounds to the length, which that's fine staying as it is. Okay. Brackets are still not happy. Why? Because oops, that's not supposed to have to be there. Oh wait. No, wait, what? Hold on, what? Supposed to append... oh, this was wrong from the beginning. That's why this is weird. A false. Okay. So this is for the outputs. Again, does this run without errors? Cool. None of these graphs have to do with what we've just done, but just did it run successfully? Yes. Cool. So now, will this work the same way? This actually might work the same. We'll have to find out. No, wait, sorry. This is supposed to be this bit. And copy, and also the copies might not actually need to be here. I will readdress that later. Okay, this far out here, where the difference is that this is using this variable instead. Okay, does this run without problems? Cool. Now let me just, I guess, confirm that high bounds and low bounds are what I think they are. Yeah. So these will be all the powers of 4 until it hits 20? No, or no, oh, until it hits 40. No, wait. Or it should be all the powers of 4, or 40 divided by 5. That amount keep continually going up. I was thinking of the 20 that I was using as an example, but no, this is actually going up with 40s. So first I've done is this, and then this. Yeah. Yeah, that's good. That is what that should be. Perfect. Alright, it took a while, but now we have done another step. Which is just randomly split the training data into K groups. Done. Got them. Got the groups. Leave out the kth group from the training set. That is these two. We got them. And then we got the rest. Yeah. And then use the rest of them, so the split, to calculate the weights, and then measure the error of the weights on the validation set. I don't know why I'm doing this instead of using the test set, but whatever. Sure. Effectively what this is doing is just, instead of having the test set, having the training set, and just taking a chunk out and turning it into test sets, but sure. Yeah. Why not? Okay, so what I need to recalculate the weights. Which kind of weights? With the biases or not? To find the best parameter vector WK. Vector, so it's not going to be the single number one, so it's going to be the one with all the things, but I don't know if that includes the bias on the W. I don't know. I think I'm gonna go with the one that biases W? Yeah. Oh, sorry, the first W. I think I'll go with that one. Or do I? Hold on, let me double check. Probably not actually. Yeah. I'll go with initial biased W. Right. It was the very first thing from way back with these weights. Oh wait, where'd this come from again? Where do these weights come from? It's different. Actually, this might just be all I want. Right, because I'm not calculating lambda yet. Or, wait, this, right. I use this to find out an optimal lambda. But how? How? Oh, by the way, did this run 6 times? Or, no, there's 5, but 1, 2, 3, 4, 5. It did run 5 times. Ooh. Wait, but how did? But I have 6 lambda values. How did that work? 5-fold across validation. 5-fold means split into 5 groups, right? Yeah. Yeah. For each. Oh, no, right. I start this. Okay, right. I go through this every time for each lambda value. Got it. Okay. Yeah. Okay, hold on. So, which means I will be using the one that uses lambda, which means I'm gonna go with the unbiased lambda because I think that was the more default one. Okay, so, and I can swap them out and just see what it does. God, this is so much code. Okay, cross-validate. So this is repeating for split. Now I need to repeat for all the lambda values, and I'm doing that before or after I'm just thinking, do I do that before or after I think I re-randomize it each time. Yeah. So I'm gonna start the looping out here. So at the beginning of each loop, do the randomization again. Okay. So for I in range, and actually I'm going to do the same with L in range. These are the different lambda values. Why am I typing this out when I can copy it from where I have it before? We're gonna do copying some of this. Deciding how much I want to copy. Yeah. Okay. Okay. Yep. I'm getting this. Okay. Okay. Oh, already copied these. Oops, didn't need them. Didn't need to do it again, but I did need to empty this. Yep. Cur lambda blah. So now we are having the same lambda values. I need to then tab all that out. Okay, so then we're going in, randomize the data, and then do this stuff. And now go forward here, use the unbiased this, which actually I might be able to just call this function to some degree, but yeah, I'm not gonna worry about it right now. Nope, wrong one. The one that doesn't have the bias. This one. And I think I'm going to be doing the same error test. No, actually, no, it will be modified, so I won't be copying this. Hold on. From here to here. No, wait, hold on, a little further. This. I'm actually going to put a space there because these two things aren't related, really. Okay. Wow. I gotta tab it out the right amount. Not that much. Okay. So now weights is gonna be this functionality again where I am using the lambda thing. Yeah, I'm pretty sure that's all good. And then what? Oh wait, no, hold on. This needs to go off of. This needs to go based on these, the split versions. Right? Training data split. And this. I will rename this to say features, I guess. Because there's a difference between, like, I'm saying that input is the initial input. Features is like the inputs plus what I added. So I classify those as being different. Yeah. Okay, so the split stuff is going to be here. Everywhere I see features. Yep, that's a lot. Oh, Dr. Viato, hi! Welcome back! We are continuing to do all of this, which to varying degrees of success. It is getting there. Oh shoot, I'm gonna need a new length for some of these. Right. It's a lot. You can see how many lines of code we're at now that, this has been a lot. But it is getting close to being completed. We're actually at like the kind of the final stages. If this stuff works that we're in the middle of doing, then we'll be done-ish. I have to still comment and all that, but yeah. Lots of drawing graphs that have different meanings and experimenting with different things, and it's been interesting. So yeah. Okay, what I'm doing right now, something called cross-validation. Okay, right, this needs to go everywhere I'm seeing output, which is, I think, just the once there. That's going off of this equation, where there's only one y. Yeah. Okay, so this becomes different. Let me put some spaces here because, yeah, this goes off of the validation set. Yes. Don't know how that works, but I guess it does. Just make sure I'm copying the right things. Yes. Feature validation. That all there, and then the output one. Be careful not to miss anything. Try as I might. Okay, so that's that. Now next I need to update the lengths of things, because otherwise that's going to run into some problems. So where is the lengths of these are going to just be the lengths of these, right? Yeah, yep. Length of that list, which I'm hoping that that's going to be the... No, this needs to be the length of, like, a column. Whoops. No. Yes. That would be, like, .t0, the length of that, I think. Yes. Okay. Yeah. And then I also get the length here based on the test data. Right, because this is now going to be the validation. Yeah. And this going here as well. Oh, ho, ho. Yep. There. And, well, this being this, I believe. Okay. Where else do I use that length? I thought I used it in, like, one more place. Maybe not? Why does this keep... This playlist of 145 like songs in it keeps replaying a lot of like the same ones, I swear. maybe I'm going crazy. Let's go this. So, Mata-chan! Oh, you're saying hi to him and not me? I'm kidding. No, I just, no. Yes. Okay, so this should do something. What am I doing again? Computing the average errors is slightly different, right? Average errors based on... Oh, I'm not doing this based on two things. Hold on, why? I'm not doing this twice. I don't need this version. I'm not doing... Yeah. Alright, calculating the weights, and then the average error amount based on the validation set. Yes. And then I need to store all these in some kind of a list. And then, oh, not this dot. Yeah, that's not what I want. Not error vals. Error vals, cross valid. I guess this is some new variable I'm making. Hey, Francesco! Hi! Prosody, Wolfan, Cruise. Hi, I can't speak apparently. Hello! This time I won't fall out of a chair. What? I'm kidding. No, yeah, no. Hi, how's it going? We are doing more of this. But wait! Yeah, I can do that. You can fall out of a chair? Alright. Make sure it's funny. No, okay, we are, I think, on the cusp of being done this, and look at how long it is. I mean, there's, like, great deal of stuff that's commented out, but still, it's long. So this needs to be the variable I just made. It broke? Oh, God. No, your chair broke? No way. Really? Oh, no. Oh, no. That's not good. I have broken headphones, so... Still, for now. Oh, no. What did you do? Why is this not running? Errors, yeah, my favorites. I fell out. Oh no. Had a good stream, finished coding my app. Ooh, was tempted to ask you for help, but got it 100% working. Woo, well that's great. Like that you were able to get it working, but if you weren't, then yeah, I'd be happy to try and help. I know guarantees that I'd be able to help. I don't have much mobile app experience, but I could try. I've getting experience with whatever the heck this all is. Why are you going wrong? So there's some kind of multiplying. Oh, wait, really? That high up? The weight thing is off? Oh, that's probably another thing where I have the dimensions of something wrong. Okay. So if you have no idea what we're doing, then welcome to the club. I don't even know how to begin to explain this. You'll see it visually shortly. Francesco, I had to dig up an old documentation because I have an outdated DLL and it couldn't be asked to update, lol. Fair enough. Yeah, updating old code you haven't touched in weeks, months, or years can be tricky. Yeah, I should know what DLL is, but I'm not as familiar. I'm aware of the word, I'm not familiar with it. Yeah, Fran has a sad life. He makes Discord self-bots and other tools against the guidelines. Ooh, interesting. I didn't know that there was, and beyond like malicious viruses and stuff, I didn't know that like the bots you can, making Discord bots, there's illegal stuff you could, like, you know, not illegal, things that are against the rules and the guidelines. I have a Discord bot that I made myself. The code is somewhere, but yeah, it's nothing fancy. But hopefully I'll be continue to add to it at some point. But it has like basic functionalities of a bot. With the one thing I was trying to do is mainly get going live notifications on my Discord, but they're always like quite late, but oh well. Sometimes I feel like half an hour or even more late, but oh well. A self bot is basically a bot that runs off your user token. Oh, so it pretends to be you. I can see why that would have a problem. Masquerading as, well, yourself, I guess, but I can see why that would be frowned upon. Sure. I couldn't understand a lick of code. Gonna be honest. Fair enough, it is complicated. You know this is complicated. I didn't understand it until I made it. There's a huge difference. So, like, when you're the one who's writing the code, you understand it way better than anyone else. Like automating your account from code. Yeah, fair enough. I can see that. I can see that being useful, I guess. But, well, I mean, I don't know. Yeah. I can see it being useful, maybe not for me so much, but, yeah. Automate your Discord account, yeah, basically it can be used for raiding and nuking. Ah, gotcha. Gotcha. Cool. Well, yeah, I hope you don't get in trouble with that. I mean, if you're masquerading as yourself, is that, I don't know, not as much of a problem? I can obviously see, like, faking it to be someone else being way more of an issue. I can definitely see that. But friend doesn't raid or nuke. Gawix does? Is that the name of the bot or something like that? Is this Francesco in my Discord right now, or in chat right now? Is he a bot? Or, yeah. Yeah. Okay, right, what am I doing now? Gawix is my friend, don't know why he's mentioning it. Well, fair enough. Okay, so, no, he's a real person. Are you sure about that? Okay. What was I doing? I keep, like, losing my train of thought. Okay, some multiplication in here is two matrices that are of uncooperative sizes, so it's not liking it. No, I'm not. I knew it. Oh, wait, no, that wasn't Fred. That was Chris Kid. Nailed it. The name. Okay, line 391. Oh, that's here? Oh, it makes it further down than I thought it did. Size 160 is different than 5. This should not be thinking it has a size of 160. Okay. Uh-oh. Yeah, big ol' uh-oh. Well, I gotta try and fix this chair. Oh yeah, Pro SD. That is unfortunate. Hey, my chair didn't break when it fell. It is also on the older side, but yeah, I'll be getting a new chair soonish. But yeah, I'm gonna be moving soonish, and I'm waiting until after I move to get a new chair because yeah, I'm gonna be staying. Oh, I'm not gonna be staying for long this time. I have school. Have a great night and rest of your stream. All right, Francesco, again, thank you for the raid. I really appreciate it. I don't even know how it broke. Somehow. Here, if I comment out some things, I can at least show you a little bit of what we've been cooking up here. 1 secondo. Actually, first of all, let me go with over here, the 2 bits of code that are running. So, bam. First of all, lines. Some training data and some test data. That has, like, titles and stuff. Bam. Then, same graphs, but, trying to do a line of best fit, where it uses this data to make the line and then plots the exact same line on the test data and kind of seeing how well it does. And also down here it's outputting like the average like error amount. And then bam, same thing but trying to be quadratic. Then bam, same thing but trying to be cube, which this is the best one. This maps it the best. And, yeah. And then trying to do the same thing with power of 4, which is actually slightly worse. So that's a thing. It's slightly worse on the test data, which is what is more important. So that's a thing. But it's intentionally that way. The power 3 is the better one for that scenario. And then on over here, land, I'm still getting errors. Why? What? That's an indented block. Why? Oh, because I have a function that I started but didn't, has nothing in it. I'll comment that part. And comment out this, and 1 second, this is taking longer than I thought, but this, and shabam, bunch of graphs, go! There we go, okay. Bunch of different information. So first of all, this is the same default, this is what the initial data is. Oh, I fixed it, lol. Awesome. Oh, so it wasn't as bad as like a break as like the leg snapped off and I gotta get that Gorilla Glue. Then this is the line with order of 4 because the rest of this goes off of to the power of 4 version of the line because that's just what it is. The next is things that I forget what they were. Different parts of the assignment with doing different lines. So yeah, it worked. Legit, I just did. Awesome. Glad you got that sorted out. This is calculating this lambda variable and mapping it compared to this average error variable. And the main important thing here is looking at what the lowest number is, which is here. This lowest, or the lowest number in the bottom one, which is here. So that's cool. And then over here, doing something with the weights and seeing how they... I don't remember what this was for. I just remember having to calculate it. And it's supposedly the correct numbers for what I need. I'd like to hope. Anyways, so now what we're doing is doing something called cross-validation to calculate, those two graphs both had to do with putting in these different lambda values. Here's some results that we get. And now I'm calculating the ideal lambda value for that stuff. Kind of, sort of, yeah. Which, I mean, looks like it could have just been the one where it dips in the one thing. Take that and make it, actually, no, that would be cheating, huh? In theory, actually, it would be take, in the one graph where it dipped a bit, we want that number, but without looking at the test data. We only know that that number dips because of looking at the test data. So we're trying to calculate lambda before having looked at that graph. I believe that's what we're going towards. Yeah. Okay, so with that, there's all this stuff that I just commented out. Okay, first let me comment back this line. No. Wait. This one. Yes. Okay. Bring this back. So, yeah, in the immediate right now, we're dealing with tons of errors and things not working the way that we want, but we will sort this out. Okay. So, I never use this. I don't need this. That's why I don't use it. I don't need to reset the weights thing here because it gets reset up here in a moment. Okay. So this works off of... Here, actually, I can show a picture. Nice handy-dandy photo of the principle behind what we were doing. This kind of thing. Of taking our whole bit of data. Hey! Oh! Thank you! ProZD! ProSD456, thank you! Thank you! I really, really appreciate that. I'm gonna go to bed because I have school, but nonetheless have an amazing rest of your stream. Man, thank you, and thanks for dropping by. And again, so thanks for being part of the raid. Francesco, I guess, is probably gone by now. But yeah, thank you everyone that part of the raid is here. I really, really greatly appreciate it. And hopefully we'll be finished this soon. I'll be getting on to more interesting things. Eventually, getting back to the good old unicycle thing with cool tight ropes and all that. But yeah, but again, I really appreciate that, Prosty. And yeah, see ya. Oh, Francesco's still there. Still here, just saving things, lol. Fair enough. Okay, so this is the visual thing of what we're doing. So basically, except this, but we're splitting into 5. That's just how this is. Taking our training data set, splitting it into 5, and then basically like eliminating, like, going through it, like, I can't talk. Turning this graph into words, not graph, this diagram, we're running through the data set with like this, and then using this as a validation thing, running through it with, you know, this and all this, using this as a validation, and that's going to help us do fancy things, mainly with calculating these ideal lambda values, which should be around 0.1 if I do this correctly. By the way, I can also, this is another thing I was looking at earlier. Didn't end up needing to really use that, but yeah. Anywho, okay, so where we are right now is in the math that's making this happen, getting errors, as is the usual, and I'm pretty sure it's because somewhere I'm passing in a wrong size for the size of the array, so yeah. All right, now I'm going. Good night. All right, see you, Francesco. I don't know how long I'll be going because I have school early-ish tomorrow. Not as early as this morning, but yeah. I would like to finish this night because I don't have all the time in the world to get this done. For the record, I have this project and another project both due. Yeah, both due next Tuesday. So I gotta get another thing I haven't started yet because I'm waiting to finish this. But the other one shouldn't take much time. And it should be more enjoyable, I think. It's gonna be taking a video game and doing a big critique write-up on it, which we'll see how that goes. I don't even know how long it needs to be, but I don't believe it's worth that much. So in comparison to this is worth 15% of my grade. Yeah. Anyways, yeah, and we're almost done though. So right now, what am I doing? Errors, yes. Like, go to run this again. I think the errors are having, like, here or something. Yes. And the fact that this has a size of 160 is a definite problem. This should have a size of less than 40, so. The other one being 5, that one I think makes sense. Yeah. Okay, so I need to... So why does this have a size of 40? At what point does it get a size of 160? Let's find that out. So let's print. I don't know what just happened there, but okay. I'm just go dodge a. Print it there. What are you? Maybe I need to go up more. Let's see. Excuse me? Oh no, what are you doing? Why are you different than you just were? Excuse me? Don't give me problems now. I close this. Close you, and close you. And it's like Control-Shift-P? No, well, okay, terminal. No, not like that. Terminal, like that. Maybe that'll refresh whatever was just going on. This doesn't matter. Okay. What was I doing? No, I just want to, well, I just run this. Probably refresh whatever wonky stuff was going on. Yes. Still a problem, yeah, but did you print out a number? 160. Okay, see, that is a problem. 160. Oh, you're a vector? No. That's not what you're supposed to be. Why are you that? Okay. Yeah, that's definitely a problem. This should have size like divided by 5, right? I said, yeah. So 40. 32 by 4 or by 5. 32 by 5 is the dimensions this should have. Yeah. Let me look at this one. See, is this one even the right size? 8 by 5. That part's correct. Okay, so it's this, my attempt at this appending that's not working at all. Okay, that's a little worrisome. So let me... Was I supposed to transpose this, maybe? Let me print out this. Dot shape, yeah. This should be like... Actually, the first time, yeah, it should be 0 and 5, okay. What? Well, okay, so this number makes sense. I'm pretty sure. Let me get this. Double check that that size is what I think it should be. So yeah, it's 0 and 5. Brackets. No, brackets. Where are brackets? This doesn't need a match there. No. That can't be right. Or maybe it can be. Yeah, no, it's fine. Ah, okay. 32 by 5. That's also correct. So if this is a pen function that isn't working out how it should be, it should be taking, yeah, two arrays and sticking them together, but with them being more boxy shaped arrays. Values are appended to a copy of this array. So, let me search up this. Gotta find out why it's not working. Oops. I was looking at this already before. So this is one array, and this is another. The values must have the correct shape. Yeah. Which it does the appending successfully. And for the record, I'm basically, the first iteration of this loop should be basically going array of nothing, append that to an array of something, spit out that same array. That's what, in theory, should be happening. Oh, this is becoming this, which, yeah, I guess that's my problem. Or instead I want it to do this, so I do this comma axis equals 0. Okay. Is that the problem? That might be all it is. So I'm putting that at here, I think. Let's see if the brackets there are right. Oh, that is not, brackets the wrong place. Yep. Okay. Hey, and that made the rest of it all run. Awesome. Perfect. Okay, these are numbers. This, so 32. Yeah, so this number should be getting smaller than looping itself. Perfect. And the rest of it ran. Awesome. Okay. So then that goes into this array. So now pretending that all this is calculating the right numbers, which it might be or it might not be. I don't know yet. Why does this keep... I have 150 things in here. Why does it keep replaying ones that I'm... keeps playing things that have happened 10 minutes ago. Anyways, I uncomment this. So it's after all of this that I'm then printing the or doing the graphing, right? Show the. Okay, so the average error on the validation as a function of lambda. Okay, that's what I thought. Just making sure. Oh, this ain't what I want. What I need is to copy some of my other code here. I'm also just realizing that maybe actually, with how long this has gotten, I'm gonna put it in a main. Def main. And then go. I'm just gonna do the same thing on the other bit of code. It would probably be good to do so. Yeah. Okay. So. Right, what was I doing? That didn't solve my problem. Any other time where I've graphed stuff. Or more specifically, I think this. Why do I have this here? This don't need to be here. Because I don't use that. Not anymore. Or I don't change it. I can read from it without having to do anything. It's only when I go to change it that we have problems. Yeah. Okay, figure, scatter, show. Actually, I want the show part at the bottom. Okay. Okay. So I am gonna name this what now? Training data cross validation. I probably don't really need the cross validation part in here. Oh no, I'm going to graph multiple things. Okay, so cross validation on average, so average error, cross validation. Whatever. Let's leave this as the name for now. So the X label is going to be lambda. The Y label is going to be validation error. And then we got this being these numbers, in theory. Did I reset this at any point? I really should. Okay. Yep. We're doing this now. Okay. See if it does. I don't know if these should stay being logarithms, but we're just gonna see what happens. Oh, errors. That's on the attempt at graphing. Yes, where this is 6 and this is 30. Right. Oh no. Wait. Oh no. How does that do? Oh. The average error on the validation set. Oh. Wait. Oh. I am doing this wrong. How do I want to do this? The average. I want the average error across the whole validation set. Where this is the average error across the single lambda amount thing. So how do I convert this? I need two like things. What do I call you? What do I call you? I'm just being indecisive about variable names here, don't mind me. So error evaluate, so the error values with this is cross-validation. Single. Whereas then down here, okay, oh. So far out I have it? No, this needs to be up one more, okay. This is another array that I'm making. Average. Well, yeah. Okay. So this, let me just change the names of all of these. And make another one, because soon I might change these to be like in different functions and all that. We'll see how that goes. And this needs to be so average. Yeah. And you have to globally get that. So much scrolling. I can't believe I've typed all this in like 2 days. I mean, a lot of it has been copied, but still. Oops. Okay. So average, and then make sure to reset this as well. Okay. So then, so what does this need to go off of? So this just needs to, rather than doing these calculations, this just needs to go through everything in this, the length of this array. Go through the length of this, add them up. And then at the end, this equals divided by the number of them, which is just this. And then add that. And now this should be these numbers that I want to graph. Instead of 30, they will be 6. And so it should graph. Yes! Haha. Okay. Oh. Oh no. I don't think that's the right numbers. That's a little concerning. Because to my knowledge, the number I should be getting should be like this. Well, at least I wouldn't think it'd be something on like the edges. I think I could change about this to make that maybe actually happen. The validation error. Also, this looks weirdly linear at this point, but might just be with the way that it's drawn. Like, surely it's not just going point, 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 point. Because it should be like point, 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 point. Actually, basically, at each of these is it being a data point. Actually, I think this one is curving slightly, but this one doesn't look like it's curving at all, which is, especially it's not curving down. So one thing I can change about this is I wasn't sure whether to go with the version of lambda identity where I don't have the initial bias in there. I can take that out. Actually, literally just taking out that line and that's it. I can make it more optimized. But does this do what I want? No, and that looks the same. It would seem. Let me just see something. Is this the exact same? Or like, how different is this? Let me just compare before and after. And am I changing this in the right place? I am. I'll close all these. So once again. Wait, what? Oh wait, hold on. Did I not this what? I didn't change anything. And I swear this looks way more like a dip than it did a moment ago. What? Excuse me? Am I crazy? So wait, hold on. With this gone, it looks like this. Oh, now it's like dip going up. Oh, right, there's some randomness in the data. I forgot about that. That's why it's weird. Okay. Here, let me run it a few times. I forgot that it's random. Of course. I'm not as crazy. So sometimes it looks straight. Well, it seems like sometimes it bumps up a little bit. I'm more interested in data that doesn't look so like a whoosh. Like I want some spikes or some dips. Would make me more confident in my assessments here. But I think, yeah, I'm leaning more on the side of keeping the bias. Or, actually, no, I'm not so sure. Just keep running it a few times. Yeah, okay, so now it's dipped slightly under. So, and then with the bias, okay, so it doesn't actually seem to impact it that much, so it seems like it could be an either or. If it can be an either or, then maybe I, is that all bumped up a lot more? Yeah, I'll keep the bias then. Like, I think it's supposed to be there. I'm not sure. Okay. More lines. So I'm not entirely convinced that that's what that should be. Now, to be fair, the other one, like, what I'm basing this off of is that this one here has this bit of a dip. It's not that much of a dip. It's like, it is kind of small, I guess. And this one does not have a dip. And if anything, it makes sense. Actually, yeah, it makes a lot of sense that this would more so match this one, which does not have a dip, compared to this one, which does. Which is interesting. But I don't know. I'd like to hope I'm not doing this wrong, but it might be the kind of thing where I be like, oh, you know, it's kind of finished, and like I come back to it in a bit. Maybe like, you know, work on my other thing, something like that. But at least having answers that look like I put a lot of work into them, somewhat good. Okay, so the last part of this, though, let's pretend for a moment that that is what that's supposed to look like. The last little bit of this. So the average error on the validation as a function of lambda did that. I don't do it for each lambda. No. And then for the best fit, plot the test data and the plot the test data and the regularized blah 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 line that we've gotten. Okay, I'm just gonna kind of let this continue to be on the bottom, and I'll separate into functions after. It's just easier to like get to use variables up here rather than having to keep doing the global thing. So I'll figure out that in a second. So we're gonna be making another graph. That's gonna be just the test information. This is test. Actually, I guess I can just test data, cross-validation, order, blah. Okay. Where I'm plotting the normal data, which means I'm gonna want any time where I've graphed the test data, which I'm looking at like near the top for where I've done that, but not in the subplot, just scatter plot like this. Hold on. I want these two. Yes. Wait, does the initial graph not have an XY label? I just realized that. It doesn't. Oops. And that means it probably doesn't on this side too, which it should. No, it does here. I just didn't do it in the other place. Hey! Worst do 2 is now following. Hi! Hello! Welcome to the stream. How's it going? And all that. We are doing some stuff. I can barely describe what this even is because it's something I barely understand. But it's coming along well. Doing stuff with graphing lines. Here I can show, bam, graphs. All these different graphs that represent different things, having to do with eventually getting basically this line of best fit that like does its best at kind of following this sort of line. Yeah, and that's going interestingly so far. Okay, I think we're getting close to the end of this, kind of. Yeah. Okay, so what I was just doing was going to add labels onto this X and Y part, this over here. Yeah, and then I need to copy this. No, hold on. To copy some things to down below. I've got so much code in here now. It is insane. So I need to draw the test, like this test input and output first, and I guess with this title, then yeah, labeled X and Y. Oh, don't need that twice. And then I need to not have these. Now I'm just plotting the, what am I plotting? The line that I obtained with the new weights as they currently are, with the best lambda value. Okay, if I do it now, it's gonna go based on the last weight that it calculated, but let me just do that first, and then I'll recalculate the weights with the lambda value that I want. All right. Okay, where would that be? I've done this before. I'm just looking for a line to copy so I don't have to type it out. Where I've done any of the line of best fits, it's gonna be regression on test. This over here. Yeah, this is what I want. Just double checking, yep. Making sure I'm getting what I'm after. And then I don't think I'm changing the scale on these. No. Bam. Okay. Regression. In fact, actually, this is gonna be. I'm gonna put regularization. Am I spelling that right? Okay. Blah, 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 and blah. Okay. So I'm going up with test data features. I didn't add features to the test data. Where did this variable come from? I don't remember that being a variable that I made, but I guess I did at some point. Where? Why? Why did I do that? Oh, here, right. And I said before, I'm pretty sure I just straight up don't need this. Yes. Yes. Yep. But now I have it in here in some places, but that just needs to change, and then fine. So we do this, and then we get some errors from some things I just renamed, so I just need to go find them. Let the errors guide my way. Okay, 169. And this is the value I'm going to be pasting in a bunch of places. Right momentarily. 16200. The filter. Yeah. This. Is that all? Nope. 183. 183. There we are. Yeah, I'm just going to keep trying to run it and yeah, let the errors guide me. Not enough dimensions. Oh no. 183 again. What? Wait, oh no. What? Oh, this doesn't need to be transposed. Right. When it's not the features version, it doesn't need to be transposed. Yes. Oh, 183 still. What? Why would you still be having problems? Okay. You're gonna have problems, of course, if I change the wrong field. Does this need to be transposed now? It does. Over here. Maybe what I just did was a mistake. Still 183. What's your problem now? You don't like it being transposed, you don't like it not being transposed. Operand 1 does not have enough dimensions, requires 1. You saying that this has a size of 0? Why would it? I'm still setting it when I read the data at the beginning. Yeah. You know what? Let's back up. I didn't need to make my code more optimized anyway. Fine then. This runs, right? No? Yeah? Okay, whatever. Something I can look into again later, but for now I'm not worrying about it. That's not what that's supposed to look like. Right, because that's the wrong weights. I need to now that I've supposedly calculated based on all this, I now know what the proper weight should be based on the lowest lambda value. I'm going to recalculate the weights one more time with that lambda value. It's going to be, let's make sure I'm just copying only what I need here, which would be this bit. Yeah. And I would like this. I'll probably, hopefully, maybe separate these into functions in a minute. In many minutes. But, okay, so per lambda, I want to set this beforehand. Per lambda, just to brute force this for a minute, setting it to 0.1. Show elite goat skills here. Ah! There you go. All the best programming nonsense going here and here at the Cyber Chroma stream. Yeah, okay. We're getting to the end of this. Soon, potentially. So this should be the right weight thing, except this shouldn't be all hard-coded, or maybe it should be, I don't know. Unless I'm supposed to programmatically find the best value for lambda, but it's not the 0.1, but I feel like it should be. Oh, this didn't, where's the... Didn't do what it was supposed to do. Oh, yes, there it is, okay. I guess that is what it's supposed to do, huh? And it actually, oh wow, it got it with a, huh. Oh. Neat, cool. So this is fascinating because it's in comparison to how code was a while back. Like, it's not gonna run, okay. I was hoping I could compare this diagram to the other, but I can by screenshotting it in this. And now the other one will run. There we go. So initial, is it better than the order 2? Let's find out. So this. Okay. So ignoring the parts that aren't fully straight because it doesn't matter really when there's like no dots. So comparing this one, and we're only really caring about the. Oh wow. We're only really We're only really caring about the bottom graph. Because that's the test. Which, if I make it bigger, so it kind of, sort of tries to more so match. So comparing this one, interesting, compared to this one, which was way off, which is, yeah. But that's very fascinating that what we've managed to do here with that lambda thing. I don't actually know if this is close. It's definitely closer on the end here, like this one is, but in terms of the rest of this, it's like very close. But yeah, anyways, so that's cool. Don't save that. Right, so now though, the problem here is that in terms of this thingy that's calculating all these lambda values, it doesn't I'm not quite sure if it's getting the proper lambda value, but we're going to go with it. Or right now I've done this, picked out a lambda value, and hard-coded it here, when I think this should be like actually sort of taking it from, like, this shouldn't be hard-coded, is what I'm getting at. Which, let me make a variable here called best lambda that's going to be equals the first one, because it's going to be that. So best lambda, wait, it's going to always be that. Let me go with 1,000, because I want this to actually change. So best lambda is currently 1,000. And then when this runs and it does these calculations, I'm looking for there's a better way of doing this, but min lambda error, I don't know, whatever, which is also going to be a big number, so that it will go down in the first time I go to test what it is. Okay. So, what I want to do here is, after I've calculated this thing here, then I'm going once I've calculated this one, if, this is Python, not C#. Okay, no brackets here in your if statements. Okay, if this is less than, not equal. I was debating like where I want the equals in there. It doesn't really matter. If it's exact, then cool. When you're dealing with floats, if they're both exact, then that's a big deal. Why is this 145 in this playlist? Keeps giving me very repeats that are very, very close together. Okay. Anyways, okay, what am I doing here? I am doing a little bit of comparing this to the old error amount. No, the current, the one we just calculated, which is going to be this. Then best lambda equals cur lambda. And then this should be best lambda. Let's see that do. It's do. Right, these don't, once I close these, then the last one will show up. It didn't update once. Oh, wrong way. Other way around. Yes. That made it never update. It should update. Okay, now, blah, blah, blah. Ah. That's not good. Why is it failing to get, like, a minimum amount? Okay, print the average error. This isn't being over 1,000. No. I don't believe you. It should be a number that's, like, close to 1-ish, right? These are the numbers it's printing out. So I'm saying if 0. whatever is less than this. Is this running at all? Print. I just need to know if this is running whatsoever. Which it did. If it ran... I mean, first of all, let me just stick best lambda right in there. I have no reason to continue to use cur lambda there. If you are running, then why is best lambda not being updated? Excuse me? Duh. The error amounts weren't going lower and lower, right? They were going higher, right? Yeah, why is this running? It shouldn't be. If the current average error that we have is lower than the error that we've been saving previously, right? Let me print this again. I just saw that they were really low. I didn't pay attention to if they were getting lower and lower, which they shouldn't have been. They maybe it would do like a dip, but like the last one should be really high. Oops. Hold on. Let me just deal with the fact that I've hit play mode multiple times, I think. Yep. Let's get through all these. Okay. Yeah, no, the numbers are going up. Yes. That's what I suspected. Which, then, why in the... this being true? This doesn't recognize itself as being an int, or a float. I wonder if that's any sort of a issue. Where did I calculate this again? How do you... oh, literal. Excuse me? Excuse me? Why is this doing this? For the record, if I is min lambda changed anywhere? It no. Yeah. Tisk tisk tisk. Me. Thanks, Dr. Viato. Sometimes I'm just an idiot. There we almost go. See, the problem with this is the fact that it's worse than it was before, which shouldn't be the case. Remember how when I hard-coded the 0.1, how it actually went through this? That was a good thing. That means I'm definitely doing something slightly wrong in these calculations, which is unfortunate. But the problem with that is, I think it makes sense for the training data, but not the test data, because I'm not using the test data. Am I missing a step? With this? Unless it's supposed to not be correct. Which, I mean, could in theory be the case, but... and I could see why. I see how it could make sense. Also, let me close my bajillion tabs. Didn't mean to close that one. That was not a tab meant to close. Cool. What you doing? Yeah, we're gonna do that. Sure. This I can close. Yes. Okay. Okay. Right. So now, still putting some spaces between here. So this best lambda. No. Yes. Yes. Does this get impacted at all if I do this? It didn't before. I don't think so. If I take this and take this, then it modifies the initial bias, which I don't remember if it should do. I don't think it should. It's gonna be, yeah, basically the same. And that needs to be consistent in the two places, otherwise it's even more weird if I don't do that. Okay, but either way, okay, let me do a thing. So, just so I can see all the graphs together, I keep commenting out this show line, but by the end of this, I'll have all of them in there. Okay, blah. All of these guys. So, yeah, again, to compare here, some things. So in looking at only the training data, it makes sense that, because this line only goes up, it makes sense that the lowest lambda value when only looking at the training data is here, because that's effectively sort of what I'm calculating. This makes sense. For the test data, and I think this is skewed specifically because of these two dots at, like, blocking a little bit. These two dots out here that are being kind of outliers. Because of them specifically, I think the test data it's slightly better if lambda is this 0.1. But when only looking at the training data, that this is never happening. So I thought that I was going to be doing equations and some different math to make it pick up on doing this, but it never did. Which makes me, I don't know, I'm not sure if what I have here is completely correct. It's like close, maybe? Is it closer than this? Would be my next question. Don't tell me it's exactly the same. No, it is slightly better, I think. Looking at like this one to this one, it's hard to tell because the scales are weird, because this one's the full page, this one's only half because of the way that this was. Yeah. Make this bigger, and then you compare it to this. Again, hard to really tell, but I could print out numbers to, like, you know, properly have numbers to see here. I think this is closer. The new one, anyway. Maybe not. So it's not like 100% exactly the same. For the record, these two are very similar, because this has a really, really low lambda value, and the lower the lambda value, the more that this is going to be like that. Or the closer that these two are going to be together, for it being the same. Okay, well, that's that. So with that, in theory, I'm technically done this. If I want to be... If I think I'm satisfied with my results, but I'm not so sure if I am. But I think I'm at a point, though, where I'm going to say it's good enough for now. I'll take a break from this, and I'll come back to this later, possibly. But first thing I want to do, two things, to actually wrap this up. Nice little bow on this. I do want to... Some of this... All of this is in one function right now, and I want to see if I can split some of it up. And then, yeah, start there, and then go through and comment everything. Oh. Okay, so just thinking, like, okay, how can I separate things? That'll be the easiest to actually separate. So, all right, I'm graphing two separate things here. So, obviously, well, everything in the for loop, in the double for loops, is all going to be in one big thing. So have this be a function, and everything above it to some degree. Okay, so this right here is the cross-validation. That's what this is. So that can stay with that being the name. Down here, this is def. This is me graphing the cross-validation. Graph, can I get a better name? Average error validation as a function of lambda. Whatever, cross validation. Okay. That's, I'm gonna have to put in some global variables like these that's just not recognizing. I'll do that in but a moment. And this is also gonna take a degree as input. Did I use degree number here? Because I did somewhere. I'm gonna assume I did somewhere, yeah. Then having all this, and I was gonna split up, so this is calculating more weights. Def, calc weights, cross validate, and it's gonna use this best lambda value, so it's different. And then this will all be graphing the second final, or actually it's the final graph, where this was graph, can't call this graph cross validation again, but graph, I mean, if anything, this is the regression line. Or the regularized. Oops. Graph regularized regression line. I don't like how long of a name that is, but whatever. Does this not use a degree? No. Does this use a degree? Yes. So on their own, on their own those work. Now I gotta, one, call the functions. Two, get the right global variables that need to be in here. Some of this maybe should be split into more code files, but like, whatever. Okay, this. Yeah. And then this. And then this. Of course, I just copied the exact same thing. This is the one that had the 4. Oh wait, what's the difference between this? A graph cross-value visualization where this has the 4 and then this. So I would have missed one. Because this should have the 4 in it. And then that's followed up by this one. Okay. Yep. I almost think that I'm just gonna call this again because it's more like a fresh reset. It's like these. This is a chunk together. This is a chunk together. This is a chunk together, and this is a chunk together. I believe. I'm gonna actually change this like that. Because that maybe is more descriptive of what is kind of to be consistent in naming. I don't know. Okay, so now these all need to be global. This. Wait. How are you used here? Oh. Wait. I may have cut off too much. Oh. This is using the wrong things to calculate its final weights. This should be using the whole data set, I think, which is this actually, I believe. Oh, that's not what I want here. I don't know if this actually messes with the final result too much. It might just be just a tiny bit. Oh, this needs best lambda, which is now going to be a global variable. Yes, that. Which I have to actually make it up here exist. Okay. What next? Is that good? Good to run. Maybe? Nope. Something is missing passing along a degree. Oh, did this need this? I thought there was one function that didn't. That makes me worried. Did they all use it? I guess they all used it? Okay. If they all use it, that's fine. So next thing I need to do, oh wait, I'm not done here yet. I need to add global, the thing I just made global, what was it? It was the, best lambda. Yeah. Hope I have all the global parts in place. Guess we're gonna find out. Definitely don't. Okay, so... something's not being properly sent to the right places. I just need to, confirm that every variable that I'm using in different functions I have this global thing. Unless I'm just accessing it. It's only when I'm, see, this doesn't need anything to be global because it's not changing anything. It's only when it's accessing it. When accessing it, like read only is like fine. When it's changing it, it needs the global part to it. Okay. Was the problem to do with that I changed these? It shouldn't be. In theory. Global weights, that's it. Yep. These are gonna get changed over here. This is not a thing that needs to be global. Okay, perfect. Please. Yes! Hey, it's better! How did it get better? Huh. have no idea how this happened. But I'm happy it happened. This makes me way more confident about that. How did that happen? I don't know, but I'll take it. It has the dip. How did it get the dip? It got the dip, so it used the 0.1. Is that from random chance? Oh, this dip was like a lot, huh? I don't know. Okay, so one thing that worries me is the nature of the randomness of this. It might have been once in a blue moon. If I run it again, from the randomness, does it still do that? No. This has to really dip for that to happen. Okay. But it happens sometimes, which is fascinating, actually. So, is there anything I can do to sort of force it to happen? So specifically, yeah, this here, no, don't do that, no, hold on. This here, if I can manipulate the stuff that goes into making this graph specifically, so that this, actually, let me full screen this, so that this is even, it doesn't matter how much, it's slightly lower. This is slightly lower than this, all the time, 100% of the time, would be great. The problem is that a lot of this is going off of randomness, which is not good. Well, I mean, it's good that it's random, but it'd be nice if it was doing that and always random. Where the alternative is, I think sometimes it like jumps up a lot. Double check on that. Yeah. Oh no, it's even like that. There's no way this would ever go below this, I don't think. Or like this being the lowest thing. Be interesting to see though. Again, the problem I think is that I'm not using the test data in this, what I'm not supposed to be. The point of this is to do all this training with this data, and then this is the test. But yeah. And it's fine. It's fine, except for these two values on the end. They're like the outliers, which is fine. Yeah, and this is also going off of that the degree 4 is kind of too high. Degree 3 is a better fit, but the point of this is to do all this on a thing that's like too high for it. Why? Because. Yeah. Yeah, missed here. I don't know, but it's interesting that it can actually do the thing that I want it to do. Yeah, but again, though, is there any way I can influence it, nudge something in the right direction? I don't really think so. Other than if I hard code it, if it's 0.1, do this thing. That's not gonna happen. I mean, I could mess with the split amount, but that's the way I'm told in this that it has to be 5. But it'd be interesting to see how that messes with the data even more. Curious just to see. Wait, no, that's gonna give me errors, maybe? No. Yeah, no. I think that's fine. Yeah, okay. Anyways. I think it's fine how it is. I think I'll leave it how it is. I think it makes sense. I have a rationale in my head to, like, rationalize why these results make sense. And it is because, as I've said a few times now, the reason this is not like the best fit of actually reaching these two dots here is because the initial training set doesn't like cover that effectively. Like, it trains to cover this very well. Throw in this, it hits here, and it kind of just does its own thing. Like, it doesn't, yeah, it's not trained to hit this kind of scenario, which makes sense. So I think I am justified in it. Oh shoot, this doesn't have the padding thing. Let me just do that real quick. That's just one line. With this, needs to be up at the top. Okay. Up, over, by. Where do I usually put this? Compared to all this. Down here? No. That's not what I want. This. No. Stop. Oh, I didn't change that out from 5. Oops, that would have been not good. Okay. Okay. Okay, let me now, I think now's a good time to bring back all of these individual show things where each one's supposed to pop up like one at a time. Yeah, I put them all in place, just didn't, just gotta uncomment them all. Yeah. Okay, they're all there. Cool. Oh, right, I don't actually think I need to have the initial training data for this question. Yeah. Numbers. Graphs. Woo! Okay, so... Okay, so now with this, I'm actually not sure if I even want to. Some of this I might be able to get rid of out of this part. Like, yeah. I might be able to, for the sake of like. This part, this question has all the code that's basically doing all of this that I don't think needs to be done again over here, like here upwards. You know, I need to import the data, that's important. Let's say here. Might be fine, not existing. Let me just see if it runs. Where's? Oh no. Oh, I know what line is missing here that I need to put in here, but that's fine. Okay. There's a line that is here. Where are you? This line that needs to be somewhere where I debating whether to just like graph the default data anyways. I don't need to. Sure. I'll keep it. Yeah, I'll keep it graphing the initial data, but I'll get rid of the other parts. Okay. Double check that this runs successfully. So we got initial data, cool, and then we got the error regulation or the regularization, the error averages on the test, on the training data and on the test data, and then this is the weights compared to lambda, and then this is lambda compared to the validation error, and then this is the final cross-validation thing. Okay. So with that, I can now delete all these functions that are not being used, and I'll just reduce the length of this by a lot, which I think can be. I think I use this, leaving this and this. Let's see. Yep. No problems. All these go through and don't look strange. Do I use this? I believe I do. Yes. Okay. Anything in here that's not being used? I don't think so. Okay. Okay. So many global variables I had to make here, but that's the course. Yeah, okay. So I think we are good and done for the coding of this. Now, I think the last thing we're going to do, and then we're going to end things off here, is go through and comment it all, because, yep, it is a part of the process. Oh, I didn't realize that this did this. Did I end up using this? See, it's not accessed. I don't use that. Or do I? Am I gonna get errors now? Let's find out. I won't know for sure until I've gone through every one of these, because especially the last part is where I actually use the randomized stuff. Okay, fair enough. Yep. Also, wait, do I need this? Because I only use the second part, I'm pretty sure. It's for efficiency's sake. Mm-hmm. Double checking. Oh yeah, must just get it. Yeah. Sure. Okay, that ran, which also means that I could have removed it from up here, I believe. Let's double check. This, cool, kill. Other thing I actually didn't even pay attention to is just, what does this actually print in the console? Does it print the things I wanted to print? That imported successfully? Sure. Okay. I don't think that part needed to print anything, right? Oh no, actually it should print the best lambda value before it uses it. Anything else? Does it need to? Yeah, I'll have it print the best lambda value once it actually knows it, which would be at the end of this function. Right before it uses it, I guess, sure. Print the best lambda value is no, hold on, this will do an F thing. And this. Anything else? We're gonna do more things here for like the sections, I guess. Performing regularization. Yep. And then performing cross-validation. Okay. Making sure I kind of do this the same way. Yeah. Oh, I did some slash ends. Sure. I don't do one for the literal first thing it does. Here, I'll just go success. This pain. Okay. Pretty sure this is like 2. If I'm following the same kind of thing that's happening with the rest of this. Okay, let's comment this guy. So arrays from arrays for a bunch of different global variables. Okay, so array for all lambda values, which could be hard-coded, but specifically kind of like to not, I think. Go off based off logarithm stuff. Okay, whoops, no. This is going to be arrays for error values. Good enough. Array for, wait. I don't care, it's explaining exactly what it is. I can't think of a better comment for that. Value for Calculated best lambda value. Alright. Okay. A lot of this starts off the same from the comments I had before. It changes here. Alright, let's do it. Go through each lambda value, and I'm going to put in brackets based off logs, something like that. Okay. Calculate weights with current lambda value. Okay, that's gonna skip me down right to here. I don't need to comment what each of these are doing. I kind of did in the other one, so you're not meticulous to do it again. I've maybe hopefully shown my understanding of this. Okay, go through each line input to calculate the average error amount. And I do this. Do I need to do this on the test, the training, the test thing? Yeah, okay. Doing the same kind of setting up the graph, except there's things here that I need to comment out. Oh, what I'm plotting is changing, I think. No, this is it. Regularization error amounts. Yeah, that's correct. Setting up the graph. It's kind of, no wait. This is scaling. Scaling graph, sure. Same thing here. And then, yeah, that can be there too, whatever. Showing the graph. Okay. So, then we got this. So, this is going to be resetting, or clearing, I'm going to say. Clearing arrays. There might be some more arrays that I should be clearing, potentially. And you know what? I'm going to make sure I do that because it's good to do. Equals blah. What else only has a dot append, and that's it? This. The test one will be in the same boat. The weight doesn't need to be reset because the first time it's like called here, it's a direct like assigning thing. So, but yeah, here are all the same comment of clearing arrays. Yeah, anywhere where I just have just append. Okay, this is going to be going through. This is going to be the same comment. I'll just copy it. Okay. So, calculate weight. Weight based on current lambda value. All right. And then here is calculate weight parameter based on weight. Parameter. Based on current weights. Okay. Nah. And that's this whole equation. It's storing it there. Okay. That's good enough. More graphing. Scaling. Graph. Show the graph. Wow. Almost there, kind of. Don't know why I pasted that there. Clearing, raise. I don't know if any of these should be cleared also, but nah, probably fine. And resetting values. That kind of covers that. This is the same lambda line that again I will copy. This. Okay. Now, this is okay. Randomize data set. That takes all the way down to here. I'll separate like that. Actually, I will do this. Generating random seed to randomize both arrays in the same fashion. Sure. Okay, so now this part is implementing. This is doing the cross validation. So cross validation by looping k times. I'm using k because that's the thing it's using here, and this is kind of just saying that this is k, but I'm not putting just k in here, so it's a more descriptive variable. Okay. Calculating bounds of the one. Does it have a name, the one I kick out? And then I remove. That's the what's the validation set? Bounds of validation set. This one is now calculating getting a validation set. Extracting, and then getting split set with what's left. Okay. Then also even these, I don't know if this needs to be a copy thing, but let me see. Let's find out, shall we? Because it'd be more, less code. If I don't have the copy, I only need the copy if I plan to change this, which I don't. I just read from it and then overwrite it again. So is everything the same? I believe so. Yeah, it looks good to me. Okay, so next is, once again, calculate weights, which I think this is similar to when I calculated weights before. It's a pretty the same function, but I think there's some differences, so I'm just gonna leave it as how it is. It's fine. Okay, calculate weights based on current lambda value. Yeah, and that brings us down to go through each line of input to calculate the average error amount. Sure. And then put line of input. That's not necessarily what this is anymore. What is this going through? It's going through each. Go through validation set to calculate the average error amount. Oops. No. And then go through. This is this is average each. Average all the error amounts for this lambda value. Yeah. So this is like the average for all the error values for this lambda value, and then no. This is all the error values on this. This is all the different error values on this one lambda value or something like that. Oh, right. No, I forget how this works, but it works. First off, I remember that, yeah, we do need the two separate averages. I don't remember why, but meh, take a reason. If we have had the lowest error so far, make this the best lambda value. Okay, almost there, I think. Yeah, here, we got scaling the graph. Okay, we're not almost there. We still got more. How far down in the code are we? We're getting there. Oh. Scaling the graph. Showing the graph. I've been inconsistent about like the ings and the tenses of things, but whatever. Okay, so I've taken all these things. Why do I need this? I don't need this to be global. These two do not need to be global, right? Do they need to be global to do a .t thing? I hope not. Yeah, it seems to be fine. And every time I make changes like this, I should run this and just make sure I don't run into problems. Cool. Okay. Yep. Alright. I'm also just going to reorder this because I like to have these kind of in the order of what we're using first to some degree. Okay. So now, it is calculate weights based on best lambda values. This makes sense to be different, kind of. Some of it could be the same. All of this is the same, but whatever. Value. That's all of this. Yep. From the cross validation. A bit longer. Okay, so the size. Okay. Calculate the y values of the regression. This can still be regression. Actually, change it to cross val y vals. No, yeah, it can stay the same. Whatever, it's fine. Add the last weight to the y-intercept. Yes. Plot the regression plot the regression curve or line. Yeah, because this could have a different degree. And with that, we're done. I don't need to comment any of this, except I noticed down here that it's like performing regularization, nothing. This part doesn't print anything. Is there anything that? Oh, what did I just do? Is there anything that I can have just print from this? Anything I kind of evaluate? Like something I could just print that's not me having to do any more calculations. Printing out the lowest, the best lambda value from this would take too long. I don't know. Something like, I guess I could actually just do it by the end of each section. Variation done. Sure. Yeah, why not? Yeah, this. I guess I'll do this everywhere. Last little thing. Data initialized, I guess. Yep. Except I'm going to put this on this part too. I guess at all these I will have the same kind of comments. Data initialized. Linear regression complete. Yep. Yep, it is coming along. It's getting there. Nice descriptive comments that make it look like I put a lot of work and care and effort into this thing. Yeah. I don't need to print out the average error stuff with the other part, I don't believe. Doesn't tell me to. Alright, with that, I think we might be done here. Yeah, and I'll leave that one comment of data imported successfully. No, wait, I will add an exclamation mark on it. Where is that? And I think that'll be the last thing I do. End on a high note. I can find it. Where are you? This. Do the same on the other side. Oh. Okay, and with that, oh my, I think I'm satisfied in calling this done. I have to do a little bit of writing with this. Actually, not much. I just have to maybe a few sentences for each part of this, but still got to do it. I'll do that off stream. I'm not gonna, do that now. But yeah, there we go. I think, yeah. Do the names of these make sense? I want to hope so. I just want to remember what these were. And with that, I think we are done. Yeah. Okay. I'm just like, is there any last little things I want to do to this? I might look back on this later, especially if I realize I'm doing something wrong and there is a way to actually get the lambda value to be low like I want it to. To be to 0.1 would be ideal. And fill me with more confidence, but I'm pretty sure I can't use the test data to get to that conclusion. Which, yeah, we shall see. I really hope I don't find out that I've done some part of this completely wrong, but hopefully not, frankly. I think the only thing that matters, or one main thing that matters here is that, I'm not going to bother printing this right now, but the average error at the end of this, and the average error at the end of this. No, sorry. The average error right up here, if it printed, specifically, the average error printed from here, and the average error printed from at the end of this. This one is slightly lower. If it is, even a little bit, that's a good sign, I'm pretty sure. Yeah, I think so, anyway. Actually, I don't know, maybe it would be higher, I'm not sure, but I'm pretty sure it's supposed to be lower. Whatever, anyways, I think with that, we're gonna call it here. So I think that's gonna wrap it up for this stream, and with this done, I guess I move on to the next thing, which I got a lot of writing ahead of me now. That's something to look forward to, because now I gotta do this big write-up of comparing, or analyzing, a game, and I don't know, whatever is involved with that, but I have to do that, and then, some more little things here and there. We'll see. We shall see how that goes, and I probably won't stream any of that. I'll have to see. We'll see. Probably not, if I had to guess. So the next thing I will be streaming in a few days, maybe, should be doing another programming assignment where I'm going to be doing some 3D graphic stuff. Actually, I can find the first thing I did to do with that. Got this over here, not there. This one, this one, this one. Making, what is it? Making this, but through code. not completely from scratch. Oh, okay, for the record, this was like, the assignment was make this, and then I wrote code in it, you know, produced this, so, or other way around, I think, but, the fact that they're the same, that's like, you know, a good thing. The next thing will be more complicated, I think. I think it's going to involve more, like, curved, spherical stuff. So we shall see how that goes. But I got other things to finish first. That thing is due next Thursday. I have till then to get that done. Oh, so busy. Busy, busy, busy. But once that's all done, then I'll have some more free time for more other things. Like, which I don't know if it's going to be... The immediate next thing I'm working on, I don't know if that's going to be... Well, it's going to be one of these two things, probably. I don't know which one. We're going to see. The thing is, a demo of this needs to be done by the beginning of March. I think it's like March 8th or something. Whereas this needs to be done by early April. So... Like this, yeah, it needs to make a lot more progress to get there. And also, this is a group project, and this isn't, so that also factors into things. But we shall see how all that goes. Anyways, though, I think I'll stop that. But yeah, I'm glad with how productive this has been and how well it's gone. With finishing this thing. It took longer than I thought it would. But that's because of how complicated it was. So that's just how it was. But yeah, got it all done. And how much code did we write by the end of this? 248 plus 452 with lots of spacing and comments and all that. And some of this being some of the same. And some of it could maybe have been more optimized and, you know, turning more stuff into combined functions. But I think it's quite all right how it is. Oh, wow. What time is it? It's like 2 in the morning. Great. All right. Well, yeah, I better get going. So yeah, that'll, oh wait, rating someone. The first time ever I've remembered twice in a row. Actually, Dr. Vito, okay, there's only 2 people, and okay, one of them's you, Dr. Vito, and one of them's me on my phone. So actually, maybe not. I've remembered. That counts for something. But okay, I'll raid someone if I have more than one other person. Dr. Vito, you go find some other streamer out there and tell him I sent you. No, whatever. Anyways, all right, yeah, we'll end things off here, and then next time I think we'll be doing more the graphical stuff, which I forget what programming language that's going to be in. It's actually, I can see, I just had it open. 1 second. I keep going to end things off, and then I keep not doing that. Oh, that's also Python. Oh, I forgot I did that in Python. That was like a month ago. Still, okay, so we got more Python ahead of us. Well, I'm warmed up from this. Although I think that one will be easier, if I had to guess. But I could be wrong. We'll see. Anyways, I think, yeah, I will actually end things off now. All right, so that'll do it for this live stream. If you liked it, look forward to more. Thank you all so much for watching, and as always, I'll see you around. Bye.